the way that he put it. I was working on an analogy to describe kind of the Web 2 dilemma, and hopefully this isn't too soon, but one analogy that kind of made this stick for me a little bit is that if Web 2 is someone sneezing on you during the pandemic, and Web 3 is a properly fitted N95 mask, then Web 2.5 is kind of like a chin diaper, right? And like I know there's a lot of different opinions and ideas on the efficacy of mask mandates, et cetera, but I think we can all agree that the chin diaper really didn't make a lot of sense. And that's kind of Web 2.5, right? It just doesn't make sense. It's sort of it's incongruous with the goals of blockchain and Web 3. Specifically, it undermines a lot of the value propositions that the Ethereum founders and a lot of the early builders in Web 3 sort of united around in the first place. So being able to build unstoppable applications with composability. When you start building on centralized infra run by single service providers, well then your app is no longer unstoppable. It stops as soon as that platform gets shut down. Once you stop building on open standards, the composability of your applications and of the stuff that you've built goes down quite a bit. And even if there was a standardization on these centralized servers, there's a limit to how much composability you can get when you're building on centralized building blocks, because the more centralized building blocks you compose, the more brittle your system becomes, because now you're basically, if one centralized building block in your giant compose system goes out, well now that ripples to breaking your entire system, as opposed to unstoppable smart contracts running on Ethereum, the way those work, where a new DeFi protocol can come along, integrate with an existing unstoppable DeFi protocol, and that composition can keep playing out until you get this this really rich tapestry of decentralized applications. Definitely hurts for usability if you're just doing one-offs all the time. And then I think on ownership, censorship, resistance, fairness, I'm going to try and paint this a little bit in a few examples. The first is how many people saw the article that Moxie Marlinspike from Signal wrote earlier this year? Okay, like let's say 30%. So he wrote, I recommend you look it up. He wrote a very, I think, well-intentioned, can we get levels down just a little bit? Very well-intentioned, well-thought-out critique of Web3 from someone actually trying to make a good faith attempt at building some decentralized applications in this space. And so one of the things that he did was build an NFT app, and to sort of kick the tires on like the guarantees that we think we have when we're building on NFTs, he basically built a single NFT, but depending on where you viewed it, whether you viewed it on OpenSea, Rarible, or in your own wallet, you got one of the three images shown on the screen. So like when you're actually buying the NFT or looking at it in a collection, you're seeing like this cool piece of artwork, and then by the time it makes it to your wallet, you get a poop emoji. And that's possible because the NFT was not hosted on decentralized data and using a decentralized data supply chain. It was using centralized servers to serve that that NFT. And for a lot of us who are sort of inspired by the ownership vision of Web3, that Web3 is enabling digital ownership, how can we own things when the actual information artifacts that we're owning are controlled by centralized intermediaries? I think this experiment also highlighted another interesting place where we're falling short today. Sorry, we got some clicker. There we go. So this experiment also highlighted a way in which we have censorship in quote-unquote Web3 today, because once OpenSea realized that Moxie had done this, they actually delisted his NFT from OpenSea, which if OpenSea was doing that as a individual application and doing that for sort of their own purposes, and I think that's fine. Like we believe in choice at the level of projects and individuals. But the problem was that so many other projects in the ecosystem were building on the OpenSea API that him getting delisted from the OpenSea application also made it so that the NFT stopped showing up in wallets and all these other places where you would expect to see an NFT that you had purchased, right? So this is a real example of censorship that's happened just this year in the context of the blockchain data supply chain for a use case that we all, I think, care a lot about. Another one, this is a little bit more speculative, but I think it's an interesting one just as a thought experiment, is index or extractable value. This was an idea that was put forth by someone in our community. You can think of this as being a little bit analogous to like MEV, or also payment for order flow, which got a lot of attention this past year or two when people realized that Robinhood's business model for offering free stock trading to retail investors was that they sell the order flow to giant hedge funds like Citadel, and then Citadel, with its privileged access to these to this order flow, can then like extract all this value at the expense of the retail investor. You could imagine a world where if we were all accessing the blockchain, where we expect more of our financial lives to exist over time, and we were all accessing it through a centralized intermediary, that centralized intermediary might gain a lot of alpha from being the one that's seeing the sort of Google Trends style data around accessing and querying our financial lives as it exists on the blockchain. Okay, so that's kind of where the Web3 vision is at today, and sort of the importance of keeping the blockchain supply chain decentralized. Let's talk about where Ethereum is going and the ways in which a decentralized blockchain data supply chain supports that future vision. So for those that saw Vitalik's EthCC talk earlier this year, you might have come across these new, let's call them work streams that are all happening in parallel. So they're not sequential milestones, but they're all parallelized work streams that are happening in the Ethereum ecosystem: the merge, the surge, the verge, and the splurge. And the diagram on the left can look a little intimidating. We're just going to focus on a few aspects of this roadmap, specifically parts of the verge, the purge, and parts of sort of the light client vision of Ethereum. So a brief overview. The Verge, one of its sub-goals is around supporting stateless clients. Stateless clients allow validators to sort of be small and light while having like heavier specialized builders in the right side of the blockchain data supply chain. There's different approaches to this: weak statelessness, strong statelessness. Weak statelessness is where builders sort of provide the witness of state that's being used by a transaction. In strong statelessness, the end user actually, when they submit a transaction, they would also have to submit the state that that transaction is going to access as a witness to the network. The purge is about history expiry as well as state expiry. So EIP-4488 covers the history expiry side of things, which is the idea that after a certain amount of time, in contrast to the way that Ethereum works today, full nodes and validators would be allowed to drop, they'd be allowed to prune historical blocks, basically keeping the storage footprint of these nodes lighter. And then state expiry basically attacks the unbounded state growth of Ethereum, where certain state, if it's not touched frequently enough, again would be allowed to expire. And then light clients, we're going to touch on a little bit in the next screen, but I think they're interesting to bring up here because they share a lot of the same requirements as sort of those previous two milestones, and they're also part of the solution space, right? Because a lot of this stuff boils down to being able to access state and data. But the problem with light clients is that today, at least, light clients rely on altruism from the full nodes in the Ethereum network. So if those full nodes decide to support the light client protocol and serve data to these light clients, then it works out great. But the reality is that because of that lack of incentives, as Piper, one of the researchers working on this, noted, basically the light client protocol in Ethereum is a vast desert of starved clients desperate for data. Historical blocks or pruned blocks from the the blockchain, or expired or uncached state. So in the case of state expiry, it's expired state. In the case of stateless clients, it might be just state that the builder or the user needs that's not cached locally. And the solution space breakdown here, I think can be broken into two larger categories. One is financially incentivized approaches. So we mentioned those light clients needing cooperation from the full nodes, which right now don't have an incentive. So things like the graph, things like Pocket Network could fit into that category. The other category here is using more like tit-for-tat incentives, which are not financial incentives, but this is kind of how like the BitTorrent network works, for example, where if you're being a good citizen in that network, uploading data as much as you're downloading, then there's sort of this reciprocity, that you get. And that's the approach being explored by projects like Portal Network, using things like gossip protocols and DHTs, which again are techniques from BitTorrent and now IPFS as well. And so why are we doing all this? Like, why are we getting rid of all this state? Why are we getting, are we doing it just for the fun of it? No, we're getting rid of this state and this history for a purpose, and that purpose is scaling Ethereum in a decentralized way. So simply put, what that means is being able to fit more transactions into a block, being able to have bigger blocks while maintaining a small footprint for validating clients and light clients. And as an example of this, one of the EIPs that's out there right now is called EIP-4488. It proposes a approximately 5x cheaper, 5x reduction in gas costs for call data. This is about supporting like the Ethereum like rollup, centric future. But the reason that they feel comfortable doing this, which was inevitably going to lead to bigger blocks or more full blocks, is because it's intended to be paired with EIP-44s, which is one of the proposals in the purge, which is, specifies dropping this requirement for full nodes and validator nodes to keep around all this historical blocks past a certain point. So that's what all this really boils down to, is decentralized scalability of Ethereum. Okay, so this last one's kind of a bonus section. I think this is really interesting from both a couple standpoints. One is that the Firehose, which we briefly noted earlier, is a next generation extraction technology. I think it's interesting, A, because I think it should impact the way that Ethereum clients get built in the future. But I also think it's interesting because it's an example of sort of this positive externality coming from an ecosystem that's tackling the blockchain data supply chain in a decentralized open source way, right? So this is Firehose is a technology originally created by Streaming Fast, which is another core developer in the Graph ecosystem. Before I get into how it works, it's worth calling out some of the problems with JSON RPC and the way that it works today. So, most of you, I think, are, show of hands, people that are familiar with JSON RPC? Okay, most people in the room. So this is how you access, data from like a Geth or an Aragon client today. It basically depends on a running program to read data. So if you look at this diagram on the left, you kind of have this fan-in architecture where all the users are sort of hitting a running process. That process consumes CPU. That process becomes the bottleneck for getting data out of the node. And then because you need to have heavier nodes to serve all the data that people want, like archive nodes, potentially running parity trace, it's also incredibly intensive on memory and solid state disks, because in order to actually efficiently access that data, you need to provision a lot of both of the latter. It's difficult to get query intermediate state, so JSON RPC really only lets you query data as of a block. You can get a little bit more by using the parity trace API, but it's still incomplete, also very cumbersome. It can be difficult to debug, so if you're using a subscription to like ETH get logs, for example, via Infura, like we've encountered this in our own stack, that like sometimes in the past, messages will just get dropped due to transient network events or partitions. And there's just no way to debug that. Like you just miss the message, and like it's very, very difficult to figure out that like, hey, a message you should have gotten never made it to you. And there's a pretty incomplete verifiability story. Some of the data you want to get out, you can get a Merkle proof for, but other data, like if you're using like the ETH get logs interface, for example, there's not a really easy way to get a compact proof that says you didn't miss any logs, within some range of blocks. So what's the solution? We think the solution is the Firehose approach. It's streaming first. So if you look at the diagram on the left, data is being as soon as it's available, it is being broadcast out in a fan-out approach rather than this fan-in. It's being distributed as flat protobuf files. So these can be distributed across commodity hardware, and using things like Google Cloud Object Storage or Amazon S3. Because now we have these distributed flat files, now we can start parallelized workloads on those files, all without even touching the blockchain node. So this is much more akin to like what you would see in like a Hadoop big data architecture where you have all these flat files distributed across commodity hardware, and then you have these compute clusters that can be scaled independently and spin up concurrent and parallelized access for doing the sort of transform steps on that data. And so when you do that stuff, you get, compared to the approach of using JSON RPC today, you get a 1 to 2 order of magnitude increase in read performance based on the use case. There's a couple integration strategies that I'm going to move through here real quick. The first is just integrating this as a drop-in replacement for JSON RPC. Basically have it be something that runs locally on the node. When you're running your node, instead of accessing via JSON RPC, you would be using sort of like the Firehose stack. And that's kind of like a really basic integration. But in the future, you also might want to actually improve the verifiability guarantees that you get from Firehose. So you could imagine sort of the Firehose instrumentation logic running as a WASM process that is implemented as a read-oriented rollup, so like an optimistic rollup or even a ZK rollup that actually gives you some guarantees on the validity of the sort of data that is extracted through that Firehose instrumentation process. And then the final approach that, and again, these are still very early in us thinking about this, but the final approach is you could even potentially integrate Firehose files into the consensus process itself. Now, you probably wouldn't want to do that initially, because initially there's a strong benefit to having what's called like data agility, being able to evolve the schema, evolve the instrumentation logic based on sort of a changing understanding of what's needed. But as those integrations stabilize, there might come a time and point where blockchain core developers decide to say, hey, we'll reference maybe the Firehose files from the previous epoch at some future block, right? So that they're actually, you have some guarantees natively in consensus. I'm happy to announce that actually we have our first example recently of a blockchain core development team self-serving their Firehose integration. And I think this is going to be really important for every blockchain core development team, especially and including the Ethereum ecosystem, to eventually own their Firehose deployment so that they can sort of maintain that for their own use cases. And then that also has secondary benefits like basically automatic integration with protocols like the graph. There's another integration story here related to EIP-44 called shim clients, but we're out of time, so if you're interested in that, feel free to come up to me and find me afterwards. Highly recommend checking out Alex B. from Streaming Fast's talk this week on substreams. And then also Vincent from Masari has a talk on standardized subgraphs, but they're heavily using Firehose and substreams as part of their dog fooding. So yeah, thank you guys very much. That's my talk. Do we have time for questions, or? I guess we have time for a couple questions. We have a mic in the back.
Is there a published specification for the Firehose?
There's pretty detailed documentation. I wouldn't say it's at the level of like an IEEE spec or anything like that, but there's very detailed documentation on the architecture, how it works. The repos are open source. So if you just search like Firehose, the graph, docs, you'll find it real quickly. Yeah, Dave in the front.
So thank you. For the stateless clients in like EIP-4444, is there any way to estimate or predict like how, like basically what I'm trying to understand, like can the graph network itself as a whole essentially like earn income from providing a service of like, basically the current Ethereum nodes retiring the state, but then graph nodes serving up that, and then as a whole, like the network getting some profitability from that?
Yeah, it's a really good question. So this is, these are sort of emerging ideas in our ecosystem, but like increasingly my view of the graph is that it is going to be like a multi-service ecosystem. So like today, the primary service is, you do ETL into a subgraph and query it via GraphQL, but there might be a range of services, for example, accessing Firehose data directly or JSON RPC data directly or data in a key value store or a SQL store. And I think all of those could potentially be supported side by side in different like namespaces, if you will, within the graph ecosystem. And in that context, then you could imagine, yes, graph indexers and service providers being the endpoint that like light clients use to get their data. It could also be what blockchain nodes themselves use to hydrate data and some of these other related to these other milestones. So yeah, I think it will be a source of query volume in the future on the graph. Yeah, great question. Cool, I think that's it. Thank you guys so much for your time and attention. Oh, the clicker's up there, is that okay?
Upcoming Mud, an engine for on-chain games, announcing Alvarez, Justin Gilbert, and Kevin Fincher.
Ah, okay. Yeah.
You recommend?
Hello, hello.
Cool. Let's wait like 30 more seconds. Yeah, time's running. Cool. Doors are closed. We're ready. Good morning, everybody. My name is Justin, and along with Alvarez and our friend Kelvin from Optimism, we're going to go over new technologies for on-chain gaming. So Alvarez and I work on Lattice, among with many others. It's a project that's spun out of 0x Spark in order to push the envelope of on-chain gaming. We basically want to enable people to build crazy things on top of Ethereum. And things like full-on virtual worlds whose rules run on the EVM and whose state is secured by Ethereum. People usually refer to those projects as on-chain games, but we prefer to call them autonomous worlds because we think it goes well beyond gaming. It's about giving autonomy and sovereignty to complex systems. So the problem is building large on-chain projects is actually really hard, which is why today we're going to go over two new key pieces of technologies built by Lattice and Optimism in order to enable autonomous worlds. And I'm going to pass it to Alvarez to go over the first one.
Cool. So the first key piece of technology that we want to introduce today is MUD. MUD is an on-chain game engine, or how we like to call it, an engine for autonomous worlds that we develop here at Lattice. And when we started working on on-chain games, there was no engine to build upon. So we had to run through all of these very common, very general problems, very non-trivial problems as well, but they were common in all the games we were building. So we set out to build this key missing piece of infrastructure and build MUD with the goal of solving all the hard problems of building on-chain games. So what are the hard problems of building on-chain games? Well, they fall into mainly three categories. The first one is how to make sure that your client and your contract state are always in sync. Then the next one is how to architect your game in a way that makes it easy to add more content later without having to refactor the entire code base. And then the third thing, if you care about impact beyond just an individual game, then how do you make sure that your game is interoperable with all the other games out there? So before I go into how MUD solves all of these problems, let me quickly go over the previous common approach of approaching these challenges. Usually, the most common approach before was you have one struct per entity type on your contract. Like, if you want to have a monster, then you have a monster struct, and in that struct, you store all the data for that struct, for that entity. And then, of course, on the client, you have to replicate that interface in order to represent the state there. And then you have getter functions for each individual type of entity that you want to sync to your client. And you implement your logic based on these specific structs. And every time you modify one of these data structures, you have to emit a custom event that then can be called by the client to then update the local client state. And this sounds already pretty annoying, but it gets even more annoying when you want to now add content, because now you have to add a new struct, and you basically have to edit your entire network stack in order to make it compatible with this new struct, from the events over the getter functions to the event handling on the client. You have to modify everything. And then on the interoperability side, basically all you have are existing interfaces like ERC20, ERC721, etc., which were not built for on-chain games and are very limited in what they can express, right? So our goal with MUD is to solve all of these general problems so that you as game developers, on-chain game developers, can just focus on making a fun game. All right, so this is for the why. Now let's go into the how. How does MUD solve these problems? MUD is built around an architecture pattern called Entity Component System. This is a very popular pattern in the traditional gaming industry for a reason. But if you're not familiar with it, I'm going to give you a brief crash course on ECS. In ECS, an entity is just a numeric ID. So in our case, it's just a UN256. And then you have components. You have components you have components that store the data for this entity. So in our case, we could have a component that stores the data. You can think of it as a mapping from the entity ID to the component value. You can think of it as a fancy standard Ethereum mapping. And then you have the systems which implement the logic. So components are only data, systems implement the logic. And systems don't act on specific entity types because there are no specific entity types in ECS, but rather an entity is just the collection of components that are attached to it, basically. And so your move system, as an example, doesn't care about whether it's moving a donkey or a dog. It only cares about whether this entity that it is moving has a position component attached to it, and then it can modify that position component. And if you think about it, that's actually, in a way, how Ethereum already works today. You can think of addresses as entities, and then a token contract, like a ERC 721 token contract, can be thought of as a component and a system mixed together and attached to this entity, to this address. If you wanted to model this in pure ECS, then you would just have a balance component that stores the data, and then a transfer system that implements the logic of transferring stuff. All right, so with ECS in mind, how does MUD handle the state sync? In MUD, there's a very central contract, the world contract. And every time you add a contract, every time you add a component, which is also a contract, it gets registered on the world contract. And then every time that component gets updated, an event is emitted automatically through the world contract. That means the client only has to listen to this one central stream of events coming from the world contract and can then keep the local state in sync, basically. And the great thing is with MUD, you don't have to worry about any of that because MUD handles all of that for you. What you have to do as a game developer is just create a component contract, give it some ID, and then create a component on the client and give it the same ID, and MUD handles the state sync automatically. And the great thing with this general approach is also that we can provide generic indexes that help your client catch up faster and reduce their RPC load. And you don't have to write any custom subgraphs because all the data is stored in a very generic way. And that's why we can have indexes. Cool, now to the fun part of adding content. As a quick reminder, in ECS, entities are just a collection of components. So our fighter entity here is actually just a collection of a health component, an attack component, and a movable component. And now if we want to add more entities or stronger entities like a dragon, then we can just modify those component values, give it more health, give it more attack, and suddenly we have a dragon. Another way to add more content is to modify or recombine existing components together. For example, remove the movable component, and suddenly you have a defense tower. And the last way of adding content is adding new components. Every time you add a new component, the number of possibilities of combining your components actually doubles. So you can just recombine your components in a new way. You have double the amount of entities you can now represent. As an example, you add a healing component. Now you can build a healing shrine, a healer, and a healing potion without changing any of the existing logic. And then when it comes to interoperability, in theory, everything that you build on chain is interoperable to everything else already. You just have to make a custom integration for everything, which gets obviously kind of annoying and is not scalable. So in other words, interoperability needs interfaces to scale. And you can think of MUD as an interface for those on-chain worlds. You can read the state from your own world in the exact same way as you can read the state from other worlds. So all those worlds are just by default interoperable with each other. And you can think of existing interfaces like ERC 721 as an interface for ownership. But MUD, on the other hand, since every component is a standardized way of storing the data and we have the standardized query system, basically MUD is an interface for anything. You can just write a query for any world out there and just represent whatever you want. Basically this query, this very simple query, gives you all the movable attack entities owned by this address, but you can get arbitrarily complex with that. So this is how MUD solves all the problems for building on-chain games. But the great thing for MUD is that it's actually completely genre agnostic. We built 2 different games in-house at Lattice over the last couple of weeks, 2 completely different genres. The first one is called Sky Strife, and it's an on-chain RTS. The goal is to build your army, to defeat your opponents, and then steal the loot from the center of the island and then escape with the loot as the first person. It uses 39 components, 20 systems, and not a single line of networking code because MUD handles all of that for you. And we're actually going to play tonight or not tonight, this afternoon at the Hacker Basement at 4 p.m. So if you want to check it out, come there. And then the other game we've built is yet to be announced. It's an on-chain voxel game. It features an infinitely procedurally generated world. You can mine, you can build stuff, you can craft stuff. And it only has 8 components and 7 systems. And also here, 0 networking code. And those 2 games are completely different genres, but they build on the exact same infrastructure. They just use different components and combine them in a different way. Yeah, and this is MUD. As a summary, with MUD, you don't have to write a single line of networking code because MUD handles all of that for you. Adding content is completely trivial. Adding a new component doubles the amount of entities, the types of entities you can represent. And any MUD world is by default interoperable with any other MUD world. And that is how we solve all the problems.
Cool. All right. I'm going to drop some more crazy stuff. Full nodes are great. So after this short introduction to MUD, I want to go over 2 kind of advanced features / mental model from what MUD is. So the interesting thing with full nodes is that they give you access to the entire chain directly from the node database. With a node, you can do things like, oh, what is the counterfactual of this? Can I execute a transaction but slightly change the storage of that contract? Like, what would happen if I were to make a transaction on Uniswap and I have 1 billion DAI instead of 10? The problem is that traditional dApp clients today are not full nodes. They rely on things like Infura or Alchemy to serve their data, and then they have to build this complex state machine of indexers and events in order to serve the data they need to their users. As an example, the Uniswap client has to connect to a full node, and it has to fetch the state it is interested in just in time, because otherwise it would take way too long. So as you move around on Uniswap and you select different pools, you have to wait every single time to know what's going on. I don't know if you've ever read the Uniswap client code, but it's pretty insane just to be able to keep such a short, a simple state machine in sync. And there needs to be a lot of custom code and indexers. Additionally, the Uniswap client cannot actually simulate transactions. It doesn't know what will happen if you execute that single swap. So the way it actually works is you have the Uniswap client, and then remotely you have a full node and you have a bunch of indexers. And the Uniswap client has to make very slow network requests in order to be able to populate the information that the user needs. So why don't we put the full node and the indexer inside the client, right? That would allow you to make instant queries. You would be able to index the chain however you want. You don't have network delays anymore after you're synced, and then you can simulate transactions, right? That would be amazing. And actually, for the Ethereum OGs here, that's how Mist was working, which was the Ethereum browser 5 years ago. But the thing is, full nodes are super expensive. They require a lot of bandwidth and storage. They have very expensive cryptographic data structures that are needed in order to serve light clients. So it's pretty much it's not really practical today to put full nodes in the clients. And so because of that, most dApps today, if you use DeFi or whatever kind of stuff, usually they have UX hurting network calls. You have to wait a lot for every single thing. You have to wait for the TX to be mined in order to know what the side effects of what you have done actually is. There are services today like Tenderly and stuff that allow you to simulate transactions, but they add additional complexity to the code base. And more often than not, they need to use remote indexers, which add yet another surface of things that can possibly go down in complexity. So can we do better? Now that we have slightly better infrastructure than when Web3.js and Ethers.js was invented, is there a way to essentially have our cake and eat it too? The one interesting fact about autonomous worlds or on-chain games is that they're more often than not standalone, unlike traditional dApps. What that means is that the state transition function of an autonomous world almost always only depend on its own state. So as an example, when Darkforest was running on XDAI, Darkforest could have run on a chain with nothing else but Dark Forest. Dark Forest didn't care about the other things on XDAI, right? That's unlike most dApps today, which rely heavily on a plethora of different services on chain that they connect to, things like oracles, things like ERC20 contracts, and so forth. And again, this is unlike, as an example, Uniswap, where if you were to want to simulate the transactions of a Uniswap trade, you would need to know about the other smart contracts, like the ERC20s on each side of the pool, because they could be implemented slightly differently. So one mental model for what MUD is that it's a namespaced full node, which is why we think this goes well beyond gaming. It's a way to build actually better clients than what exists today. And the reason we can build a namespace full node is because, as I said earlier, autonomous worlds are mostly standalone. So MUD syncs a world, the word contract that Alvarius talked about. It's a namespace for data and logic. So data are components and logic are systems. So MUD can sync the data of every single component connected to every single entity and download the EVM bytecode of every single system. And the way it does it is it does its initial sync via a general MUD indexer or a full node, and it keeps its state up to date via a full node or a MUD stream service. MUD doesn't need the cryptographic data structures that are usually in a full node because we don't want to serve light clients. We just trust a node remotely. But what we want to be able to do is build extremely snappy applications by having the entire state in logic client side. So the thing that is interesting with MUD is that components are self-descriptive. Components have on-chain schema that explains how to interpret their actual row bytes. And so the MUD client can read the on-chain schema. And so compare that to a full node. With a full node, you know the actual storage slots of every single contracts, but then you just have 256 bits of you don't know what that is. This is why people write view functions in their contracts in order to be able to load actually contextual data from those applications. With MUD, what you get is a key value database of entities mapping to a bunch of components. And it doesn't matter who deployed those components. The client just knows what they are. It knows what their name is. It knows what their structure is. So as an example, when you sync a MUD full node, so a MUD client, you would know that the first entity, 0x0, has position 1245 and health 200. So it's way more contextual than the way full nodes are done today. It's because, Ethereum is trying to be as general as possible, whereas here we impose constraints in order to get features. This allows a client to run complex queries on components without any network delay. So you can run aggregated queries like, oh, give me all the entities that have a position and a health with value 10. You can do crazier stuff like aggregates and stuff like that, but all of these are executed instantly in 1 millisecond on the actual state. So if you were to rebuild Uniswap with MUD today, or at least the Uniswap client, you would be able to move around and do things without any network delay when it's synced. And downloading the actual snake snapshot usually takes less than a second. So the other thing that is pretty interesting with MUD is that it ships with a local EVM. So when you make a transaction in MUD, that is when you call a system, what MUD does is it runs an EVM on that system, given it knows its bytecode, and it injects the ECS state when that actual EVM bytecode needs to read the state. It registers all the side effects that happen. So as an example, if you were to call the move system on entity 1 and you say move to x10, y minus 3, MUD can run that into an EVM and know that the side effect is that oh, no, the position component of entity 01 is 10 minus 3. It also sends the transaction on chain, of course, and then when the transaction has been mined on chain, it compares the side effects that happen on chain with the one that were predicted. If they match, nothing happened. And so from the user's perspective, it seems like the transaction was essentially executed instantly, which gives way better UX. And when it's not the case, when the prediction fails, so as an example, if someone else clashed with our state, by having their transaction execute before ours, or if we're behind the tip of the chain, we just revert the side effects and apply the actual ones. But that happens quite rarely, actually. This is how modern MMOs work. They do prediction and rollbacks all the time. So yeah, with MUD, you can essentially read and index components without network delay, client side, and you can also simulate transactions without waiting. And we think that, we think that this actual increase in user experience is pretty insane. We've seen it for games because that's what we were trying to do, but I can't wait for someone to build a DeFi protocol in MUD and make it the snappiest swapping protocol ever. Another thing I'd like to talk about is this concept of extending worlds with MUD. So today, with fully on-chain permissionless app, things like Uniswap or Dark Forest, developers can extend the protocol via new contracts and custom client, right? That's the power of those applications. So as an example, in Uniswap, you can build an LP liquidity mining program on top of Uniswap permissionlessly. You don't have to phone the Uniswap company in New York to ask if you can do that. Similarly, with Dark Forest, you can create smart contract players or new features. However, the problem is that developers that do that, they need to ship new clients and indexers when they do that. So as an example, if you want to build a yield aggregator, not a yield aggregator, a swapping aggregator that finds the best prices, well, you need to build 1 inch. You need to build a new client. Also, users need to know where those new features are. They have no idea that someone out there built new contracts and new features for that specific DApp. And that actually creates a clear distinction between first-party code and third-party code, which, in our opinion, greatly hurt interoperability and creativity. So, as an example, in Dark Forest, you can do something like, hey, I'm team XYZ, and I'm going to deploy a thing that marks some planets as rewarding, and if players captures them, they get some ETH. That's pretty cool, you can do that. But now, how do users know that this exists, right? Like, where are the contracts? How do you, like, even if you had that information in your client, how does your client know what to do with that data? Does it render a button? Does it trigger a shader? Similarly, you probably have to rebuild all your indexers from scratch. So you get a fragmentation, essentially, between first-party code and third-party code. So again, can we do better? In MUD, the central contract is the word contract. If you know the address of the word contract, you know everything. You know about all the components, you know about all the systems, you know about all the entities. And the thing that is interesting with the word contract is that it actually has no owner. If you deploy, so it has no owner, it's permissionless, and so that means there's no difference between first-party code and third-party code anymore. Everybody is first-party. So the creators of the word contract, the deployers of that contract, actually have no special kind of access to it. They're not privileged in any mean. The word contract is non-upgradable. So the rule is anyone can create components and systems. So when Alvarez was talking earlier about the health component, and the position component, and the move system, anyone can register those components in those systems on the world itself. And when you do that, when you create new components, that is like new data, or new systems, that is new logic, they're accessible in the client, they're indexed, they can be found in the debugger, they can be executed in local EVM. And there's actually no difference between like what the core team deployed and what like any other people did deploy as well. So the rule is that all systems can read from any components. So and those components can be deployed by different teams. So as an example, you could write a system that runs a query on the world that queries a component deployed by team XYZ and a component deployed by team TTT. And they can actually aggregate those data together. The only rule is that components have to whitelist which systems can write to their state. And that's really important because otherwise an attacker could deploy a system that just resets everybody's inventories. So the way it looks like is you have this like graph of components and systems that kind of like trust each other, but also you have this interesting social phenomena where users of those applications decide what is real. So if you have two position components that like don't match with each other, the users have to decide, okay, do we believe in position 1 or in position 2? And that's already what happens today on Ethereum. If I deploy a new DAI contract, my DAI is worthless. So it's all based on essentially what you think is real. But it is made in, like, MUD is architected in such a way that you never have the problem where you need to create some form of like, oh, like we need to like give our upgrade keys to a DAO in order to let our players upgrade it. No, this can emerge naturally, essentially, from the web of trust of the players themselves. And this leads us into like an interesting kind of like idea of augmented reality. So this is not the augmented reality you know with fancy glasses and hardware. It's more about layering base rules with new interpretations. So beyond the core components and systems all players believe in, probably the ones that have been deployed by the core team, the low-level physics, it is possible for anyone to create augmented reality layers that only a subset of players engage in, and that permissionlessly. So we're going to illustrate this. Imagine a game. It's a very simple game. It was deployed by like one core team. It has 3 components: position, movable, and resource. It has 3 systems. You can move, you can pick up a resource, or you can drop it. And you can see there are 3 players there: 0x01, 0x07, 0x05. There are little characters riding horses, and you have a bunch of resources on the floor. What players do is they can ferry resources around. This game doesn't actually have any goal. It's just some rules of physics, essentially. And like as an example, I can call move on my player, and I would move my horse from one place to another. Now, team TTT, team tic-tac-toe, comes in, and they deploy 2 new components on the world because they can. You know, they don't have to ask anyone. Those 2 components are the stake component and the board component. And they add 3 systems: challenge, accept challenge, and resolve. Now, all clients are aware of those new components and systems. They just don't know what to do with it yet. If you open your game at that time, you'll see a little install box. It's like, hey, there is some piece of JavaScript that is linked with those components and systems. Do you want to use them? If you do, now you can play a radically different game while still being compatible with the low-level rules. So as an example, I can take my player, I can move to the gold at 0x03, I can pick it up, move again, and I can come next to that player at 0x07 and call the challenge system on that player. That challenge system is new. It was deployed by the team tic-tac-toe, and I attach 1 ETH to my transaction. The other player, if they're aware of that augmented reality layer, can accept the challenge, stake the same amount, and now this new system is going to create a new entity, 0x09, because anyone can create entities, and attach the stake component and the board component to it. So now, for the players that have the actual code that allows them to experience the tic-tac-toe augmented reality, they can see a board on the floor, and now they can play tic-tac-toe. They can drop the resources in order to play tic-tac-toe, and someone can win. They can call the resolve system, and they can take the stake and destroy that entity. And you can do that without clashing with the rules that all other players believe in. So tic-tac-toe is just like tennis. Like tennis is an augmented reality layer on top of our physics. I can drive in my car and look at tennis players, and we're not breaching the rules. Like we're all like living according to the same rules, but we're just like experiencing the world in different ways. So it's an augmented reality. And from the perspective of other players, they're just like, what the hell is going on? Why are people dropping resources on the floor on a grid? But they can still coexist together. So there are a lot of augmented reality out there. The main one is capitalism. It was made up. We all wear the glasses that allows us to see capitalism. But I can interact with an anarchist that doesn't believe in money. I can go and like have dinner with them, and we won't actually experience the same augmented reality, but we share the same low-level rules. Competition is also an augmented reality. The thing that is interesting with this game is that it has no goal. Some people just made a set of interesting rules and resources, but now anyone can come in and essentially puts a competitive layer on top of it. Minigames are also augmented realities. So for the people here that have played Minecraft, in Minecraft servers, a lot of people build minigames. You know, you have to break the wool underneath people's feet and fall into lava. Those minigames actually don't clash with the rules of Minecraft. They're just like new systems that have been created on top. And you can do that permissionlessly. You don't need a governance for the world because the world is onerous. Anyone can deploy new components and systems, and players believe in whatever components in the system they care about. And now I'm going to pass it to our friend Kelvin, who is going to drop some more cool stuff.
All right. Hello, everybody. How you doing? How you doing? So you want to build an autonomous world? Good luck. Good luck. Have fun trying. Just kidding, of course. I'm going to be talking to you today about the OP stack. Technically, we were originally hoping that this talk would be after the other talk about the OP stack, so just pretend that you're 5 hours in the future, you've watched the other talk, and you know, whatever, time doesn't matter anymore. So introducing the OP stack, except Carl has already done it 5 hours from now. Kinda. We still need to write all the docs, so if you want to use this, you're going to have to dig deep a little bit. You can talk to me afterwards about how you can actually achieve this. But all right, introducing the OP stack, I want to talk to you a little bit about basically how you can achieve this, build your own system today, and get really good security guarantees at the same time. All right, so boom. What is the OP stack? Essentially, the OP stack is rollups gone modular. Over the last year, we've been designing and building this thing called Bedrock, which is the next major upgrade to Optimism. And while we were doing that, I think we realized that the key part of building a solid rollup client was to make it as modular as you can possibly make it. And we'll talk about this a lot in the talk later today, the back-to-back talk that I have with Carl. But we kind of realized at a certain point that if you really want to maintain one of these things, you can't allow different parts of the system to bleed complexity into other parts of the system. And the classic example that we saw over the last 2 years was we separated execution from proving. This was the big thing. This is what basically Optimism's EVM equivalence upgrade, Arbitrum's Nitro upgrade, they all follow the same pattern, which is let's build the client the way that we want to build the client, and then let's make execution work on top. So the end result of all of this over all this time is that we've broken up our system into a highly modular system with lots of different pieces. We think that there's 3 simple layers that kind of follow what you think. Oh, there we go. Look, you've seen these things before. Consensus, execution, settlement. You've seen these things before. If you've heard anything about modular blockchains, you kind of have an idea of what the OP stack is all about, except the OP stack is putting this modular theory into practice. So the real difference here is It's not just charts on a blog post about, okay, if you plugged in this data availability layer, you get this behavior, and if you plugged in this data availability layer, you get this other behavior. Instead, it's actually concrete components that you can implement and you can switch out to get the behavior that you want. So I'm going to talk to you about the core concepts, the different components that you can switch out, and sort of what you might do if you wanted to build a game to use these different components and do something really interesting. So the first layer that we like to break out of these different, there's obviously the three primary layers. Inside of consensus, we think of two sub-layers quickly here. We've got what we call data availability and derivation. But I'll start with data availability. So you've probably heard about this. You probably have a basic idea of how this works. Data availability is where you publish your data, right? So the idea is, well, people don't always want to publish their data to Ethereum. All the rollups originally were built under the idea that, okay, we're always going to publish our data to Ethereum, so let's just build our architecture under that assumption. And so the OP stack basically says, well, actually, whatever. As long as you kind of have an array of blobs, that's what we call them. They can be blocks if you're Ethereum. They can be blocks if you're Celestia. They can be all sorts of different things. But essentially, what you want is an array of things where you can publish data to. And ideally, you have some properties about this data availability layer. Ideally, it's somewhat immutable, otherwise the whole thing is just going to keep reorging itself, and that's going to be really annoying. Ideally, the data is actually available, otherwise you can't do anything with it. So there's some properties that you want about this. But the nice thing is the OP stack basically says, well, whatever. You can define any data availability layer as long as it fits this basic idea that it's an array of byte strings. You can slot it in as your data availability layer. So concretely, what can you do with this? I think the easy example is instead of putting all your data onto Ethereum, you can use something like a data availability committee instead, reduce your costs, make your system cheaper. I think this is a really good application for gaming because you don't need those sort of ridiculously high security guarantees that you do when you have a basic rollup where you're just putting data on Ethereum. The ability to switch this out for a data availability committee or a different data availability layer altogether is really important to get the exact sort of security properties that you want depending on the amount of value that you actually need to secure. All right, derivation. Derivation is interesting. I think derivation is one of the coolest parts of the OP stack design, and essentially the idea is that derivation is how you are pulling inputs for your blockchain from the data availability layer. So derivation is basically like a function that's aware of the structure of the data availability layer. It's like, let's say we're putting data on Ethereum. It's aware of the block structure. It's aware of how data is put onto Ethereum. And it parses that data, it pulls it out, and it turns it into inputs to your layer 2 execution engine. Derivation is really important, and it's, generically you can understand why this is important. Let's say we're a roll-up. The same thing that we're doing for unannounced game will be announced soon. If you're one of these systems, what you do generically is you post data to an address on layer 1, and maybe you have deposits, and maybe you have some other sort of information, and you transform all of that. Maybe, if it's data posted to layer 1 by the sequencer, let's say you decompress all of that data, you transform it into inputs on layer 2, and then you're going to execute those inputs. Derivation is really interesting, and I think there's a lot of hidden things that you can do inside of here that maybe aren't always obvious. One of the things that I think people can achieve with this is have in-game events or have events on your chain happen when things happen on the layer 1. So let's say you want to have an in-game event happen every time there's a Uniswap swap event on layer 1 over a certain value. What you can literally do is in your derivation function, you can take our derivation function, you can tweak it slightly, and you can say, okay, I'm also going to look for Uniswap swap events. And then whenever there's a Uniswap swap event, I'm going to generate a transaction on layer 2 that makes this thing happen. And the end result is that in my game, fireworks go off, whatever you want. You can basically modify this however you want to have the state of your layer 1 define what's going on your layer 2. It doesn't just have to be transactions. You can build amazing things with this. And it can be very, very stateful, so you can do a lot of cool stuff here. Boom, execution. Okay, execution is probably what you think execution is. It's your execution engine on layer 2. It's your state transition function. It's the thing that takes the inputs that were generated by the derivation layer, and it takes the current state, and it's going to translate that state into a new state, right? It's going to take that state into a new state, and that state's going to be used to derive new inputs, and it's going to be, you get it, right? Every time I make a transaction and something happens in my voxel game and the world updates, that's what's happening under the hood in the execution engine. The execution engine in the OP stack lives behind the engine API, right? So what we decided to do was Ethereum, while it was going to the merge, needed consensus clients and it needed execution clients, right? So you need a way to talk between the consensus client and the execution client. And that interface between the two clients is the engine API. So what we did was basically take the same API and you stick the data availability and the derivation thing, and you separate that from execution by that same exact API, so it looks exactly like Ethereum looks. The nice thing about this is that you can plug in absolutely anything in here. It doesn't have to be the EVM. You can take the EVM and maybe you can make some easy tweaks. You can add a new precompile. You can tweak a few opcodes if you really want, and that'll just work really easily. In Optimism, in Bedrock, we add a new transaction type. We add this deposit transaction type. That's really easy. But it really can be whatever you want. It could be Bitcoin. It could be a Game Boy. As long as you have a state transition function and you wrap it inside of the engine API, you can do whatever you want, and it should just work. The whole thing should just work. So if you want to build a game and you want to use the EVM and you want to add a new precompile because you have some complicated game state function that's just too expensive to run inside Solidity, then just modify the EVM. If you want to run a totally different execution client altogether, you can also do that, and it just sits behind the same API, and all the rest of the stack, all the roll-up stuff, all the transaction stuff, it just keeps working as if you didn't do anything at all. All right, and then finally, settlement. Settlement is this weird one. It's a little fake. It's, what does this really mean? I like to say that settlement is about establishing a view of your system on some other system. And it's all about making claims, right? I'm making a claim about the state of my system onto another system. And so settlement is really useful, obviously, in traditional rollup. Settlements is really useful if you want to do withdrawals. If you want to be able to move funds out of your rollup onto, let's say, layer 1, you need to be able to settle the state of layer 2 onto layer 1 so that I can say, okay, that is the true state of layer 2. Let me pull it out. Let me operate on it, and maybe I'll give you a withdrawal as a result. But the thing is, you can do a lot of really interesting things with settlement. You don't just have to make claims about, let's say, the total state of the system. I think a really interesting way to think about settlement for gaming is that you can have a short-lived chain that plays some game. Let's say we all want to play a chess tournament, right? We can play a short-lived game, and then at the end of the game, we can all, we see who wins the whole tournament, and we can make a claim, and we can say, Kelvin won the whole tournament. And that's the claim that I'm settling. And then you can have this generic proof system that will just prove arbitrary claims about the state of your layer 2. And so you can prove this idea that, okay, Kelvin won. And then we can resolve that winner back to layer 1, and we can pay that person out. And then we can throw the chain away because we don't need it anymore. So we got this short-lived, verifiable system, right? This game that we know that the whole thing ran as it should have ran. There's no weird state coming out of it. We prove that back to the base layer, and then we can throw the whole chain away, and we don't have to worry about storing it. And so for short-lived, high-capacity games, you can really bump up the gas limit. You can do crazy stuff because you're not worried about state bloating to infinity. And then you can just settle any sort of information about the state of your layer 2 back to layer 1. All right, no sequencer, no problem. Actually, currently a very big problem, but this is just an idea of basically where we imagine this system going in the future. Because there's a big issue, which is that every single time I talk about this idea, somebody comes up to me and they ask me, doesn't that mean you still have to run all this sequencing infrastructure? And the reality right now is yes. But we want to get to a future where the answer is no, right? Because most people don't really want to run this infrastructure. You want to focus on building a game, especially let's say you just want to build something small. You want to run it for a couple of days. You want to put it up there. The reality is if you're I'm sure that the average person does not want to deal with the level of stuff that we have to deal with at Optimism to keep the sequencer running. So we have this concept that we're exploring called shared sequencing. Basically, shared sequencing is taking all the headache of running your own sequencer, and it's deleting all of that. And the basic idea is that all of these different autonomous worlds can share a single sequencer. And of course, when I talk about a single sequencer, you can see there's multiple machines there. I like to think about the sequencer as sort of a single logical entity. But in the future, what's going to happen is you're going to get decentralized sequencing. You're going to have something that looks like a leader election, where at any given time slot, there's a specific sequencer, and that sequencer is sequencing your rollup. And then there's the next time slot, and the next sequencer comes in, right? So the thing with this is you can do something really, really interesting. If you have one sequencer sequencing all of these different chains at the same time, right? Instead of having multiple different chains that are talking to each other. The problem today is if I have, let's say I'm Ethereum and I have Cosmos, right? And I want to interact between a Cosmos chain from Ethereum. They don't share a validator set, which means that my communication inherently has to be asynchronous. But if you have a single sequencer producing the blocks on many different autonomous chains, autonomous worlds at the same time, you can get this amazing property of atomic composability between all these different chains. You basically have a single sequencer saying, okay, there's a transaction coming in on chain A, and there's a transaction coming in on chain B, and I'm supposed to guarantee that they can come in atomically, and I can do that because I sequence all the chains at the same time. So now you have different games, different worlds, different realities that can interact with each other. They're their own states, right? The validation is separated. None of the validity of one of these chains depends on the validity of the other chain. But they can talk to each other as if they're on one unified chain. That's crazy, right? Now I can have an action in one game, all of a sudden create some simultaneous action in another world at the same exact time if those two worlds want to talk to each other. So this is part of something that Optimism is playing with that we're calling the superchain. We think that this extends a little bit more than just shared infrastructure. I think that the incentive here is not just to share infrastructure, it's to share code, it's to share a set of values, it's to basically collaborate on having all of these different games and all these different worlds. Maybe it's not games, maybe it's entirely different roll-ups. But they basically, we think that there's a strong incentive for these systems to not just be able to transact atomically, but to really be able to collaborate with one another towards some coherent vision, because you're much better joining in on this system than you are trying to build your own chain separately with your own sequencer set, and you have to run all the infrastructure, and you don't get to talk atomically with the rest of the system. So, long live the superchain. I would highly recommend, if you're interested in this, how this might work in more detail, come to the back-to-back talk with Carl and me later this afternoon. We'll go into much more detail about how all this works. All right, where are we? All right, so the other question I get is why make it free and open source, right? Aren't you basically just like letting people compete with Optimism and build their own rollup? And the answer is like kind of yeah, right? This is the idea. And the idea, basically the argument is that the reason we have to do this is because there's just no other way to do this. We need, we think that there's going to be this explosion of people who are interested in building layer 2s, interested in building layer 3s, right? We're already seeing all these, big L1 systems come in, and they're experimenting on the execution layer, right? They're competing with Ethereum on the execution layer. They're saying, we're going to build a parallelized VM, and that's our advantage. And if you really want to survive, you're going to need to be able to compete on this stuff. And we think you're going to need to be able to compete on this stuff without having to have 25 engineers work on this problem like 3 years, for 3 years like we did. And instead, you're going to want the ability to have 3 engineers figure out how to do this in 3 months and start a business out of it. So this is basically the argument. If you want to really make it possible for Ethereum to continue to compete and for people to experiment on the execution layer, experiment on the derivation layer, experiment on all these different layers, it just has to be available, right? If there's not a permissive license on it, you can't use it. If it's not modular enough, if it's too hectic to try to hack in your modifications to the execution layer, you can't use it. So the goal is just make it as available as possible so that Ethereum can continue to compete on every single layer of the stack, but you can still stay within the Ethereum ecosystem. And this is us today. This is where we are. We got Lattice. We got a couple other people. And this is the world that we're imagining, right? We're imagining that basically everybody is building on a system like this, and they're collaborating, and they're working on a shared infrastructure. And by working on a shared infrastructure, you share audits, right? You can share engineering time. It basically takes you 100 times less effort to build 100 companies instead of having every single company fragment and build their own system. You basically have all the freedom in the world without actually worrying about the low-level technical details about how are you going to publish transactions to layer 1 reliably? How are you going to deal with reorgs, right? How are you going to make the proof work? Because all that stuff is extraordinarily complicated. There's no reason why every single person who wants to build one of these chains should have to basically build it from scratch. Doesn't make any sense. All right. So some closing remarks here. Basically, go nuts, build something crazy. You can do so much with this architecture, right? You can swap out the data availability layer, make your chain cheaper. You can swap out the execution layer, build an entirely on-chain game. You know, you can literally take an emulator of some system, you can put it into the execution layer, and you can even prove that the whole emulator functioned properly. You can do an enormous amount of stuff with this, and the nice thing is you don't have to worry about how are you going to go build the sequencer, how are you going to go build the proof and all these different things. You basically get all that for free. So that's the idea. Where are we? Yeah, thanks for coming to my TED Talk. Where are we right now? So the code is all there. It's possible to hack on this stuff. The next goal is to take all these modules and make really, really clean documentation so it's clear what you have to change, where you have to change it to make all this possible. If you go in today, you know, Lattice has been extraordinarily brave to go in and basically hack this system together and really make it work for them. And we've seen other people do it as well. If you're interested in doing this, you know, come talk to me later and I can give you pointers. But the goal is, you know, right now it's still a little early. We're looking for people to come in, help us figure out where the APIs aren't clean enough, right? Help us figure out where the documentation isn't clean enough. If you know what you're doing and you're really interested in hacking on something new, like come find me and I will try to help you get started with this whole thing. And the goal is make this accessible to the average person who just, you know, doesn't want to deeply understand how this whole architecture works. So that's me. I'm going to hand it off now. All right.
You want to keep that mic? All right, cool. 3 minutes left. Announcement time. So, just like the OP stack is meant to like essentially increase pluralism by making something free and open source and easy to use, we kind of did the same thing with Mud. Mud is MIT licensed. It's soft launched today. And to kind of like pave the way forward, Lattice and Optimism have been working together over the last month and a half on an autonomous world that was built on Mud and runs on the OP stack. So we're like pretty excited to show Opcraft to everybody. It's a 3D voxel game powered by Mud, running on a crazy degenerate OP chain. Yeah. I even have a video. Well, I will see if it plays. But Alvarez and I yesterday were trying to build a house. So yeah, that's running on DVM, guys. It's a procedurally generated world. I can't wait to see what people will do with that. You can deploy marketplaces, oracles, extend it, build augmented reality, tennis, capitalism, whatever you want. It's going to be open source soon. It's playable today. Let's actually see how we build the house. I remember it was quite hard, given we didn't really have consensus on how it should look like. Yeah, okay, cool. We did it. Opcraft is going to be soft launch and playable at the Autonomous World Arcade at 4 p.m. today at the Hacker Basement. So if you want to play it, come there. Additionally, we're going to have a tournament of Skystrife, which is the RTS that was built with Mud. We have playtested it weekly for like the last month. People really like it. There are StarCraft players that don't even know that it's running on chain. They just like the game. So yeah, we're going to try to hit 64 players. So come along as well. Hacker Basement, 4 p.m. So what about the other stuff? Well, Mud is actually already available. We just don't really talk about it because it's not very documented. It's like the OP stack. It's on mud.dev. The code is on GitHub. We have a bunch of teams building stuff with it, but it's yeah, talk to me if you're interested. The OP stack is going to be announced soon. by Carl at 1:30 p.m. on the main stage. And yeah, that's us. Thank you, guys. All right, we did it. 50 minutes. 50 minutes. Yeah, it was 50.
Good job. Thank you. Good job. Great talk.
Bueno, Carolina, como no viene, entonces, pues, ¿a quién presentamos? Que esté listo. La mayoría ya los tengo aquí.
After this one.
After Carolina.
At 10:40, that's it.
Yes.
You're Hadrian?
Yes.
Okay, you're next.
Yeah, after.
No, but Carolina is not showing up, so you're next.
Okay,
Yeah.
okay.
Sounds
You
good.
need a headset or
But
mic?
we are,
What would you
but are we moving the schedule?
Hello everyone, welcome. Unfortunately, Carolina couldn't make it today, so we're going to go ahead of schedule with our lightning talks and welcome Adrian. Yeah, cheers.
Thank you. So yes, I'm Adrian from Open Zeppelin. Yeah, those are not my slides. Yeah, those are my slides. Okay, so thank you everybody for attending. I'm working at Open Zeppelin, and this talks about like 5 smart contract pattern, but that's actually a lie. The real thing I want to discuss is what I think is a good mindset when writing Solidity contract. And basically the pattern I'm going to show you are more of like examples of what I think can be fun development in Solidity and how I think it aligns with the good development practices. Okay, yeah. So I think one of the 2 main points I want to make today is that a lot of the ecosystem's value is a result of smart contract composability. That's particularly true of DeFi. And the first thing you should do when writing a smart contract is make sure that you are leveraging as much composability as possible and trying to make sure that your contract can interface with all the existing tooling that would be relevant. An example is people always ask us like, hey, can we make an ownable contract payable, like someone could buy it? And this makes really no sense because there is already a lot of tooling for buying assets, and that's the NFT space. In the NFT space, you can just buy anything from OpenSea or Rarible or any other marketplaces. And we don't want to redeploy that for the ownable contracts that exist. So the idea is that when ownability is just like the ownership of a contract in order to have access to it, to some admin functions, well, you could just turn that into an ERC 721. And this is how you would do it. Basically, you can very simply say like, hey, my owner is just the owner of a specific token on an ownership registry, and I can have an owner modifier for that. And when I want to transfer ownership, the only thing I will have to do is go to this ownership registry and try to transfer the corresponding token. Now, on the ownership registry, you would have to override the isApproveOrOwner function to allow that, but that's very easy to do. And so here in this example, you have a vesting factory. This is actually live on mainnet. And when you want to deploy a new vesting wallet with a beneficiary for it, well, here the beneficiary is just the owner of the NFT on this factory. And when I deploy a new contract, I just create a new clone, I initialize it, and I mint the token. And that's the equivalent of my owner if the contracts were ownable. The difference is here, my contract show up on OpenSea, and I can basically sell it or transfer it very easily. If you want to go a bit further, you can even have like a universal address ownership registry, which I think is pretty fun because it allows you to get rid of the minting part by just saying that, hey, by default, all the tokens are already minted and they are owned by the address that corresponds to the token ID. I mean, all the tokens ID that matches an address in hexadecimal form. And then you can just say that, hey, it's not possible to burn them. You would just send them back to the original owner. And there is this isApproveOrOwnership that I'm doing some fancy stuff with codes, but you don't need to care about that. And this can just be another approach that I think it's nice, and it shows creative use of ERC 721s. And another thing we use is that ownable obviously is something that a lot of people are familiar with, but the granularity is really bad. Sometimes you have different admin functions in your contract that you want to have different access for, and access control does that pretty well. Access control is provided by Open Zeppelin. The thing is that access control is maybe a bit more difficult to work with because you cannot transfer a role. You need to grant it to someone else and then either get it revoked or renounce it. And so it's very nice for some users, but at the same time, ownability has some advantages. So let's just combine both. Let's just make a contract that has an owner, and the owner is basically the default admin role, and then you just cannot grant or revoke this default admin role because that's controlled by the ownership part, but the owner still is the admin, so it can grant any other one. And this, here it's ownable, but it could be the ownable registry that we showed just before. So you could have a contract where the owner is the NFT holders, and then you have all these access controls that are managed in that way. Or you could be creative and use ERC 1155s here. And so yeah, that's just some small ideas, but it's not very complex code. I think everybody can understand that. But the point I really want to make is that you can combine tooling together and combine contracts to make sure that everything is basically as seamless as possible. The second thing I want to present quickly is that the ecosystem is constantly changing, and basically when you write a contract, I mean, you can make your contract upgradable, but even without the upgradability part, you really need to care about what is going to be the life cycle of my contract, and are there small tricks that I could use that will make my user's life better in the long run. And that's for the users, but also for like the UI designers or basically anybody in this space. So these are just two small pieces of code, like 0.4 and 5, that I came up with very recently, and I think that's things that are interesting because we never expect a hard fork to happen until it actually does, and people start trying to do a proof of work blockchain, and then the bridges that are on this proof of work chain starts breaking, and that's a pain. So you could imagine having this very small piece of code here that basically takes no size on chain, that just gives you two modifiers that verifies that the chain ID that you're currently using is the one that was registered in immutable storage when the contract was deployed. And then you could do that to create some kind of bridge where actually most of the function remains completely trustless with this only initial chain modifier. But if for any reason there were to be a hard fork, the version of the bridge that is on the chain that changes the chain ID, then all those would be automatically disabled, and you get into recovery mode when some like multisig would be able to take over. And this multisig is not a threat for the user on the legitimate chain, because of this only fork chain, like this admin cannot do anything nasty to your users. But that's an exit point that would have saved some pain. I mean, it was on the proof of work chain, so maybe we don't care a lot, but who knows? Maybe there will be more legitimate forks at some point in Ethereum's life cycle. And another one is that that's something we provide as OpenZeppelin, and that's what we call the multi-call contract. And that's very simple. It's just one endpoint, one small functions that allows you to delegate to yourself with an array of data. And that's very easy for you to integrate into any of your contract, and I don't think there is any reason not to do it. And the way it's being done is, earlier we saw this example here, and here you have this multi-call that maybe you didn't see because it's red on black, so it's not really visible. But what it allows you to do is, when you want to create a new vesting for one of your investors or someone, well, if you have 10 or 20 investors, maybe you don't want to do 20 transactions that do 20 calls to this new vesting function. So what you do is just that you encode, like you have a map of entry, and you encode the function using like Ether.js or Web3 or whatever you like, and then you just have to do a single call. So there is a single transaction here that you have to wait for, and what it will do, it will basically run like all these operations. So you could deploy 20 vesting at a time, or you could do an approve and something else, or you could batch transaction together. Like, you don't need to wait for account abstraction to batch transaction. You can already do it at the contract level. I mean, providing that the target is the same contract for all the subcodes. And that's as simple as including that. So yeah, keep in mind that there are all these nice tricks that could possibly help your users down the line. And I think it's important to have that in mind when building contracts and try to be creative. That's it. Yes. Yeah, so I'm going to repeat the question for the stream and the live. And the question was about, like, can access control be used for smart wallets? That's it, basically, I think. It really depends what kind of smart wallet you want to build. There are different kinds of smart wallets. If it's just something that you are the sole owner of, I'm not sure it brings anything new to the table. But if you are doing a multi-sig, maybe it will be relevant. I mean, my opinion is that a time lock, for example, is a kind of smart wallet, because it's just someone that will manage asset and do operation, but with specific rules. And in the OpenZeppelin time lock, we use access control to separate the role of the proposers from the executors, from the admin that may have the right to cancel, potentially. So yes, if you are building a multisig and you want to have different privileged access, maybe having an overseer that is able to recover in case of issue, having signers, having proposers, that basically you're turning your multisig into some governance mechanism, which it basically is. What a multisig is, a governance mechanism. So yes, you could use access control.
In the example with Modular that you've shown, we are deploying the same method, like a bytecode for this method in every contract. Wouldn't it be better if we have it deployed separately?
Yes, it would, but it's not possible right now. So, like, if we had EIP-3074 live, we could just have this use this host and host call mechanism to do batching transaction, and you would not have to include that in your contract. The thing is that this is not available now. It will not be available until at least Shanghai and maybe later. So I think the bytecode increase is really small compared to the value that is added to your contract right now. But yeah, in the long run, hopefully we would have all this supported at the execution level layer.
Hey, great talk, by the way. In the ownable ERC 721 part, you were talking about how you could basically ditch the ownable library, right? What advantage? I kind of missed the point of like, what's the advantage of implementing the ownership inside the ERC 721 logic instead of just bringing ownable? Is it just like bytecode size, or is there any other advantage that I'm missing?
No, the real advantage is in composability. The example is, for example, your ownable contract. It could be tied to assets. Maybe you would want to consider that as a class of its own that you would be able to lend against collateral, or maybe it's like a vesting wallet that is basically a future, a financial future that you want to sell on Uniswap on OpenSea. Right now, you cannot sell an ownable contract on OpenSea, but you can sell an NFT. So the way here is to make sure that your contract is compatible with all the tooling that exists out there, OpenSea and others. Also, just being able to see the ownership in your Zerion or any wallet you use, that's also something nice.
Thanks.
Thank you.
Until noon, so 11:50 to noon. Is that right? Are we good to go? Should we do it?
Yeah, let's do it.
All right. Standing room only. Feels good, man. All right. So Oren McMillan and I are both the founders of a quadratic funding protocols. Oren founded CLR Fund. I founded Gitcoin. We've been friends before we were founders of that project, and we were talking about how inspired we were of the ethos of client diversity that has come out of Prismatic Labs and other teams at the base layer, and how that, Trent, go around this way, yeah. Those are not stairs. Anyway, so we were talking about what it would mean to have practical pluralism at the public goods funding layer of the stack. And so I've assembled some of the top founders of public goods funders in this space to talk about practical pluralism. So I'll hand it off to you, Oren.
So I'm just going to read a quick excerpt from the article that we wrote, or the essay that we wrote. It's up on this QR code if you want to go and check it out later, because I won't read the whole thing because we don't have time. But here we go. So pluralism itself is a primitive for anti-fragile, resilient, and regenerative systems. As an ecosystem, Ethereum has done a great job of fostering diversity in its mining and validating clients. Similarly, we should insist on pluralism across the full stack of Web3 technologies and culture. So this includes discrete products like wallets, RPC nodes, DAO tooling, public goods funding mechanisms, AMMs, stablecoins, developer tooling, as well as the intangible influences like the people, groups, communities, and opinions which participate in and hold sway over our ecosystem. So we're all here today because we believe in client diversity. We believe in pluralism as a primitive, and we want to join. We want you guys to join us in kind of extending this ethos of client diversity and pluralism to other layers of our collective stack. So by having pluralism as a core value in each kind of vertical, we make it more likely that the space tends towards capture resistance and not fragility. Participants should be able to choose or to use or not use any of a number of options for any given need. And so by having pluralism at the kind of beating heart of each niche, we ensure the space is anti-fragile. If there's a major bug discovered in one system, the resulting cascading harm can only go so far because there's always another alternative system to pick up the slack. So for Web3 to truly express itself, diversity and pluralism must be a core value. I'm going to hand it off to Griff to say a little piece on this as well.
Yeah, and I think we need to make sure that we're watching for opportunities for pluralism. I'm really worried. I want to make 2 points. I'm really worried, number one, about Etherscan. I think it's the hidden centralization that we don't. Matthew Tan and the Etherscan team are amazing, and they do great work. But that is the biggest honeypot in our industry, and we don't even think about it. If you can hack Etherscan and say you sent $1 million somewhere, you sent $1 million somewhere. We really need to make sure that we're funding alternatives like BlockScout, and I'm really worried about BlockScout since Gnosis just added Gnosis Scan and Etherscan on that chain, and now where's BlockScout going to go? We really need to think about blockchain explorers. I also just want to say, pluralism goes, if we have this infrastructure at our base layer, we can extend pluralism to the world. We have monopolistic governments telling us what to do all the time and demanding monopoly over public goods. And if we could instead change it so that we have competing organizations that are trying to meet the demand of society to satisfy our public goods needs, we'll have a much better world, and this will only work on top of a practical plurality base layer.
Hey, so I'm Carl. I'm contributing to the Optimism Collective, a layer 2, and we had practical pluralism in 2 spots. One, inside of our protocol. We started out building a monolith, but it was rigid, hard to contribute to, and bug prone. We needed a multi-client ecosystem in our ecosystem, so we took a step back, we split it up, broke it into modules, and then now we're actually building towards this multi-client ecosystem and have multiple clients for layer 2. So that's practical pluralism at work, allowing us to scale our protocol. And this is just amazing, an amazing moment of practical pluralism on stage here today. We spent so much time focusing on brands, but I am a believer that there is something which is forward progress, and that is why information and open source is so incredible, because you can actually make forward progress for an ecosystem. It's not about you getting forward, it's about moving the ecosystem forward as a whole. So that's it.
Wow, that was great. Hi everyone, I'm Pia Mancini, co-founder and CEO of Open Collective. We are not a Web3 project, so sorry about that. But what we do is we fund a lot of open source projects. We currently support 3,000 open source projects. We do project directed funding. And the way we do it is by creating an umbrella organization that allows them to access funding from companies and individuals and foundations that otherwise they wouldn't be able to access. And so our approach to pluralism is really by enabling any open source project out there to be able to receive funding. They don't need to be big, they don't need to be fancy, they just need to be an open collective. And in the past 4 years, we've distributed $30 million in public directed funding. So that's what we do.
Great. Okay, my name is Abby. I'm the head of community and governance at Radical. We build decentralized collaboration tools for developers building decentralized technologies. If you see me talk, I love free and open software. I am a FOSS fanatic, and I believe that practical pluralism, that's a tongue twister, can save the internet. The internet is being captured by anti-competitive forces that censor and capture and continue to extract. And if we don't build against this by investing in technical plurality, giving people the ability to exit infrastructure to freely act on their protocols and their infrastructure instead of relying on platforms to gatekeep their experience, if we can do that, if we can be more plural in the way that we build together, if by ownership distributions, Radical and Gitcoin just did an awesome public goods alliance. We did a token swap. If you can embed pluralism in your ownership, that's another way of securing resilience. And then finally, if you can build pluralism in your participants and the people in your network by building super diverse multi-stakeholder governance, you can build practical pluralism across the stack and build a better internet for everybody. That's what I think is great. I think that was 1 minute, right?
Hey everyone, my name is Trent Van Epps. It's an honor to be with these people, so many of whom I respect. I'm a member of the Protocol Guild, which is rebalancing the incentives to contribute to the core protocol, making sure we have people maintaining this infrastructure that the entire ecosystem depends on, and that the people that are working on it are properly compensated and motivated to continue doing this work for many, many decades to come. And I would like to point everybody to a great talk yesterday from Josh Stark of the EF. He included many of the organizations represented here on this slide. I encourage you to go check it out. It's about the EF generally, but he references or compares organizations fundraising for public goods as Ethereum's civil society. And it's a really apt analogy because we don't have a government in Ethereum. We have the private sector, which is people that are, building tools and applications for people to use, maybe profit motivated, but we desperately need to maintain the civil society that is making sure that the public goods of Ethereum are maintained and that people can get the resources to build them long into the future. So I'd encourage you to check out that talk and imagine this group of people here as the vanguard of civil society in Ethereum, and it's something that we need to make sure is encouraged. We should be able to contribute to the civil society as well, while having these organizations building alongside each other. Yeah, go check out that talk.
Alrighty, I'll bring it home. So I, Kevin Iwaki, founder of Gitcoin, repent for building a centralized monolith in the beginning. And I'm really glad to be seeing Gitcoin move towards a decentralized modular infrastructure. And I think that modular infrastructure is going to enable Gitcoin to be more plural in the future. And I would love to, I'm not in control of the DAO in any way, but as an outsider, I would love to see a future in which we build on top of the modules that CLR Fund has pioneered, that Giveth has pioneered, retroactive public goods funding at Optimism. Open Collective has been an inspiration for me from the start. Radical, same thing, and I'm really proud of what Protocol Guild is doing with public goods funding for the client developers in the Ethereum ecosystem. I really hope to see, to give another talk on practical pluralism in a couple years and invite, we're going to have to figure out how to put 20 founders up on stage of public goods projects in 2025. And I think that we want to eat our own dog food and be practically plural with the public goods funding infrastructure of the ecosystem. And this is a challenge to the rest of the ecosystem, whether you're building NFT marketplaces, DEXs, or any other piece of infrastructure, to embrace modularity and pluralism from the start. And I'm so inspired by you. Thank you for joining this panel, and please join me in a round of applause for our panelists. All right. Right on time. There we go. Thanks, everyone. See you in the lobby.
Okay, can you hear me? Yeah. Hello, my name is Heiko. I'm a developer at Corpus Ventures, and I'll present you now DM3. What is DM3? DM3 is a simple protocol for messaging. It's decentralized, it's open, and it's secure. To achieve this, we built DM3 on established Web3 protocols like ENS. The properties I just mentioned make it censorship resistant. We designed it so that there's no single point of failure. And with DM3, users are in control of their data. Everyone can write an own implementation of DM3. The basis for DM3 is a registry where users can store their profiles. We used ENS text records for that. And on the middle layer, we have the delivery service. The delivery services buffer the messages until they are delivered to the messaging app. And on top, you can see the messaging app. Since the registry is the core of the protocol, I'll now explain a little bit deeper how it works. As you can see, we have the public encryption key in the text record for the profile, and also the signing key, public signing key. And also important is the delivery service name. So there must be at least one name of a delivery service. The delivery service text record also contains sorry, now it works again. Okay, the delivery service text record also contains public keys, and it contains a URL. This URL is pointing to the delivery service instance where messages can be sent to. It's also possible to store data off-chain or on layer 2 by using CCIP. This allows the creation of DM3 profiles without high transaction fees, or if it's completely off-chain, you don't have any. And it also makes it possible to include external public key databases. This slide shows how a message would be delivered from Alice to Bob. So at first, Alice types a message into the app. Then the app will retrieve the DM3 profile of Bob, which contains the delivery service name he is using. In the next step, the app will retrieve the delivery service text record where there is the URL of Bob's delivery service. Then the message is signed and encrypted and sent to Bob's delivery service. The delivery service will push the message to the app. There it will be decrypted, and the app will look for the profile of Alice, and that's needed because the signature needs to be checked. And if it's the signature is fine, Bob can then read the message. Besides the protocol definition, we also have a reference implementation. The reference implementation consists of 4 different packages. We have the DM3 web app. As you can see, a screenshot here on the left side. It's also online available on the app.dm3.chat. Besides the web app, we have the React package. This can be used to include a widget of DM3 into other apps. And then we have the backend package. This contains the delivery service. And finally, we have the DM3 lib, which contains basic protocol services. So we are working also on protocol extensions, which takes care of things like group messaging. These extensions are optional. If you want to write a DM3 implementation, you only need to follow the DM3 message transport protocol. So that's our roadmap. Until now, we are published the protocol draft and the reference implementation. A critical goal of DiEM3 is to enable interoperability between currently isolated Web3 messengers. We are now talking with many of those messenger teams to understand their needs. And yeah, please let us know if you want to join the discussion. After we finish that process, we'll publish the specification and adapt the reference implementation. Yeah. If you want to include DiEM3 into your app, let us know. We'll try to support you. That's it. Thank you. No question?
Okay, hello everybody, thank you for coming. I'm Adrian, I work at OpenZeppelin, and today I'm going to show you how you can very quickly build your first contract with OpenZeppelin Wizards. Very quickly, a few points about OpenZeppelin. You may know us, but our thesis now is that there is a $1 trillion open economy being built on smart contracts, and we are not the one that are going to build it. You guys, the builders, are going to do that through your dApps, through DeFi, through everything. But in order to do that, you will need a set of tools, products, and services that will allow you to do it in a safe and effective way. And that's where we're coming, trying to be the leading providers for solutions for dApp developers and people in this Web3 space. We do that through many offerings. Audit, obviously, Defender, that I encourage you to try if you haven't tried it already for managing your contract. And also the OpenZeppelin contract library, obviously, and we support a lot of network. So last year, one thing we did on the contract team is create the contract wizard. And basically, so it should be animated, but it's a PDF, so sorry, you'll see it in action later. The contract wizard is basically a website that allows you to bootstrap basically a lot of contracts, ERC20, 721s, governors, we'll see that together. And the idea is to remove as much pain as possible at the early stage of building your contract by providing what is common to everybody, what is easy, so that you can then focus on either just deploying them and building your app on top of it, or customizing it with some logic. So yeah, we don't have much time, so let's just go to a demo. So you know how the network is, so I'm just running a local instance here, but you can get that through wizard.openzeppelin.com. And for example, today, I propose that we both create a governor DAO that we could all be participant in, and our participation in this DAO will be represented by an NFT. So we'll start by building an NFT contract. So we're going to take an ERC721 contract. We're going to make it mintable, and you see the code change. So if you are teaching Solidity, like using that is also a great tool for showcasing how like adding features modifies your contract. So I'm putting the vote module, obviously, because that will help us a lot. I'm using roles instead of ownability, but you see that the wizard updates everything very nicely. And that's it. That's a very simple, maybe make it burnable, but that's a very simple NFT contract. So once you have that, you can just copy paste, download it. But what we're going to do is open it in Remix. And it's also a local instance of Remix because network. And leave this one. And here you see that your code is here. It just got put into this part here. So we have the file and we are ready to work on it. But we want to do a governor, so we just need more than just an NFT. So we're going to go back to here and now go to the governor. And let's make a governor that is pretty simple with a quorum that's at least 10 NFT holders will need to participate. Obviously, we are going to use ERC721 votes. We don't want a time lock, but we want to make it upgradable through UPS. So yeah, so that's a governor that is upgradable. And since it's upgradable, maybe we don't want to have the setting updatable. You will update it to upgrade. You do what you want. That's just our code. So it turns out to be a pretty small piece of code, but if I had put that, like you see that there is a lot of possibly some overrides that are sometimes painful. So the wizard is here to help you figure that out. And so now that I'm happy with my governor, I'm going to just open that in Remix. Okay, leave this one. Remix is a bit strange, but now I should have both files here, my token and my governor. So let's deploy. So I'm going to use a local compiler because otherwise it's not going to work without network. And I'm going to compile this file. This is possibly the longest part of deploying a contract is actually compiling it in Remix in this case. Hopefully it doesn't take too long because I only have 3 minutes left. Okay, it's good. Oh, one thing we could do is like, this is ownable, but here we could just modify that and make it only governance. So that your upgradability would be managed not by the owner that we can remove, but by the governor itself. So this is a good time for you to like modify your contract a bit. Hopefully I haven't made any typo and it will compile. Again, always the longest part. Yes, it's good. I also need to compile this, which is my token. So here. And now that this is compiled, yes, I can just go here, take my token. So my token is here. It's an ERC721. I can just deploy it again to a local instance. We're not going to wait for girly. Oh, I removed it. Yeah, this is okay. This is my token here. I've got a lot of features, so I can just take my address here and paste it into SafeMint to mint myself 1, 2, 3 tokens. Yeah, I've got 3 tokens. If you get a look at my balance, I've got 3 tokens. I need to delegate this to myself, so I'm just calling the delegate function. And right now, if I go to get votes here, you'll see that my wallet has also 3 votes. So that's good. Now that we have this, we are going to deploy the second part, which is our governor. Where is the governor? It's not here. Oh. do I need to, yeah, okay, my governor is here. We remember that the governor was an upgradable contract. So basically what is going to happen is that Remix is going to understand that and is going to deploy first the implementation and then the proxy, which it's great from Remix that they support that. So now you see that I have two contracts, the governor and this. And if I go there and I just, again, copy paste the address of my account and I see the get past vote, where is it? Oh, it's in the view function. I got a get votes that allows me to check what were my votes at block number 6. And at block number 6, I had 3 votes. That was after I delegated. At block number 3, I had 0 votes. That was before my delegation. So we're not going to do a proposal or anything. We are out of time. But you could take this, put it into Defender to propose easily from OpenZeppelin Defender. You could also link that to Tally so that your user and your NFT holders can vote easily. And so basically in 7 minutes, we managed to deploy an entire governance system based on NFT. And that wouldn't have been possible without the wizard. So yeah, that's what we are very proud of, that we want you to use. And yeah, and I should have put the address. The address is wizard.openzeppelin.com. Thank you. Not sure if we have time for questions. Or if there is no question, you can just go see us later during Devcon and ask us, or go on the forum and share your opinion about all that we are building. Thank you. Switch anything or?
Okay. Can I go? Okay. Hello everyone. My name is Pavel. I'm at Epsilon team at Ethereum Foundation, and this talk was originally about what's next in the EVM, but we shortened it a bit because Lightning talks. But what I want to tell you about today is to give you a quick introduction to EOF, EVM object format. But we have to start with the current EVM we have. So one of the design goals of current EVM was simplicity, and the thing is that we kind of overdone it. The current EVM can just execute whatever bytes you will provide to it, and that's why I'm kind of sometimes thinking about it as a garbage eating machine. So it brings some success to EVM, but that also brings some inefficiencies to it. So one of these inefficient aspects of EVM is that you need to do a lot of work except above the actual work the instructions are doing internally. So this is like the checks that every step in the interpreter you will need to perform to make sure the EVM works as specification wants it to go. And this is kind of the motivation we want to clean it up. And the cleanup of that is to introduce a container, binary container for the programs in EVM, so that it will kind of translate the mixture of different features and some misfeatures in the legacy EVM to something that is a bit more structured and polished. So the main aspect of EOF is to provide some metadata about the program, including the version number, and split the bytes into code and data sections. We can also do a bit more about that. This is the kind of the the next proposal that can be applied to the MEV of EOF, which is to introduce functions. So we can partition the code section into more pieces with additional function type information. And to work with the functions in EVM, we will introduce two new instructions. One is to call the other code blob, and one is to return from the call to the caller. And this, the calling the functions internally works, allows you to move you between the different code sections. In the code sections, you can use relative jumps, which would replace the existing dynamic jumps. And yeah, so this is the control flow instructions that will allow you move it around in the code sections, and it won't be allowed to actually cross the boundaries of the partitions. And as I mentioned, having this control flow features, we can deprecate the existing jumps semantics. In particular, this is really useful because we can drop the jump desk analysis, which has to be performed about EVM programs before every execution. And if we kind of add up all of that, we can, with additional code verification that will happen, we can eliminate these first three checks in the EVM. So this is the additional aspect that can be added to that, which we can verify how the functions behave internally with simple algorithms. But to sum up all of that, yeah, there's kind of improved version of EVM that has some nice control flow, have the code and data separation, and support native functions. Yeah, so that's mostly what I had to show you today. These are pointers where you can find more information. I think in particular the IFCC talk from this year, it's kind of the extended version of this talk, so yeah, you're invited to see it after it. And yeah, the 5 bullet points in the end are all the EIPs that kind of specify the broad aspect of EOF. Yeah, still have 1 minute, so if you want, you can shout some questions from the audience. That's a hard question. I mean, we're kind of competing with the proto-dunk sharding and withdrawals right now. So yeah, it's hard to tell actually. Some of these aspects were prepared for Shanghai, but not all of the features I talked about today.
Hi, I have a quick question. I'm here.
Oh, sorry.
So in one of the slides, you strike through Stack Underflow and Stack Overflow, because basically, yeah, this one and only. Can you give a bit more details around that?
Yeah, this is done by code validation. So when you want to deploy a code, it will go through additional validation process. And in particular, when you don't have dynamic jumps, you can statically check if the function will never stack underflow. Stack overflow is a bit more complicated, but you can compute like the maximum stack height the function reaches, and then whenever you call the function, you can check if you still have enough stack space available. So that's the second one is a bit more complex, and it has some trade-offs. I think it's my time, so thank you very much.
Thank you.
Thank you. Yeah, I'm gonna. Yeah.
Sí, son 4 en total. O sea, serían 13 libres y el de cabezote. Okay, I have 2 more. I mean, 1 more. Oh, yeah. Okay. 2 more for you.
Sorry. Thank you. Oh, this is on.
Balance of work? Balance of work?
Yeah, yeah.
That's just because they're not charging on there.
Yeah, let's do it.
Just it.
Let's, okay, this is not the task. No, destroy the. Yeah, it looks like stairs though.
Raul, where do you want to sit?
I'll sit on one of these.
Can I stop destroying stuff?
Yeah, you're ready to go.
Yeah, yeah, I'm destroying everything.
All right. Good afternoon, everyone. Good thing we're just after lunch. Everyone's like all hydrated and ready to process some fun information. All right. The objective of this talk, so my name is Rahul. I work for Reddit's crypto team. And over the last year, I've got really into rollups. But I see these layer twos not just as a scalability solution, but rather a way to extend what Ethereum can be could be or it perhaps should be. So I'm very delighted that I have with me these three amazing people who are running like what in my biased opinion is perhaps the most unique and coolest layer 2s in the space. So I would love for three of you to just introduce yourselves, talk about what you're building very briefly before we get into like the cool things of your systems.
Yeah, hey everyone, my name's Joe. I'm one of the co-founders of Aztec, and I lead product. Aztec's a privacy layer for Ethereum, and we currently have Aztec Connect Live, which is a VPN for all of DeFi, and we're working on a fully private VM, which has private smart contracts.
Hi, my name is Louis. I'm ecosystem lead at Starkware. Been at Starkware for over 3.5 years. So Starkware is building scalability solutions using zero-knowledge proof, more specifically Starks. Our first product you may have used is called StarkX. It is the one powering Sorare, Immutable, DYDX, Diversify, and plenty of others that we're going to announce soon. And in the last 1.5 years, almost now, we starting to work on Starknet, which is a general-purpose layer 2 on top of Ethereum, enabling scaling using a Turing-complete language called Cairo.
Hello. So my name is Nick. I'm the CEO of Fuel Labs, and to describe Fuel in a simple way, you can think of it like a layer 2. We launched the first optimistic rollup to Ethereum. That was a fully trustless, optimistic rollup, no multi-sig, anything. And to describe what we do, we have a new kind of transaction processing system, and this can take the form of something like a Validium. It can take the form of something like a layer 2. And we use UTXOs for this. We use a different paradigm from typical Ethereum systems. We have our own language called Sway, which is used to target this system. We have our own tooling. We have basically a revised version of everything Ethereum offers. We're here to help Ethereum scale and basically incorporate all of the lessons that we've learned from production Ethereum over the years. Provide Ethereum a new and different kind of pathway to scale that isn't the EVM tool chains and EVM processing systems.
Very cool. All right, so we have a good mix of people here. We have like 2 companies building zero knowledge. We have 2 companies using UTXOs, but all of you have like such unique branding and products. So like let's go for a very first principle approach. Before I ask why you chose non-EVM, can I ask why should blockchains just not use normal VMs like, I don't know, x86 or RAM? Why is it so necessary to build something new?
I think I'll take a stab at that one. So x86 and these other instruction sets are really designed for different computing architectures. So when you're designing x86, you're designing ARM, you're designing them to target a hardware system. And so that's going to come with its own criteria and its own restrictions and physics. Whereas with a blockchain virtual machine, you're designing for a different kind of physics. So you're pricing every operation, you're designing for adversarial scenarios. And because of this, you end up having odd design constraints that really put you in a corner, and you have to really understand those physics to design a good virtual machine that will both be great for processing, but also be great for security. So it really is kind of an art designing some of these systems, and we've learned a lot since the kind of inception of Bitcoin in 2008, all the way through to now. And basically, those instruction sets are for different purposes. Whereas virtual machines for blockchains are categorically a different thing. Now you can do it, but you do lose some of the nice things. Whereas if you had designed it from scratch, you basically can kind of design a better world. So yeah.
I was just going to add, I think compatibility is one of the main kind of reasons why we have to limit the feature set on blockchain kind of VMs. Like you have multiple clients trying to all get to the same kind of state update, and that doesn't exist in the world of kind of like Intel chips. So it's just, it's a much harder problem, and that usually means we get a limited feature set like we have in the EVM.
No, I don't really have much to say. I mean, technical aspect was very defined.
Blockchain VMs as an art is really a good way to put it. Right, so what are your expectations from a blockchain EVM then? From a blockchain VM, like what are the things we've learned from the EVM? What are the things that you wanted, couldn't get, built your own things?
I think just a starting point is probably like the more complex the VM is, I think the harder it is to scale. We're seeing this with kind of people trying to prove computation of EVM, and you need like giant data centers to actually construct that proof. So a simple kind of maybe tailored feature set of the VM is probably going to result in more scalability. Is maybe the first point.
Can you repeat the question?
What are your expectations from a blockchain VM? And this goes to like things you can get from EVM.
Yeah, so the thing is that what we were expecting from a VM, a blockchain VM, before and now changed. It changed significantly between the origin of Bitcoin and Ethereum and what we know now. And I guess one of the main difference is that we now realize more than ever that we need scalability, and we now discover that there are tech that gives that scalability while preserving the core principle of blockchains. And the core principle of blockchain is trustlessness and verifiability. And before, and I'm going to toot my own horn obviously and talk about ZK here, before the arrival of ZK as a practical technique to bring fast verification, we just went to the shortest, to the simplest, which was the EVM. And now that we are looking at those new tech and this new knowledge that we're learning, what Fuel is doing or what Solana is doing and what others chain are doing, we are bringing the new, more top-notch computer science to it, and which are providing more feature sets that we are looking for to develop good product, good dApps on top of crypto, on top of blockchains.
Very well said. Yeah, I guess over time our expectations have changed quite a lot.
Yeah, I would say so. Coming from sort of like 2015, 2016 blockchain to now, like I've been using Ethereum almost since it started. So for me, it's been like a long road, and I would say that the expectations have completely changed. I think, but just as well, the community didn't fully understand all the design constraints when they were putting it together. And there was decisions made over time, particularly with the kinds of architectures that Ethereum chose, that ended up being really costly for just compute and for all the different kinds of design potential that you want. And as well, backwards compatibility was something that, it was not really kind of in part of the picture. And I think it's ended up locking us into a design that wasn't really educated on what could potentially happen if we had this design, and so we're just sort of stuck with it. So, I think the expectations are that, again, you design a safe VM, you design a virtual machine that can provide all the behaviors we like for Ethereum, but as well open up a lot of new kinds of designs that we currently don't see, that we'd like to see. And then on top of that, just designing for a lot of different scenarios where if you could have done it a different way, you would have factored in all the research that we have. You can basically, you can create a new reality for blockchain that I think is much stronger than what we have now. So, yeah.
Yeah, I was going to say, like one example is probably like the curve that we all sign over. So we've all got a seed phrase, and it's kind of hasn't really changed in a while. People have tried doing smart contract wallets, but if you control the VM, everyone in the room's got an iPhone or an Android that's got a TPM in it, and you can actually build that into the VM and help get adoption. So, yeah, recreating all of the EVM, I think, would be a mistake, and just trying to kind of focus on adoption in the feature set would be a good thing.
When specifically about the change that we are expecting now from the VM, there are a couple of examples which are just so significant, so clear that the goal target moved. Aragon, when they launched, they were like, this massive OS for DAO was like very well thought out. The point that it was way too expensive. Back then, no one cared. When they started, using a whole block for yourself was like, who cares? No one's here. And now, you try to optimize, like we have all those people on Twitter doing those gas golfing to a point which is just ridiculous, right? And so one thing that we're observing specifically in the context of StarkNet and the new language that we have is that when you provide new like feature set and new capacity to the chain, you get like a combination of creativity that you like new things that don't exist before. And so Joe here was talking about the curve we're using, or the fact that we have EOAs. EOAs was a mistake in retrospect, and the problem with that EOAs is that they put us in a local equilibrium. There is no way smart contract wallet will pick up on Ethereum today because it's always cheaper to use EOAs. It's always cheaper to use my private keys. And so there is no incentive for the dApps to actually build their application to be very well compatible with Red Connect, or just to work well with smart contract wallet. And even some just ban them because they're smart contract. And so in the context of StarkNet, because we don't have EOAs, we only have smart contract and therefore only smart contract wallet. We have people using the native curve of the network called the Stark curve, and now we're also people trying to build using the trusted enclave of your iPhone. So within the same wallet, you can actually use your iPhone. You can you can use any curve that you want. You can use the browsers that have also a curve in it. And so we once you unlock the limitation that we know, you start having new things that get created basically right away.
Yeah, I agree with you. I think asking engineers to gas golf instead of thinking about innovative things to do is a big waste of time and probably prevents a lot of innovation that could have happened in the space by far.
Yeah, just to speak to that too. So like I've done my share of gas golfing. Like I want to say I'm like, you can check my GitHub, like it's sort of like an art for me, but it was more of a therapeutic thing to gas golf than it was like this is a good use of my time. Mind you, that was before I worked with Fuel, so started Fuel. So essentially, yeah, the thing is you can gas golf all you want, but it's not enough, and it's never enough, because when enough people use the system, it just gets congested, and then you're back to where you started, and you keep asking the same questions, like, well, how could we do this? How could OpenSea run in this way? And then the thing is you lock yourself in so much to just trying to support this thing, which, by the way, I mean, there's some controversy around it, but the EVM was sort of designed a little quickly and was put together a little fast, and at Devcon 1, there was some conversations about that particular thing, if you want some spice, but anyway, the reality is I've been sitting here looking at this machine for years, like years and years and years, and it's held a lot of different kinds of designs back because it can't move forward. Like it really is very, very difficult to move forward. So the fact that these teams are sort of bold enough to still be part of Ethereum, but try to do it differently just for the sake of like getting to global adoption and getting somewhere else, I think is a it's a sign of how good the Ethereum community is, because we're not afraid to challenge what people have made a culture of the system, and I think that's it's a very beautiful thing, So, but yeah, it's not all just Vitalik and Gavin's design that gets to run the show, I mean, we can try to do other things, and with layer 2s, we can now, so it's great. Yeah,
exactly. Like layer 2s should be seen as a way to extend everything that we can't do in Ethereum, not just a cheap transaction machine. But that's, sorry, you have to add something? No, yeah.
Yeah, about the, everyone comes to say about, it's always about cheap. No, it's not about cheap. Really not about cheap. I can give you a few examples of things that are being built that you just like could dream of anywhere else on Ethereum. And so, for instance, smart contract wallet is most specifically like an important one, because smart contract wallet is crypto if will not get global adoption if we have to keep a key. And if the EOA's mechanism, like having a private key, remains, basically we're going to go back to the financial system where we have 5 global custodians. And that's not what we want. And so on the smart contract part, we are now things that are getting unlocked. For instance, Argent, around here actually, is working extensively on StarkNet, and they're working on a plugging system, meaning you can actually install an app in your wallet, meaning that, for instance, every time you spend, 10% goes to saving. Or every time you want to play a game, you actually don't have to sign every transaction. You can open a session key that's going to last 6 hours, and that is only authorized to do a set of operation. And so really the cheap transaction is like an afterthought. It's just a requirement. And honestly, to be honest, I don't think it's going to last long. Like L2s themselves will not be cheap. I have a theory which is you can't have a cheap, successful economical layer. because there is no reason in the universe that my ticketing app that is trading, or where I can change my NFT, my NFT of my ticket, be impacted by the fact that the price of ETH dropped by 20%. And all of a sudden, my app doesn't work anymore. And so that just doesn't happen. That just won't work.
Insanely refreshing to hear. Maybe I want to go into a pivot over here, and like what enables all of your architectures to actually be able to do these things. I think everyone here would love to know more about these architectural decisions they've made that enable these new paradigms here.
Okay, so we all get what you're saying is we can all shill a little bit, just like a little bit for each project. Okay, all right, I'll try to. Okay, I'm going to try to keep my shilling in a kind of a dome, so some highlights. But okay, so first of all, the Fuel VM is highly inspired by the EVM. So all the lessons that we've learned with the EVM over the years, it tries to incorporate. It doesn't leave that behind. It doesn't try to say we're arrogant enough to rebuild everything. So that's the first thing. We've basically taken all the great EIPs, all the great research that the Ethereum community has done and other blockchain communities have done, and put it into a virtual machine. Now, we've made some very interesting decisions, and they all impact the kinds of things you can build, the kinds of experiences you can create, and as well the scale that you can achieve with this particular system. So some highlights are it's UTXO based, so that's the first thing. Secondly, you get smart contracts just like Ethereum. There's no loss in any kind of behavior from a developer. Secondly, scripts is another one. So in Ethereum, you have to go through a smart contract to make multiple calls. It's ridiculous. It's never should have been that way. So we have scripts, and then we have account abstraction via what we call predicates. And so this allows you to send to the hash of a script, and essentially if the script returns true, then you can spend the output. And this gives you all kinds of things you can do. For example, we can support signing with a Solana key over a UTXO that is USDC from Ethereum. That's pretty nuts, you know, and that can happen it's cool. And then that can happen in like an output. You can also do things like, some other cool stuff is we've redesigned all of the processing within the virtual machine as well, such that when you make a smart contract call with Fuel, instead of having to serialize, and the engineers will know this, I'm sorry if you're not an engineer, so just bear with me, but when you make a call, you don't need to reserialize the data between smart contracts. It's all in one chunk of memory, but the memory is segmented per call frame. And what that does is it allows you to go, I'll write 5,000 things to memory here, I'll call this contract over here, and that other contract can just reference any one of those items. So you can imagine trading engines, things like this, would love that because you can write so much to memory. You can really abuse memory, and you can abuse compute, which we have a lot more of, and not storage. So we give you far more options to use that are not storage oriented. So these are all part of the processing model, but lastly, for the last bit of shill, this also, because it's a UTXO model, you get all the nice things of Ethereum, but you get full, complete parallel processing. So you can basically have all the benefits of some of these newer ecosystems that have parallel processing, but because the Fuel VM is designed to be arbitrated, it can also be a rollup or layer 2 on Ethereum directly. And on top of that, it has trust minimized light clients. So you're not leaving behind the nice security properties what we have with Ethereum. So that's my shill on the VM. Yeah, you go.
Beautiful.
Okay, ours is also a UTXO model. Big fan of UTXOs. They're very difficult, but they do enable kind of some important features which the account model lacks, and in our case that's privacy. So it's very hard to do privacy in an account-based model because every time you update an account, you leak which account you're updating. So in UTXO model, we can create and destroy UTXOs, and they all look random. So it's one of the key kind of design choices we had to make to get privacy. And then kind of more into the VM, we also have account abstraction built into Aztec. So we have this concept of a viewing key and a spending key. When things are encrypted, there's a different set of people who may need to see the data to those who can spend it. So I think being able to control that has been super beneficial for our architecture. today the VM only supports kind of circuits or programs that we've written, but we're expanding it with a concept called Aztec 3, which Mike from Aztec is actually talking about tomorrow on one of the other stages. And the main kind of improvements there are that every program is actually a client-side generated ZK snark. So we've built a language called Noir, which enables developers to write these programs, and then users will actually, instead of sending this to be executed on kind of a node, they'll actually compute the snark in the browser in Noir, prove the correct running of the program, and then send that kind of packaged up kernel circuit to a rollup provider. And that means you actually get really cool features like code privacy, confidentiality, and anonymity. So we're excited about that.
So in the context of StarkNet and Starkware, we also created our own VM, but focusing only on scaling, kind of similarly to Fuel. And I just want to sort of make a differentiation in terms of scaling between the Fuel approach to, which is basically parallelization, enabling the execution layer to do more, and the ZK approach, which is basically requiring less from the verifier. And those are orthogonal, completely orthogonal. So you can get both, potentially. But the reason why I'm making that's the differentiation is because in some way, the way Starknet scale is by saying, you know what? Validators can have stronger machine than the rest of the world. Today, when you look at Ethereum or any blockchain like Bitcoin, the scaling is limited by the weakest machine in the network. And so when we compare the TPS or whatever, I mean, the throughput of Bitcoin versus the throughput of Ethereum versus the throughput of Solana, we are comparing Apple, oranges, and Ferrari. And the reason is very simple. Bitcoin targets a Raspberry Pi, which is roughly the cheapest computer you can find. Ethereum says, okay, we are targeting, this is a bit too constrained for the real world application. Maybe we can have like a $2,500 machine. So for instance, I synced Eve completely on my laptop, my 2021 M1 Apple book, like a month ago, 2 months ago. And Solana is like, you know what, $2,000 machine is very constrained because companies, they pay that for like a flight for their employees to Bogotá. And so maybe we can have a $2,500 machine per month. That's a practical cost for servers for an entity for corporate. And so we are really not comparing the same thing. And so when you're looking at the limitation of scaling for all those blockchain is the weakest point. What is the minimum machine the network needs to have? And so when you use a regular traditional execution layer without using cryptography to scale it, you basically don't really change this symmetry. The guy who makes money is still requiring the same machine that the guy who's verifying it in his garage. And regardless of the fact that this miner, this validator can spend millions of dollars at stake or millions of dollars in machine, it will roughly run on the same laptop that you have at home. And so ZK breaks that parallel. All of a sudden, it doesn't matter what kind of machine the validators have. I can verify it on my phone in a millisecond. And so they can have a data center for what I care. I can still verify it on my phone. So the Starkware created its own VM called Cairo because the problem that we have with existing VM is that they are optimizing for a different programming paradigms that ZKPs. So the best way to explain it is that you talked before about x86. So your regular VM is optimizing for basically your CPUs and your transistors. And transistors know one thing very well, which is Boolean logic and bits and bytes. The thing is, when you're in the ZKP environment, you are working in an arithmetic environment where the base element you're working with is what we call a field element, which is basically a big uint. And the cheap operation that you get is multiplication, addition, division, subtraction. And Boolean logic is expensive. So you move the model on its head, and there is other differentiation that I can expand on, like non-determinism or something like this. But roughly speaking, to make a chain that is verifiable, cryptographically verifiable, and using ZKPs, or validity proof, depending on what you call it, you want to have you prefer to have a VM that is optimized for that computing paradigms. And so the specific dimensionality, as I said, is orthogonal to the execution layer. And so Starknet right now is basically roughly taking the same structure, execution model than Ethereum, with a few distinctions, like we try to do optimistic parallelization, we are looking into different data structure while remaining the data structure of ETH, also expanding on what's the new state of the art is coming, like things like Sui Optos. We are looking into what they're doing because it's cool, it's useful. And so what matters is that is a separation. So Starknet is focusing on the separation between the validators and the rest of the world. And then afterwards, we are looking into optimizing the execution layer to provide the throughput that everyone expects.
I'll just say one last word because node requirements came up. So I'll just make one comment, which is, we're in Latin America, and this is a new place for Ethereum to be. I think, having been through a bunch of them, there was a bunch in Europe, etc. I think with Fuel and the way that we interpret node requirements, we want people here, not like, in Switzerland, like people here to be able to afford to run a node in this global peer-to-peer network, not only for their own research, for building, for interoperating with the network, but we want them to be able to afford it just for the global security of the system itself. And so I think with Fuel, we've been designing the best system we can possibly think of, but we're also making sure that when we talk about node requirements, which ends up being really important because it really dictates how much throughput, how much processing you can put through the system, I think this is like a very key factor. So for us, we would like someone in Colombia to be able to actually verify this and not have to pay an enormous sum, like someone's whole year's wage or whatever it might be, to be able to just run a node,
Exactly.
Yeah.
I mean, to that point, the genius of having rollups, like the ones you all three are building, is not everyone has to run their own node. So that really adds up.
Yeah, I think it gets worse for privacy because there's like a censorship component. So if you kind of restrict like your kind of nodes to AWS, Google Cloud, and Microsoft, quite quickly you don't have a decentralized privacy network. You have FANG. So yeah, our node requirements, we do the same as Fuel, and we have to kind of think about how do we get it working on a laptop? How do we get like rollups actually being built in a peer-to-peer network? And actually, some of the ones are doing a really good job here. Like Mina's got a model which is kind of like a federated prover. So I think there's a lot to learn from some of the other chains as well.
And by the way, you said that not everyone has to run nodes. I 100% disagree with that. Okay. We should be able to run node on your phone. You should.
You should be, yeah.
And that's the target. That's what we should achieve. So maybe it's not practical, and the fact that it's not practical is irrelevant. The fact that it's a goal is what matters. That's what drives us. That's what brings us towards one point. And so I really don't. I really want, ideally in the future, Infura would be made redundant to some extent. Of course not, but to some extent, at least on your phone, or you should be able to run the network locally.
That makes sense. So we spoke about all of the UTXOs and stuff, and I know you mentioned about how Fuel's parallelization and the stuff you're doing with verifications are orthogonal. We all over here obviously are Cardano Moxies, and we all obviously were quite sad when Cardano couldn't work out with UTXOs. How are you guys doing it possible what Cardano couldn't? And I guess for Starkware, for Louis, when UTXOs?
Yeah, I can go first. I mean, I think it's the elephant in the room. So currently, an Aztec client has to sync every single UTXO, test it, see if it's your UTXO, try and decrypt it, and like clearly that doesn't scale. So at the moment, we kind of use brute force, and we have some like very advanced multi-threaded WASM, so like pushing the browser right to the edge of what it can do, and that gets us kind of the current throughputs that we can kind of think about today. To get to kind of, I guess, world adoption, we actually have to look at kind of the network layer of privacy. So we're moving to looking at using something like NIM, so you can actually request UTXOs from a kind of more centralized data store without revealing who you are, and if the UTXO is completely random, when you request that through like a network layer, privacy layer, you get the same anonymity as kind of a full sync. So there's ways to do it, but it requires kind of the whole privacy stack in our case, and some pretty advanced web browser computations.
So I'll address that one pretty simply. So basically, this is one of many things Charles has done to damage the reputation of something completely innocuous to this particular thing. So so basically, just for some spice for the panel, you
Yes,
know?
please.
Yeah, just a little spice. So the main thing is Cardano's model, at least from the way we can interpret it, and this is sort of how we think about it too, is it was implying a certain kind of determinism across the system that was basically blocking or bottlenecking how they were using the UTXOs. For example, if you built something like Uniswap, what would happen is, and again, this is just my read, so, you know, let's fight on Twitter about it or something, but basically you have something like Uniswap, well, you can't really have it because with their model, you had to sort of sign off on the change state, but what if you don't know the change state? So what if there's a bunch of people in front of you and behind you in the mempool who are actually manipulating the state of this one thing? Then when you produce the result of the UTXO, well, you don't know what it is. So in their model, they couldn't do that. So it caused this issue where like you would use Uniswap and there'd be like one transaction per block for that one app because you didn't know what the state was, so you had to just use it one after the other. Obviously, this is horrible. Like, you know, imagine 1 TX or whatever per block for Uniswap on Ethereum. Like, we probably wouldn't even be doing Devcon or something like that, you know? So basically, you know, the reality is that that was more of a design decision on the whole system, and it doesn't actually relate necessarily to UTXOs per se. UTXOs are just a way to notate and define the transaction model, which is something that you can do in various ways. So with Fuel, if you have a smart contract as an input, you can have, like, say, a Uniswap-like system, that's one input. When the state is manipulated, we basically have an output, so it is noted that it changes the state. But like Ethereum, there is this kind of reasonable malleability of what could happen under the constraints of the system, such that, you know, this output basically is, you know, it's notating there's a change, but it's under certain constraints and certain conditions, similar to what we expect with Ethereum and Uniswap. When you use Uniswap, you don't always know what the state's going to be or what it's going to change to, but in Ethereum, we're willing to accept that reality under certain constraints. So I use the word determinism here. Maybe the academics don't like that particularly, but it is sort of how I would interpret the situation. But with Fuel, we don't have any of those problems at all. You can build a Uniswap-like system or whatever. You can use the transaction UTXO model. We get all the parallelism benefits. There's no downsides to that, and it's not an issue. It's really just, it was publicized as an issue, and UTXOs were related. But in our case, we have different designs that don't feature this issue at all. Yeah.
In the context of Fuel, is there any problem with composability, or is it because of scripts? Like, how do you manage the coding multiple states at the same time?
Yeah, so basically Fuel has just normal smart contracts. So you can have a smart contract that calls many smart contracts. If it does, then you're notating those various other smart contracts as UTXOs as well. They're inputs to the system, you're outputting potential changes. So it's very simple in its design. We've inherited a lot of the work that was done in research for state access lists for Ethereum. So really this is just a reinterpretation of that research, but it's in a cleaned up model, which is in a UTXO setting. So we, again, get all of these nice benefits from UTXOs, but we don't lose the user experience or behavioral elements of what we get with Ethereum. So it's a really nice model in that sense. And then scripts just allow you to make a transaction, and you could say call multiple contracts. So for a prove and transfer from, you have to make 2 transactions in Ethereum from the origin sender, which is ridiculous. Why are we doing that? That makes no sense at all, and it should never have happened. And the main reason why is because of just the design of Ethereum itself is funneling everything through single accounts, and that restricts you. So, you know, with, again, a UTXO model and with scripts, you can just have a script that calls, approve and then transfer from in the same transaction, and that's it. And you don't need to deal with that anymore. So it's really not crazy. It's really actually pretty simple. And again, just you can read all of our work and our research on this. So it's all public and available. you can try the testnet. In our testnet, we do that already. So it's, yeah, anyway.
So the question was, how does Starkware look at this question of state management? And basically the question we're asking is, how do you parallelize? How do you parallelize stuff, roughly speaking? So the Starknet at the moment do not do parallelization as of now, because we were focusing on making the whole thing work, right? We had a new VM, a new language. We focused on making things work. And so we went for the simplest model, which was the one that was used and bulletproof by Ethereum. And now that we have like all the feature set, we are focusing on actual execution scaling. So I just want to separate verification scaling from execution scaling. And so one of the things we are going to have relatively soon, which would dramatically improve the throughput of the system, is optimistic execution. So it's not an ultimate solution. It's has some downtime. It has theoretical negative adversarial reaction that could be impactful of the network. We are planning to solve it one after the other. It's not right now. We're focusing on bringing scale. Another thing that we're looking into, which is within the line of this deterministic parallelization that UTXO enables, we are looking at various data structure, like a model that exists in the space. We look at Solana, we look at Aptos, we look at Sui, we looked at all the sort of like chain that are actively building through parallelization, and look at how they did it. We still wanted the account model because it's a lot simpler, and we already have enough mind change with like the new language. So we focused on keep it simple in that sense. But we are looking, as I said, into the new ways others are doing and take the best idea that exists there. So you should expect more on that front in the coming month, but there is nothing to announce because it's still in the research phase at the moment.
Alpha drop. No, but Starkware does have parallelization, but at the verification level through recursive proofs.
Right. But that's not okay. So that's actually so we are focusing on the scaling of the execution and the VM itself. The parallelization, the recursion enables you to do parallelization of the verification. But you have to know today on Starknet, verification is not an issue whatsoever.
Yeah.
Like the verification, proving is not the issue. Right now, our problem is the sequencer. Our problem is that our execution layer is pretty bad at the moment, and we're working very actively to improve it by 100x roughly in the coming month. And so, recursive proof does enable you to scale the proving. It also enables you to scale the execution by basically going into fractal scaling, which is basically the ability, for instance, to have a Starknet over Starknet. And so what before was talking about this ticketing solution that they shouldn't live in the same environment than Uniswap. Then using an L3, you can have this ticketing with the same requirement, the same trustlessness than you would expect on the regular L2, but in an environment where the fees are more stable because there is no sort of strong economical incentive to build DEX and so on. To answer your question, all those parallelization topic is very high up into our roadmap. They're still into research, and we should expect to have things coming to production in the coming month, but I have nothing to show today.
That makes sense. So speaking from the perspective of, say, a dApp developer, not a protocol developer, who is trying to use one of your systems, throughout the panel, all of you have dropped some really, really interesting paradigms. Let's talk a bit more. I know Fuel spoke about having these scripts, and Starkware spoke about having no EOAs whatsoever and direct contract wallets, and you use the term programmable privacy. I'd love for everyone to think about what these new features are, but thinking about it from a developer or a dApp developer perspective.
Yeah, I mean, from a developer perspective, at Fuel we look at it mainly from a few different points of vision. My own, which again is reflective of many, many years of trying to build apps on Ethereum and struggling with a lot of key things in the system that make both the developer experience horrible, but secondly, the end result being a sort of odd, disjointed experience between the wallet, what the wallet can do, and then what the application can do. And then as well, the kinds of applications you can design. So with Fuel, we open up a lot of the compute, so you have far more available to you. You have far more memory to use. You have far more just general compute to build anything you want. You have more options for user experience with things like account abstraction and with kind of other aspects like native meta transactions. So in Fuel, you can have a party that just builds a piece of a transaction, then you can have another party that just tags on the fee on the other and just send it, and that's it. And you don't need to have this situation where it's like you have to wire through 5 contracts to have some form of account abstraction. So I think from a developer perspective or looking at the space, the thing is there is always going to be hurdles with a new execution environment, with a new development environment, with something that's bridging liquidity. So you're bringing your USDC and everything from Ethereum into Fuel. But the result is that once you're there and once you're actually using it and once you're actually seeing what's possible, I think developers can open their minds a little bit to where Ethereum should go and where it will be soon, once we go to mainnet.
Yeah, native meta transaction is pretty cool. I know quite a few companies would like kill for something like that. But also, I assume when you said memory, you didn't mean like how in Solidity we have like string memory ABC, you meant more like RAM or something.
Yeah, I mean literal RAM. Yeah,
Literal
so
RAM.
just having a lot more access to RAM and memory and being able to do a lot more with it and across many other contracts. So just having that kind of access is enormous. It's huge. It gives you so much more flexibility because with the EVM and Solidity paradigms, you're so constrained by so many factors. The kinds of designs you can do are extremely limited. So from my personal perspective, I've walked around Devcon a lot. I've heard a lot of new designs for a lot of new DeFi. And to be honest, it's still okay, but it's not what is possible. Like there is so much more, and it's good, but there's a long way to go. Yeah.
Yeah, Joe, go for it.
Yeah, I was just gonna say, I think it's like maybe healthy to kind of also tell developers that not every kind of VM is going to be suitable for them. So we focus on privacy, and you work for Reddit, and Reddit has a points system that's public. So like that's not really a good fit. But a high throughput VM that kind of focuses on public data may be a better fit. So some of I think our competitors in the ZK EVM space kind of pitch everything as possible all the time, and I think that wastes a lot of dev time because you have to kind of go through the test net, try and build something, and you realize kind of a while later that it's not possible. So for Aztec, what we really care about is applications that have private state. That could be things like ZK Games, consumer finance, which just doesn't exist on DeFi today. We have over-collateralized lending. You can't really have consumer finance unless you're willing to have a public passport, salary, address on chain. So I think privacy is kind of what we care about. You're not going to build an AMM on Aztec because by definition it's the ratio of 2 public pools. So being really transparent about what you can and can't do, I think is something we all need to do to help attract the right developers.
So like instead of storing variables in the contract itself, you'd store it in your address kind of thing.
Yeah, so each user basically controls their UTXOs, which are encrypted, and you can feed those into an Aztec transaction and prove something about it. And then kind of in an Aztec program, if you prove that your salary is above X, you may be entitled to a loan or not entitled to a loan. So having that data being able to be fed in as an encrypted input to a program is really powerful in our case.
So you mentioned how some zero-knowledge VMs are now realizing some of the things they ran into. Can you expand a bit more, just for all of us?
I just mean, like, I think you need to kind of... Let me think a second.
Go ahead.
It's hard to do privacy in some applications, is all I'm going to say, and then I'll see what Louis has to say about that.
I mean, 100%. And so Starknet is not built for privacy whatsoever. Yeah. But that's not nature. What's true is that you can build privacy protocol on top of it. And so I was literally saying in a random idea yesterday to Joe here, Why not Noir? I mean, Aztec and Noir as an L3. You know, I mean, there is no reason to not. You could have, this scale of composability, just not the same purpose. So you ask what kind of things you can, things you can build. So the main thing that you can build on StarkNet, I always give as a dev, the only thing you care about, 3 things, which are you get cheap computation, cheap cold data, and account abstraction. And you get a 3.5, which is a long-term vision of scaling, which means that even if you're priced out of this layer itself, you can go a layer up, which will be cheaper. So what you get when you get those 3 things, you start having new project. So I named before, the ability to, account abstraction gives you the ability to sign with your phone without having private key per se. It's your phone literally is a private key. So now when you combine, for instance, cheap computation, you're starting to have people making physics engine on the blockchain. So we have someone, a company called Topology on StarkNet that is building a physics engine. So you can prove collision, you can prove games that's existing in the 80s or 90s, worms, you can make that happen directly on chain. You can implement things like infinite risk, an infinite map using Perlin noise or still advanced algorithm that generate maps. And we have those people making it today on the ecosystem. So when you get cheap core data and cheap computation, you get things that were not possible in Ethereum before, like practical storage proof. So if you're not familiar with storage proof enables you to prove the state of ETH in the past to ETH in the present. So why is that useful? So it's useful, for instance, for voting. So when you vote, you basically vote using the token balance that you had at that proposal. Same variation. And so this company called Herodotus is building this, and they already have a snapshot trying to create L1 voting through L2 using their tech. Now the amount of so what else I think very exciting, I feel. We have a lot of on-chain gaming, because on-chain gaming was completely priced out of Ethereum. And the proof is, the only existing on-chain game today on ETH is basically on Gnosis chain. It's called Dark Forest. Yeah. So we have seen a massive boom of projects that were priced out that couldn't build on ETH, building on us. Things, and even flagship like Loot, literally building their own universe on StarkNet right now.
Thank you so much. Yeah, I know we're running out of time. All I'll say is, to all the dApp developers, I think because we work in crypto, we kind of owe ourselves to test and prod. I say that as a meme, but what I really mean is, I think we are here to experiment and try these new languages like Sway and Cairo and Neuer and stuff. So I hope you all actually go out and at least read up on what these cool things are doing. I know if you have time, but we are happy to take 1 or 2 questions if anyone has. Yeah, anyone has any questions here?
Hello, very interesting talk. I have a question. Why each one create their own different language instead of using something more standardized like Circom or even I don't know, C++?
I'll just say for our case, none of the languages other than Circum are built for kind of private state, and we found that Circum was too low level, and we're trying to target kind of Web 2 developers or Solidity developers, and they shouldn't have to kind of know how to be a cryptographer. So our language abstracts the cryptography part, so you can just write an application, and nothing was out the box.
So is it working? Yeah. Circum is not Turing complete, as simple as that. And so if you want to do an if statement, which you kind of need for, so StarkNet is an OS. The real name of StarkNet is an operating system, right? StarkNet OS. And so every sys code in StarkNet is written in Cairo. So if you don't have a if statement, your program is going to be quite big. So another thing that Circum doesn't allow you to do is being able to prove multiple programs within the same proof, which is something that Cairo through Sharp enables you to do. And so we needed to create our own language for that purposes. And finally, Circum is, I guess that's actually true. Right? We target in Snark, but that's not really, yeah, remove that part. But yes, not Turing complete, not being able to prove multiple programs using the same proof.
Yeah, and in our case, we really didn't want to create a new language. We looked at a lot of options. The main reasons are some of the existing programming languages like C or Rust, for example, they're really not designed to target a blockchain, and there's a lot of different ramifications around targeting a blockchain system that you want to catch in different stages of the compiler. So that was one strong motivation for us to have our own language. Secondly, the compiler and the tooling have to work really hand in hand. So in a blockchain environment, you want the developer to have extreme control over every aspect of the system so that they can really simulate everything. So the developer experience was another. And lastly, we wanted to create a Rustish-like language that really targets blockchains, not just the Fuel VM. So the way that our compiler is designed is such that, and this is unlike others in the space, it's designed to be very modular. So if we want to target a backend, like Cairo, or we wanted to target the Mine VM, or we wanted to target a different language, the language ecosystem will be set up to target many different kinds of blockchains, including the EVM. So one we're working on right now is targeting Yule, and that's with Foundry. So you'll be able to use Sway and maximize its value and its design without having to want to rebuild languages again. Now, mind you, I think some of the ZK teams have different criteria at different stages of the compiler that they really have to factor into their design. So, we can't speak for all ZK VMs or anything, but it's a good harness of a blockchain language that's Rustish that people will like. Yeah.
Thank you. Any other questions?
I'm not sure how relevant the question is to your environments because I haven't looked too deep into it. But if you build something like an Uniswap on it, which excludes Aztec already, would MEF be a problem on those networks as well because the indexes could sort transactions differently, or is it somehow solvable?
We have right now on StarkNet, I think, top of mind, 5 different Uniswap v2. So the answer is no. It's not a problem. And no, that was a joke, but no, it's not. StarkNet currently uses exact same data structure model than Ethereum.
So it doesn't really exclude Aztec. We have swaps from Aztec Connect to Uniswap, and probably the most liquid Uniswap because it's on mainnet, so liquidity doesn't get fragmented. We just have to kind of acknowledge that Uniswap's a public application, so we can't make it private, but we can make the users private. So users come to Aztec, and in this case, they bridge out to L1 in a batch to get scaling and privacy. So yeah, it's possible, but it just requires a different kind of paradigm to normal scaling.
Yeah, and then for us, we don't make any claims about MEV, so you could probably extract it if in a decentralized sequence setting. But I will say that we actually take a slightly different approach in the sense that we actually want to give the node as many abilities as possible to extract as much MEV as possible, or provide teams that either try to fight MEV or actually try to advantage it, the best tools that they can have, because we don't have a solution for it, but we know there's incredible teams either advantaging it or trying to reduce it or solve it. So, but either way, doing MEV facility and fuel should be very interesting. Yeah.
For internal Aztec transactions, they're kind of, if they're fully private, you can't see what's happening. So our approach is usually to try and push it to L1, and then you can use something like flashbots to kind of solve it in the way we currently know how. But yeah, if there was kind of public components to an Aztec L2 application, then there would be MEV on the network. But yeah, I think trying to push it to L1 is a good strategy.
Cool. Thank you so much, everyone.
Hello, hello. Hello, is it working? Yes, right, thank you. Well, hello everybody. First of all, I would like to thank you to the Devcon organizers for giving me the chance to do this talk, and also thank you, all of you, for attending the talk. My name is Ignacio Ramos. I work for Polygon GKVM, and I am at the protocol team. It's been a year and a half that we've been working very hard to release the ZKVM, and I am very happy and very proud to announce that on Monday, it was announced the release of the ZKVM on public testnet. So I will ask you to do an applause for all the Polygon team that they did that effort, that it's enormous. So thank you very much to It's good to start a talk like this. So the title of the presentation is GKVM versus EVM, full equivalence. Okay, has a delay. Okay, so a little bit, what are we going to talk about? First of all, I will do like an overview to give some context about what is a ZKVM, and then I will go more concrete on what is the Polygon's ZKVM. After that, we will go like to the topic of the talk, which is the difference between the ZKVM, the Polygon's ZKVM, and the EVM. So, what is a ZKVM? There are some, well, there are the three statements that I think that they define the minimum of a ZKVM, which is that it is a virtual machine that executes smart contracts in a way that is compatible with zero-knowledge proof computation. And why would we like to do this? Because our expertise is scale Ethereum. We want to increase like the throughput of Ethereum, the transactions per second. At the same time that we lower the fees. So how can we do it? We use zk-SNAR technology to make cryptographic proof of execution of Ethereum-like transactions. In a summary, now when you process like a batch with a lot of transactions, you get a result, you get an output, you get a state. So how can other people, how can other ones to trust you that this process of the batch has been done with correctness, has been done correctly following like the EVM constraints. They have to process also those transactions and see that the output is the same. With zero-knowledge proofs, we can like do it easily because we can, after processing all those transactions, create a zero-knowledge proof, and if someone wants to validate that these transactions have been processed correctly, like following the constraints of the EVM, of the ZKVM in this case, they only have to verify that proof, and this is faster. Also, the verification of a proof, it's always constant, which is very interesting. Actually, this is like a game changer in the ecosystem. So, I remember it was around the FCC that a lot of companies were doing like announcements of releases of ZKVMs, and it created like a lot of noise, especially in social media and in many places. And a lot of people was very confused because a lot of new words appeared there, like compatibility, equivalence, what is the prover, I don't know. But luckily, we have like Vitalik, that he did a very interesting blog. I strongly recommend it to read it, when he classified the ZKVMs in 5 times. He created what I like to say, like the ZKVM dilemma. Like, if you have more performance, you have less compatibility. And if you try to have more compatibility, you will have less performance. Actually, at Polygon ZKVM, we aim to be from type 2. We are not there yet, because we still have to finish the precompiles, but we will be there very soon. Actually, we are like 2.2. So, the advantage of this type 2 is that it has a lot of compatibility. It has as much compatibility that we can talk about equivalence. The disadvantage is the performance. In Vitalik's post, he said that it takes like a lot of time to generate the proof. Well, this is a bit relative. I mean, what is a lot of time? Now we are generating proof in around 5 minutes, but we still know how to do it, and we have a lot of ideas in mind and how to reduce this to up to 5 minutes. And also, it's not that a big problem because you also can like parallelize the proofs. So let's go to the Polygon ZKVM. First of all, I would like to explain like very simply, when we talk about equivalence, what are we talking about? We're talking about that putting the batch of transactions in the EVM and putting exactly the same batch of transactions or the same block or whatever to the ZKVM and get the same state. And when I say state, it's like the same state root. And when they have like the same state root, it means that the storage, the state of the blockchain is exactly the same. It means that all the accounts have the same balance, with the same nonce, with the same bytecode, with the same storage, with whatever. They are exactly the same. So are different black boxes because internally they work differently, but the equivalence means that for the same input, they have the same output. So how we do this approach? I could be like a lot of time explaining how we've done it, and there's people here sitting that could explain it by far better than me. So I just do like some sentences just to put some context. Also, it's not the topic of the talk, but we can discuss about it later. But at the end, what we are doing is a processor, okay? And a processor has clocks. So each clock is like a new state, and we are playing with these new states as steps. So as all processors, you can build an assembly at the top of them. You can build an assembly language to define these steps. And this is what we've done with a language called ZK assembly. With ZK assembly, we try to replicate the behavior of the EVM in an assembly language. When this assembly language is compiled, it creates like a build, which is a big trace of all the steps that define the processor. On the other hand, we have the PIL, the polynomial identity language, with its like one step more of Circom 2.0. It's also a language done by our tech lead, Jordi Bailina. And what the executor does is that he gets the ROM, which is the build of the ZK assembly language that I just explained. He also uses the PIL, where there are the state machines of the Ethereum defined there, and he like verifies the correctness of each one of the steps of the ROM while it processes the transactions. So more or less, this is how it works. Like, I'm just scraping the surface. That this is how it works, the ZKVM. And of course, as all other processors, we also have a RAM and a storage. Now let's talk about the variances between both of the EVMs. First of all, the storage. As you may know, the EVM uses a Patricia Merkle tree, while we are using a sparse Merkle tree, where the leaves are indexed. In each leaf of the EVM, we store it stored all the information of the account. They have the nonce, the balance, the storage root, and the code hash. But we are doing it differently. Oops. Something happened? Oh, no. Because I'm moving. We are doing it differently. On each leaf, we only store one property of the account. So this brings me to the second difference, which is the hash. For the EVM, it's used the Ketchak. But we are using the Poseidon with the Goldilocks prime number as the finite field. This is for performance reasons. So when on Ethereum you want to get the key of a leaf, you have to hash the address. But as we only can retrieve like one property of the account for each leaf, we have to hash the address with a property key. For example, if we hash the Ethereum address with the property key of balance, we will get the leaf where is stored the balance. Another difference is that Ethereum uses more than one tree to define all the system. As you can see here, in one of the leaves, there's the storage root. The storage root points to a different state tree where the storage is stored. We are doing it differently. We only have one tree that defines the whole system. Another difference is the memory. The EVM uses for each slot of memory 8 bits, 1 byte. And we are using 256 bits, that's like 32 bytes. So we are working with a bigger memory slot. This makes that when you are querying to the memory, the information that you get is the same, but the way that you obtain the information, it's a bit different. I mean, the internal logic of some opcodes had to be changed a bit. I will show you an example now, for example, for the opcode mload. With mload, you load 32 bytes from the memory. So, well, there are different cases. Some are more tricky than the other ones. This is the easiest one. When you want to get just 32 bytes, you just ask for it, and you have to return the full slot. In our case, it's the full slot because we have a slot of 32 bytes, the full slot of the memory. In case of the offset, is different from 0. Well, when I say different from 0, I'm talking about mod 52. It means that the beginning of the slot is not the beginning of the memory that you want to retrieve. Maybe you will have to get like half of the memory from one slot and half of the memory of the next slot. And it gets a bit more tricky, when you want to retrieve more than 32 bytes. In this case, for example, more or less than 32 bytes. In the first case, for example, we are only retrieving some bytes of one slot. In the second case, just the bytes in the middle of the slot. And in the third case, it's like if you want to do it with an offset different from 0 and also more than 32 bytes, then maybe you have to get some bytes from one slot, then get the whole bytes of the following 3, 4, 5 slots, whatever the length is, and some bytes from the last slot. The CK counters, yes, another difference. Probably this is very new for a lot of you. I will say that the behavior is like gas, but it doesn't replace gas. I mean, we are computing the gas exactly the same way as Ethereum does. But as I said before, we have like a limited number of steps in the processor, right? So when you are processing a batch, you have a limited number of steps. And also you have a limited number of state machines that you can consume while doing an opcode or an operation. So in our implementation of the zkVM, I will show an example just after this slide, we have to check that we have enough counters to process that opcode. If we go out of counters, for example, the zkVM throws an error, which is out of counters. This error is not user fault, actually. It's like a fault of the executor, but it can be solved easily, like processing this batch, but with less transactions, because it means that the counters, the number of counters to process that batch has been exceeded. Here we have the name of the different state machines. For example, the binary one, it just consumed when you compute a binary operation, or the key check when you do a key check hash. I will show you an example of an opcode. Well, it's a widely used opcode. It's the equal one. The equal opcode, he compares the two last values in the stack and checks if they are equal. As you can see, this code is from GK assembly. As you can see, the first 2 lines, here I am checking that I have enough counters to process that opcode. As you can see, the binary, I'm checking I have at least one binary counter for the state machine of the counter, for one binary counter to process this opcode. It's because here I use the equal, and the equal consumes one binary. Also, I check the steps. Each one of the lines of the ZK assembly is a step of the processor. Here I put 120, although the number of lines is less. It's because I will go to read code, which means that all the process has been correctly in the best case scenario. But in the worst case scenario, I may fall out to a stack underflow, or maybe out of gas, or a stack overflow, and I will need some more steps to handle this error. So this will be the example of the ZK counters. Let's go to the following difference. Yes, we don't use the self-destruct. Actually, this is a difference now. But we guess that it won't be a difference in the near future, because probably Ethereum will accept the EIP-4758, where it replaces the self-destruct by send all. So we're not using self-destruct from the very beginning. We are using send all, and I'm happy for it because self-destruct creates a lot of problems. What does the send all does? Instead of removing the bytecode and the storage of the account when you call the self-destruct, what it does is to empty the account and send all the balance of the account to the account caller. At the end, we're just following this EIP. This is also a difference that will disappear in the next months because we are really working hard to finish this, and this is the why we are not still type 2, but as I said before, this will be over in a few months. Actually, we only support 3 precompiles from the EVM. We support the C recover, the identity, and the ModX. And this is one of our priorities. We are working to finish them all. Actually, the SHA 2.56, it won't be that hard because we've only done the easy recover. Maybe the easy binding, it's a bit more tricky, but well, we're working. It's work in progress. Okay, some other difference that they are minor or faster to explain. Spoiler. Okay, one of them is the opcode of the Xcoded hash. Obviously, if we are using a different hash, we're using the Poseidon instead of the keychack. This Xcoded hash, it's returning the hash with Poseidon. Also, the block hash, well, this one, it's not really a difference because it's not a variant because now on the EVM, you only can get the block hash of the last 256 blocks. Now we are supporting to get it from the blocks, all the blocks in the blockchain from the very beginning. And the memory limit. We have a limited memory of around 40 gigabytes. This is different from the EVM because the EVM is unlimited. The limited is set by the gas, and you can put like 50 million gas in one block. Actually, this limitation makes that in a batch, you can put 8.5 million for each transaction. That this is the cost of the memory expansion, and we won't have any more memory. But I have to say that a transaction with 8.5 million gas should be enough to do whatever you want. It's also very easy like to do different transactions. If you have a very big transaction, it can be like split in different ones. And also, this is currently this last one. It's a different now, but it won't be a different anymore because we are also working on it, and it's one of our priorities, which is that we are actually not supporting EIP-155 and EIP-2718 transactions, but it's a matter of time. So, in conclusion, well, you all have seen the slide from before, but this is like now the most important moment of the of the presentation. No, why is it happening? No, exactly. It's that we are passing the 97% of the Ethereum test suites. Thank you. Yes. Actually, I think we're very proud of it and we're very happy because I think that it's like the most empirical way to check the equivalence of between a ZKVM and it's not finished yet. It's moving along, I'm doing nothing. Okay, what I was saying. Yes, I think it's the best way and the most empirical way to show to the people that we are compatible, we're equivalent with the EVM. So this is the final remarks. We are fully EVM equivalent, and I also would like to send a message like this in the second point, which is that the difference that I've been explaining now, most of them are for aim to be more equivalent and with a better performance. I mean, we've been building the ZKVM with a different toolkit that what was done with the EVM. So we had to take like some technical decisions with different tools, but to reach the equivalence, also taking in account the performance. So I think that maybe also we have learned a lot from all those years of the EVM processing a lot of transactions. And actually, I think that probably people from the Ethereum Foundation, if they had to do the EVM again from the very beginning, they will do some things different, and some of the things are the ones that we're trying to do. Like we've learned from them, we've learned from the EVM, and we've tried to do it better. And finally, to finish, just tell you that what I said at the beginning, we are on public testnet, so we really encourage everybody to try to crash it, try to test it, play with it. I mean, it will be very good for us if you crash it, so we can find a bug and we can iterate and deploy again, fix the bug, and all this. So just to finish, thank you very much for. Yes, thank you very much for being here. Hope you enjoyed the talk. Thank you.
Uh, uh. Okay, I'm starting in the next few minutes. And who got the swag? Yeah. So these people, maybe if you sit down next to each other, just say hi and just scan it. Don't scan without saying anything. Just be friendly. Okay. we have a few minutes. There's more room on this side, so if you guys can come over. And again, while waiting, if there's someone who has a swag on your side, just say quickly hi and just scan. Okay. Hello guys, how are you doing? Good? Okay. So, my name is Makoto, but in ENS, it's matoken.is. How many people got this swag things? Great. Okay. So probably for some of you, I was a man behind, between the nice swag and the you. So just making sure you guys are QR code and all that stuff. But I'm hoping that now I don't really have to explain what ENS is. So it's basically a Web3 username. Whether you go to POP or Etherscan or OpenSea or ECXYZ, it's all matoken.is. So that's my name. And so today, I think this room is mostly in a theme of L2 track. So we are going to talk about kind of L2 off-chain, interchain strategy on what ENS is doing. And we are actually been doing since kind of 2020. And there was a lot of talk and work going on, but people are not quite sure where we are at right now. And it's actually some of the feature, it's still in the halfway of the roadmap, but some of them are already available. So first I'm going to explain what kind of the cross-chain example already available to you. So this one doesn't really require any technical knowledge. Then I go a bit deeper to the underfoot. So probably I show a bit of code, so mostly for devs, and for what's next section is what's going to happen in the probably a bit technical. Okay. So number one, cross-chain example in the wild. Okay, so for some of you may know, Coinbase, one of the biggest exchange, recently announced that they decide to issue subdomain to all the users. I think there's a couple from the Coinbase. You want to raise your hands? Okay, thank you. Woo! And it's great because whenever you go to exchange, you change, you get your fiat to Coinbase. Then if you want to move into somewhere for the DeFi, then first thing struggle is how to send to Ethereum address. And I think it's great that it's being ENS is available from the as soon as a new user got on board with crypto. And I got makoto.cb.id because Matoku is already not available, unfortunately. But if you go to your profile page, and another thing is, so Coinbase has, I think, Coinbase.eth, but they chose cb.id, firstly because it's a lot shorter. And another thing is, ENS is not just about .eth. You can actually import your internet domain as a Ethereum name. So Argent wallet has a .xyz, and you can have .com and stuff. So they decided to use cb.id to import the DNS to ENS world, then decided to issue subdomains. So once it's done, you can see my handwritten avatar and website and the email address. And if you look into this, our ENS manager, you can actually see the same thing. So it's the data which is stored in, I think it's in a database in Coinbase, is proxy through basically Ethereum layer 1, so that any dApps or wallet can actually access the data. And the great thing is the user hasn't paid any single gas. And another interesting example, so I think Coinbase case was in completely off-chain in the database. So Lens is another Web3 social network, which provide a user profile. And how many people have Lens profile? Okay, maybe half of it. And so this Stani.lens actually have a ENS Ethereum address associated with it. And something you might not know is it's actually, that's also a proxy to the Ethereum L1, ENS, and on layer 1. So if you actually look into it, you can actually see that on our ENS manager. And this is kind of recent release, but now MetaMask supports, so that like if you try to send, I mean, no one really has to send ETH to Stani, you know. If you want to, you know, you go to stani.lens.xyz. That's already available. And this is another interesting thing that, like, so optimism. There's some community user just posted on our forum that, hey, we created a name service, and they actually just forked what we are doing, and they created a kind of NFT, and they decided to issue subdomain on their NFT, and it's actually available on Optimism, which I didn't even know until he posted it, which was kind of crazy. And but I do explain, there's some nuance on the difference on how you do, he's doing, and what we could do in next chapter. And this is a really, really, really crazy thing. Is like, so I'm saying like off-chain, which can be anything. So I showed like database example. I showed you the lens is basically the Polygon other EVM example. This is literally the Google Doc, and someone put the kind of integration so that if you type the data into the Google spreadsheet, it actually updates, which is kind of crazy. And yeah, I only got to know because someone tweeted it. So this is it's called sheets.is, apparently. Sorry? Oh, you made that. Oh, hello, hi. Yeah, say hi to you. What's your name? Jing. Okay, yeah, so that's his thing. So if you have any question about integration, speak to him. Okay, hello, hi. We should, change this thing. Okay, nice. Okay, so so current state is, so these things we've been doing, it's not something you can do it without any integration. So we actually talked to many partners and the integration partners to integrate this thing fast. So if you're a dApp developer, if you want to have these like Coinbase subdomain or a Lens subdomain or a Sheets subdomain, as long as your dApp has Ether.js later than 5.6.2 or Web3 Pi v6 or Web3.js v493, you already have the feature integrated. And also, I think nowadays people use framework kind of tool like WagMe or use dApp. Because they use Ether.js underneath, that's already supported right away. And for the wallet side, there's a wallets like Alpha Wallet, Argent, MetaMask, Umbro, Coinbase, Trust Wallet, Wallet Connect, and Etherscan. They all integrate. So if you're using these, you can actually send money to basically Stani or like any Coinbase user who has CBID subdomains, if you want to. And so, yeah, what's common across? Oh yeah, I just realized I can just read that. Sorry. Okay. So what's common across this example is basically storage agnostic. It can be database, Polygon Optimism, or Google spreadsheet, and depends on the storage. Yeah, if it's in like a L2 or sidechain, you might pay a little bit of gas. If it's in off-chain, completely gasless. And interesting thing is, like, I think most of the time, like, if you use different chain, first things you have to do is like you go to MetaMask and change the network ID and the stuff. You don't have to do it because you don't want to know which chain these users' data are, and like I don't want to know like where data is for the Coinbase users or Lens users. So that for the read-only purpose, data is all available through L1. And this one I will explain later, but we call it kind of trust not minimized. You'll find out a bit more detail. Okay, so under the hood, so if there's any, pretty much all the things I'm going to say is in this docs, ens.domains. And there's a QR code. So if you are interested, you can just take a shot. And sorry. Yeah. Okay. Thank you. Hello. Hi. Thank you. Okay. So now I'm going to go a bit detailed. So ENS is one of the kind of oldest smart contract available that it's been deployed first in 2017, and it went through like almost like 4 or 5 years. And the basic model is we have basically two big components. One is called registry, where it's just a big gigantic dictionary key value store. And instead of registry has the value, we return. So for example, in this example, you ask what's the user says what's the who.is has. In example, it returns 0x1234, which is another smart contract called resolver. And the resolver is the one, if you ask the resolver what's the address of who.eth, that returns the actual Ethereum address. So that kind of two ways, right? And the reason we did is the flexibility that once you kind of change, it's very difficult to change smart contract once it's deployed to ask everybody to point to the new one. But if you have a resolver, each user or each name owner, this is important to understand, is can swap the resolver and have their own custom logic, or if we release a new feature, you can upgrade to the new feature or by per each user, per each domain. Okay, so this is a basic. And with this in mind, what we do with this new interchain, cross-chain thing is something called CCIP read, also known as EIP-4668, secure off-chain data retrieval. And what I'm going to explain is it's going to instead of the two-step model of the existing resolver, it's a three-step model. And I call it revert, request, and verify. Okay, so what it does for the first time is, like, for example, if you go ask for the data on the resolver, instead of returning the data, it actually throws the exception called off-chain lookup. So like a revert, this error message came from, I think, Solidity 8 point something. And this interesting thing is, like, basically it returns a different kind of data type by calling the same function, so that like you don't have to, client doesn't have to know whether the function call is towards L1 or L2 or other place. It's just like it reverts and it catches, and then once you revert, you catch the revert message. It has the information about this address, which is a resolver. Then it has something called URL, which is we call a gateway server, and plus the call data, which you send for the function call, and off-chain resolver. So this is, I think, the function type of the function which you're gonna call once the gateway returns results. Okay? And the code is a bit old, so there might be some consistency. So step one, revert, and that's Solidity code. And once that's done, am I okay with timing? Yeah, and so this is a web service, the URL. You just catch in a revert. You call this web services, and the things it does is first line is server.add is just like a function. CCIP read server library offers like for any of the web services you have, you can kind of chuck in this capability easily. Then what you do is you basically query the data from somewhere. It could be database, it could be a sidechain, it could be Google spreadsheet. Then after that, we basically ask the gateway to sign the data, and it returns back to the client. And then once it's returned, again, this is in L1, that it basically calls this function to, and you decode this signature, and you check like who verified. And if it's verified by the gateway, it was specified in a revert, we say, okay, we trust this gateway service, so like hence we return the data. So by using smart contract to be kind of proxy, user can retrieve the off-chain data without switching MetaMask or not knowing any other information. But all these things are kind of encapsulated, especially using Ethers.js. So most daily use, you don't actually even see it. But if you want to do directly with the interact with smart contract, you kind of have to know. Okay. And okay. And so once the basic logic of the off-chain data retrieval is explained, next thing you also have to know is another EIP called ENSIP10. So wildcard resolution for issue subdomains. Like one thing you need to know in the case of, we are talking about biggest use case as issuing subdomains. And when you go to, for example, cb.id, cb.id does have contract, resolver contract on the L1, which basically acts as a gateway to off-chain. But the subdomain actually doesn't have any data on L1. And what it does is, this isn't just another rule we define in a client level, that if I have a, let's say, a matoken, in this example, it says a.matoken.eth, and if a.matoken.eth doesn't exist, nor doesn't have a resolver, the client library asks to the parent, in that case, matoken.is, to say, do you know anything about your child? Then that child could goes to L2 or off-chain and get data. So that's how kind of allows you to issue subdomains, which is gas-free, because it doesn't exist on L1. Okay? And so the consequence of this approach is, first, so no on-chain event for issuing subdomain or records. So quite often, when you build dApps nowadays, you kind of rely heavily on something like subgraph to retrieve data with strict information. In current specification, we don't have that. So in our case, we kind of hard coding, like, especially if you have done any coding on the ENS. For example, text record, key value store, which key has been set, we actually or which coin type has been set, we actually retrieve from the subgraph, the graph subgraphs, and because the graph information doesn't exist, we actually basically hard code. And if you look into the ENS manager, and if you look into the subdomain of the CB, my address, so all the money could. So protecting the gateway has some security concern, and for that reason, if you have a gateway, you have to deploy gateway by yourself. You can't let other people to deploy gateway and use their own. So that's kind of limitation of current approach. However, it's here and it's working. So another photo time is that if you want to try out this approach into your app, this is a QR code to take a photo with me smiling. Thank you. Okay. Ready? Okay. And so what's next? And so we are kind of, as I said, it's kind of halfway. And so we did the off-chain data retrieval, ticked, and basic library and wallets integrated, ticked. And so there's 3 other things we kind of have to solve to go to where we really want to achieve, go. And the first thing is called CC. I was about to swear, sorry. CCWDP, aka EIP-4488, is called Cross-Chain Write Deferral Protocol. Did you guys come up with the name? This is like so difficult to remember. But I think it's the joint EIP with, I think, Coinbase and Nick Johnson, I think. Is basically so far you saw that all the data can be retrieved on L1 so that you don't need to switch network to read the data. But once the next step is actually you want to let users to update the data. And currently, I think in case of Lens have its own interface on L2. So like you have to know that you have to update on Lens. In case of Coinbase, you have to know that you have to do it in a Coinbase basically extension. But this one kind of use a similar approach to CCIP read to return the where you need to kind of read points to your endpoint or like a URL to update the data. So this is kind of fresh Oh no, it's June. So it's been a day, but I only get to know like a few weeks ago that this existed. So it's fresh, but like there's already draft, so you can take a look. And next, so yeah, trust minimize resolver equal rollups. So far I was talking about quite kind of centralized approach, like you have to trust the gateway. What we have designed is going. So yeah, one of the stuff about rollup is the fact that like most of the rollup, whether it's a kind of optimistic or ZK, that their basic principle is to batch write L2 data to periodically batch write data into L1. That means you can actually verify the state of L2 on L1 using L1 contra. So yeah, optimistic rollup uses fraud proof, and ZK uses validity proof. And my understanding is that Optimism or like Starkware, all these companies listed, they do have basic function. So once we have that function, what we're gonna, do I explain? How do I do? Yeah. Okay, yeah. So what we do is that if you go back to, I think I got rid of the code. So I'll explain is, here. So here it's just like retrieving the data and signing the message. But what you can do on the L2 rollup is like you can basically get the proof, data with the proof, and yeah, you construct the Markov tree, and on this verify stage on the smart contract, you can basically call. I forgot the name of the optimism code. Do you remember? Verify was state commitment something. Yeah, that's it. Yeah, call the function to verify, and by doing that, even if a gateway returns malicious data, oh, my time is already up. Okay, you can you don't have to trust. So that's is it completely up or another 5 minutes? Up. Okay, so I think I already mentioned. Okay. It's too slow. Yeah. But I think I'm almost finished. And there's a demo which we did 2 years ago for the optimism. So optimism, we know like how it works, and we are right in the middle of updating to the latest version. And yeah, I'll skip all the end. All the end, this now you took my photo, so sorry. So the QR code, so you should refer to. And the more important things is, yeah, we have State of ENS by Nick Johnson at 4:30. So yeah, that's it. Yes. Okay, thank you.
It's, yeah. Yeah.
It's a little slow.
Got it. Excuse me. I guess we can start. Yeah, sure. So, hey, everyone. Thanks for being here. My talk today is going to be about fast and furious withdrawals from optimistic rollups. So this doesn't work. Oh, OK. It's a little bit slow. OK. So a little bit about myself. My name is Massa, and I'm a PhD candidate. I'm doing PhD at Concordia University with Jeremy Clark in Montreal. And I'm also integration engineer at the Off-Chain Labs. All right, so what I'm going to talk about today is research that I was doing during the PhD, and it kind of co-located with the time that I was doing the job at the Off-Chain. So it's kind of a collaboration between the folks at the Off-Chain and Concordia. So it's a research. We are particularly interested in solving a research problem. But before I dive into the details of the problem, I want to take some time and talk about how rollups work in general and how optimistic rollups work. So you might have already heard from other folks during the conference, but it's always good to keep refreshing and make sure everybody's on board. So let's start with the question of why is Ethereum slow and expensive? So we know Ethereum is slow. There's a scalability problem with Ethereum, and it's really a fundamental issue. And why there is a problem is that let's say you have a function that you want to get executed on an input X, and if it was a cloud environment, the cloud service provider would give you the closest node in the network. And then what happened is you send the function to the node, it would execute the function for you, and it would give back the result, and you learn what the result is. But on the blockchain, because we care about trust and integrity, we can't really rely on one node to execute everything for us. So what happens on a blockchain is you send your function to a node, and what that node does is actually relays your function together with the input to all the nodes in the network. And what happens is then all the nodes in the network execute your function. So it's literally like you have to pay for each and every node executing the function for you. And then it takes some time because they have to run a consensus algorithm among each other so that they could all agree on the same output. And it's only that moment that you can learn the result. So that's really why it's so inexpensive. So this is really slow. OK, so but why is it that every node has to compute everything? So the answer is because they have to make sure that it's the correct thing. So let's say I have a function, I execute it for you, and then I come to you and I'm like, here's the output. So what is the most straightforward way for you to actually verify if I'm saying the correct thing? So you have to go and compute the function yourself, right? So the question people have been asking in terms of scalability of Ethereum is that, is there any way I can convince you that I've done the execution correct without you having to go and execute everything yourself? So there are two main approaches to tackle this problem. The first one is you can actually throw some math at a problem, and you create kind of a mathematical proof. So you run a function, you get the output, and then you kind of create a cryptographic proof. You hand it to me, and then I can actually verify the proof and see if it's a correct thing or not. So verifying the proof is less work than actually having to execute everything, then I actually save some money and time, right? So this is how ZK rollups work on a high level. So the way a ZK rollup works is you actually send a function to a node. The node would execute it for you, and then they create a cryptographic proof saying that this is a correct output. Now, generation of this proof takes a long time. It even takes like 1,000 times or even 1,000,000 times longer than when you have to like compute a function yourself. So that's kind of a hidden cost. But if like once you have the proof in hand, you can actually go and send it to the network, and then verifying the proof is really nothing. So it's really a cost-effective solution, especially if you're one of those nodes that have to verify those proofs. And the second solution is to use kind of like economics. So I'm like, I execute this function, and here's the output, and here's $1 million worth of ETH backing my assertion. And it's open for you to dispute. Anybody can come along, and they can prove that it's a wrong output, but they have to stake money as well. So the way it works is, let's say Alice is saying what output is right, Bob is saying the other output is right, and then there's a dispute and disagreement, right? And it's only in that point that Ethereum goes back to a normal blockchain mode where every node has to execute everything. So this is how optimistic rollups work, and we call it optimistic because we're really optimistic that not every node has to compute everything, because really nodes always assert the right output, and you see why. So the way an optimistic rollups work is that I execute a function, and I put an assertion, I stake on that. And let's say Bob is coming, and he says, this is the wrong output. So he files a dispute. So what happens is Ethereum would be like, hey, I know you guys are disagreeing on this output. I want you to pinpoint me to the exact step inside the computation where you started to disagree. So maybe you were fine for the first 30% of the computation, and it's only this little step where you started to disagree. So it's actually going to verify that little step. So it ends up being very cost effective, even if Ethereum has to step in. And that's why actually it's really not easy to get away with a wrong output, because everybody knows that at the end of the day, Ethereum can come along and it can settle things, and you can lose money. And then, that's why actually the only way you can get away with a wrong output is that nobody's watching the protocol. So at least one honest party watches the protocol, then you can never get out of it. Yeah. And yeah, this is how optimistic rollups work. And like in real world, it never happens, the dispute. Like in Arbitrum, there's never been a dispute before. Okay, I'm gonna get some water. All right, so let's see how it works on Arbitrum on a smart contract level. So what happens is Arbitrum puts two smart contracts on the L1, inbox and outbox, and what Alice does is she wants to execute some function, right? So what she does is instead of putting the function on L1 and having the L1 to execute everything, she puts a message saying that I want this function to be executed on layer 1. And it's only the inbox contract is going to record the fact that Alice wants this function to be executed. So what happens is somebody outside L1 comes along, they dump the contents of the inbox smart contract on L2, and then they're gonna execute everything on the ArbOS, and it's really based on like how they were sorted inside the inbox smart contract, and then they're gonna update everybody's account on the ArbOS, And then they put the output of this execution inside the outbox smart contract in the form of an assertion. So an assertion is basically a fingerprint of the latest state of the ARBOS. So Ethereum doesn't care what is ARBOS or how ARBOS works. It actually works a lot like Ethereum. It runs a blockchain. It has blocks. It has miners. We call them validators. It has block explorers, but Ethereum doesn't care about anything about that. It only cares about, like, here's the list of functions that I'm seeing that are going to be executed on layer 2. I want to see the output of this execution. That's all it cares about. So we have to wait for 7 days because we want to make sure that everybody have time to come along and they react to it if there's any dispute. And if there's no dispute, it's going to be finalized. So let's say Alice wants to do something slightly different this time. She wants to withdraw 100 ETH from L2. And to make that happen, Arbitrum has to introduce a smart contract, which is called Bridge. So Bridge's job is basically to escrow whatever tokens or ethers people want to move to the L2. So if Alice wants to withdraw 100 ether from L2, it means that she has previously moved 100 ether to the ARBOS. So what Bridge does is, hey, Alice, I know you're moving 100 ETH to the L2. That's fine. Just give me 100 ETH. I'm going to escrow it for you. And then I'm going to mint 100 ETH on L2 out of thin air. You'll be the owner. Do whatever you want. Go ahead, transfer it to Bob. And the end of the day, what I care about is somebody comes along and they want their ether back from me. And that's called a withdrawal transaction. So yeah, so like any other transaction I just described, Alice puts a message for the withdrawal transaction inside the inbox, and Arbitrum does its things. So yeah, somebody dumps the contents of the inbox on the ARBOS, it gets executed, and then the assertion would be placed inside the outbox. Now we have to wait for 7 days so that we make sure that the assertion is finalized and our withdrawal transaction can go through. And only in that case, when it is finalized, Alice knows that her transaction is in assertion number 20. She can go to the outbox and she'll be like, hey, outbox, this is the assertion. It's just finalized. It's sitting there for you to go and see. Go check it, please. And then if you're happy with that, I want my 100 ETH back from the Bridge. So outbox is happy. Bridge would give back the ether to Alice, and then it's going to burn those on the L2. So here's the problem I'm sure you've noticed. Withdrawals take 7 days to be finalized, and it could be even longer if there's any dispute. And although there's never been a dispute before, but there could be, and people really don't want to wait for 7 days. Sometimes they have a pressing reason. They want to really do something with their ether, but intrinsically, you don't want to wait. And then 7 days is just really an arbitrary number, but there should be some time window for people to pay attention to the protocol and react to it if something happens. But something interesting that we noticed is on Arbitrum, let's say there's an assertion that you're just looking at it for the first time and you're trying to figure out if it's going to be finalized or not. So if it actually happens, if you run a validator on Arbitrum, what happens is, what is validator? It's just a software that goes through the inbox transactions one by one. It's going to execute those, and at the end of the day, it's just going to compare the output of this execution with the state that is being asserted. So if you run an Arbitrum validator, you can be 100% sure that this transaction is really going to be finalized. The assertion is going to be finalized. So we found that this is really interesting that we can leverage to get a relief of this pain point of having to wait for 7 days. So the question we were asking in this research is, can Alice withdraw 100 ETH from L2 back to L1 without having to wait for 7 days? So we have come up with 4 different solutions in this work, and I'm going to go through them one by one, and they actually get better as we go through. Okay, so the first solution is Alice can actually use a centralized exchange, like Hop, right? So what she can do is she can go to the exchange, she can trade her 100 ETH on L2 with the one on L1, and it's really easy. So these centralized exchanges, they have piles of ETH on both L2 and L1, and you can actually trade with them. So this solution works. A lot of people have been using it, but the problem with that is it's centralized. So now we ask ourselves, is there any way we can do it in a decentralized way? And so that's where we go to the second solution. So the story is Alice is holding 100 ETH on L2, right? So if it happens to be somebody somewhere that has the exact same amount of ETH on L1 and is willing to trade that with Alice, then they can do something called atomic swap. So I'm not going to go through the details of what atomic swap is, but it's basically like a little of crypto combined with smart contract that allows you to basically do transactions on 2 different chains at the same time. So it's like Arbitrum here is a different chain than Ethereum, right? So it's like both Alice and Bob, they agree on atomic swap. So they have to lock up some money. And then there's a secret somewhere that if it's revealed on one chain, then you can use it to send a transaction on another chain. So it's either both transaction goes through at the same time or they don't go through at all. So this is the beauty of atomic swap. So it's perfect, it works, but the problem with that you might have noticed is that Bob can agree to do the atomic swap, but then he can just disappear in the middle of the protocol. So there's some time window for Alice to go back and get whatever she has locked up before, but it's actually very awkward because she's not getting what she wants and she's actually losing some time here. Okay, so we go to the third solution. So we're like, hey Alice, we know that you initiated your withdrawal transaction on L2 and from L2, and then now you're waiting for your assertion to be finalized. What we can do is we can give you a ticket actually that says you are actually the owner of this 100 ETH, and then you can do whatever you want with the ticket. You can go ahead, you can transfer it to Bob. That's fine, even though the 7-day has not passed. So, so it's basically like we're giving a tradable ticket or a claim of whatever is going to go out of the breach after the 7 days. And as I said, these are tradable, they can transfer it. So if Bob happens to be an Arbitrum validator, it means that he can be sure if the assertion is going to go finalized or not. So what what Alice does is that she can actually go to Bob and she'll be like, hey Bob, I know that you're actually validating everything and you might not even care about my withdrawal, but what I can offer you is that I have this ticket that's worth 100 Ether in 7 days. So what you can do is I give you a discount or a bonus. You can buy my ticket because you know that this assertion is going to be finalized, and then you get the ticket, you get the ticket, you get the bonus, and then at the end of the day, you have profit. So Bob can do that, it's great. But as you may have noticed, Bob here is having 2 roles. So first off, he has to have the liquidity, meaning that he has to be sitting on a pile of ETH, and he has to be willing to trade it with Alice. The other thing is Bob needs to run a validator on Arbitrum. So he needs some assurance. He needs to know that this assertion is going to go finalized someday. Otherwise, he's not really willing to trade with Alice. So the problem, this solution is really great, but the problem with that is there's not probably a lot of Bobs in this world. So there could be some people, they have the liquidity, so they have a lot of ETH, but they're not necessarily Arbitrum validators. Or there could be some Arbitrum validators, but they're not sitting on a pile of ETH, or they're not even interested in participating in these kind of like markets. They're just doing that because they want to be part of the Arbitrum ecosystem. So that's the problem. Finding these Bobs that work for the both sides of equations is not really easy. Okay, so we are at a last solution. We were like, is there any way we can split Bob? So is there any way we can have Alice? She wants to withdraw 100 ETH from L2. Then we have David, who is the Arbitrum validator, but he doesn't have the liquidity. And we have Carol, who has the liquidity, but she's not a validator. So is there any way these 3 can arrange something that can give Alice what she wants at the end of the day? And it turns out that, yes, there is a solution for that. We have this solution. And our solution is not necessarily the only one, but we think it works great. So the solution is to set up something called a prediction market. So what is a prediction market? Let me grab some water. So a prediction market is basically a betting market, but with the difference that you can get inside and outside of your position. So in a betting market, what happens is you can place a bet, but then you cannot transfer it, or you cannot get out of your position. You have to sit on it, and then you have to wait for the event to happen. But on a prediction market, on the other side, what happens is, let's say you think the odds of Joe Biden being the next president of the United States is so high. So what you do is you're going to go place a bet against it. In 3 months, the odds are actually going down. So what you do is you can actually sell your position. You can get out of your position. So this is the difference with a betting market. And then it's really like a betting market, but it's designed more kind of like stocks, I'd say. So, okay, so we have this prediction market. The way we set up it is we put the market. It's really like a vending machine. There's no bookkeeping or anything. It's autonomous smart contract. We put it on L1. And so a user would go to it. I can go to it. I deposit 1 Ether inside the market, and it would give me 2 shares, 1 yes share and 1 no share. So, and these shares are betting against if the assertion is going to be finalized or not. So at the very beginning, I'm actually covered for both cases. So if the assertion is finalized, my yes share is going to be worth 1 Ether, and my no share is actually worth nothing. And on the other side, if the assertion fails, there's a dispute, and then my no share is going to be worth 1 Ether, and the yes shares are actually nothing. So in any case, I can go and redeem my 1 Ether back. Okay, so how does it work? So let's say Alice is the one who wants to do this withdrawal, right? So she initiates the withdrawal, and she's like, okay, I want my Ether now. I don't want to wait for 7 days. So what I do is I come along, I go to this market, and and pay attention to this, that she wants to withdraw 100 Ether. So what she does is she deposits 100 ETH inside the smart contract, the market, and what market does, it actually gives Alice 100 shares of yes and 100 shares of no. So if Alice actually believes that this assertion is going to be finalized, and at the end of the day, her Ether is going to get out of the breach, what she would do? So she would keep the yes shares for herself, because it's a bet against the assertions being finalized, and she would get away the no shares, right, out of the no shares. But she's not going to do that, and I'll tell you why. What she does is she actually keeps the yes shares for herself, the no shares for herself, and she's going to give the yes shares to David, who's running the Arbitrum validator. So she goes to David, and she's like, hey, I know that you're already validating the Arbitrum chain, and David doesn't care about this withdrawal at all. He doesn't even know what that is. So Alice is like, I'm giving you these 100 no shares. It's a bet against this assertion number 10 is going to be finalized or not. And I'm giving it to you for a discount or bonus. So you can give me 99 cents per shares. So at the end of the day, you pay 99 Ether. And if it's going to be finalized, you can always go back to the market, and you can redeem it for 100 ETH. So Bob's going to profit, right? So yeah, sorry, David's going to profit. I was keeping saying Bob, right? Sorry about that. So I meant David, yeah. So David's going to profit, right? So he's willing to do that. That's fine. So what she does with the no shares that she kept for herself, now she can actually go to Carol, who has the liquidity, but she doesn't know what's going on Arbitrum chain. And Alice would be like, hi, I'm willing to trade my ticket with you. This is a ticket. It's worth 100 ETH. It belongs to me now, but I can sell it to you. And I know that you don't have any idea about this assertion number 10. You don't know if it's going to be finalized or not. That's fine. You don't have to do anything. I provide insurance. So what I do is I'm going to give 100 no shares to you for free. So in any case, if the assertion is going to be finalized and my withdrawal is actually confirmed, what you can do is you can go to the market, and you can redeem you can go to the outbox, and then you can redeem your ticket for 100 ETH. And if there's a dispute happen and this assertion happens to be like not finalized, what you can do is you can go to the market, and you can redeem your no shares for 100 ETH. So in any case, Alice is insuring Carol. So Carol would be able to do the trade with her. There's no risk for her. So this is great. This is the best solution that I guess we have come up with. And for the implementation, this is a work under progress. So what we did so far is we modified Arbitrum Nitro to support our solutions, and we provide measurements. We fully implemented solution 3 so far, It's a proof of concept. So what I did was I implemented an L1 market. It's really like a vending machine, as I said. So there's no bookkeeping or anything. And we modified the outbox so that it would support our market. And for the solution for the prediction market one, it's still under progress, but we modified the rollup and outbox smart contracts so they could be prediction market friendly. Okay, so I'm going to walk you through the protocol of solution 3, how it works, and what are the functions that we added to the Arbitrum protocol. So let's say Alice wants to do a withdrawal. So she puts her withdrawal transaction inside the inbox, and then what she does, this is a function that we added to the outbox. She wants to participate inside the market. So market needs to know that she actually locked up her Ether inside the market. So what Alice needs to do first is she has to go to the outbox and calls the transfer spender function. With what basically it does is it transfer her exit, her withdrawal, to the market smart contract. So it's like it's collateralizing her exit. And then once that's done, she can go to the market, and she can actually open a market on her exit. And market would check if Alice has really deposited her exit inside the market or not. And if yes, that's fine, she can open a market. Then the market is open for some time until there's a trade. Bob comes along, he's a trader, he's willing to trade it with Alice. What he does is he submits a bid that actually is greater than what Alice is asking for. And that's when the trade occurs. So the trade happens, everything gets settled down. What market does, it first is gonna send the ETH back to Alice, so Alice is happy, she got her Ether. And then what it does is, because it's owning the exit now, what it can do is it can actually go inside the outbox and change the owner of this exit. So it reached inside the outbox and it changes the owner to Bob. So now Bob owns the exit. We wait for 7 days. And then what happens is he can now go to the outbox smart contract, execute his withdrawal transaction, and then because he's the owner, the bridge would send 100 ETH back to him. So easy peasy, everyone's happy. And then we ran some measurements too to find out how much L1 gas it would cost us to run this function. So it turns out it's really cheap. So for transferring the spender inside the outbox smart contract, it's around 86K, and it's really like the most expensive one because it's the first transferring of spender, so it's actually you're paying for creation of a mapping. So because there's a mapping that keeps track of all the owners of an exit. So this is really expensive. The first one is really expensive, but the second one and the third one, I guess they were around like 40K away, which was really great. And for opening the market, we had to pay around 300K. And for submitting the bid, I had to pay around 100K. And then for executing the transaction, it cost 90K. And that sums up the talk. I hope you enjoyed it. It's really a work under progress, so the repo is not really public yet, but I urge you to reach out to me on Twitter if you need to learn more. We're going to submit it somewhere soon, and the repo will be public. Thank you. Sure.
Hi.
Hey. Yeah.
I have a question because I got lost at some point, but it doesn't matter or not. So in our solution 3, Bob was a validator, and he needed 99 ETH, right? Because Alice was selling him 100 ETH for 99 ETH.
Yeah.
Yeah, maybe I will repeat the question. So in solution 3, Bob was a validator, and he needed 99 ETH. Because he was selling Alice 99 ETH for 100 ETH, so he could make a profit.
Yeah.
And in solution 4, the validator, who was David, he was buying shares, 0.99 ETH for 1 share, which means he also needed 99 ETH. So in that case, David, who is a validator, also needs this money, which means that solution 3, in my opinion, is better because it's simpler, and in both cases, the validator needs 99 ETH.
Yeah. Let me think. That's actually a good point.
She gives the no shares.
Yeah, the 1 share is 0.99. If you multiply it by 100 shares, means that the validator still needs 99 ETH. So it's a more convoluted version of solution tree.
Yeah, so that's the thing. So we can really work on the pricing of these shares.
Right, but we could also
Yeah.
work on the pricing of ETH to ETH in solution
That
tree.
too, yeah. So the pricing needs some work to be done. So yeah, we can also improve the solution tree. Yeah, because these are, at the end of the day, they're like a futures, right? They're like a promise for something. So yeah, we have to really work on the pricing to see if it works or not. But yeah, thanks. That's a good point. Thank you. This is really slow, by the way. Yeah. Thanks. Yeah, thank you. Thank you.
Texto. Cool. Hola, hola. Ah, cool. Hey everyone. So many nice people here that I know. What's up, guys? My name is Pablo. Buenos días. ¿Qué tal? And today I'm going to speak about Streamies, a project I've been working on with the Ethereum Foundation and the guys from LivePeer. It's a project that we're using right now to stream Devcon. So if you go to live.devcon.org, You can actually follow all the sessions there. So yeah, I'll be speaking about what Streameth is, how it works, why we need Streameth actually, which I think is the most important thing. And then I'll go over a bit of history on how the application came to be, where we used it, and also how the future is going to look like for Streameth. Cool. So what is Streameth? There is a very official definition that I made up yesterday. So Streameth is a self-hosted application that event organizers can use to host their virtual events. So yeah, we'll go a bit more in depth later on what this means. So, like I said, Streameth was born out of a collaboration between Ethereum Foundation, LivePeer, and myself. It all started with Ethereum Foundation wanting to decouple the channels from YouTube. They wanted to do 3 simple things at first. So our current version of Streameth does these 3 simple things fairly good, I think. So stream, we wanted to live stream the events, of course, without relying on YouTube. We wanted to also show a schedule of the sessions for each talk. And after the event was done, we wanted to record, show the recording of all the sessions that we streamed, right? So when we started designing the application, we decided that we wanted to mimic kind of how the application looked like. We wanted to mimic it to what a real event is. So we designed everything around rooms and sessions, right? So one event has multiple rooms, and one room has multiple sessions. So then from then on, we started building Streameth. The first thing we focused on was on live streaming. So each room can have one live stream. Through the whole application, you can concurrently stream on multiple rooms. So today in Devcon, we're concurrently live streaming 9 multiple rooms, which I think is pretty cool. We also focused on uptime. We built in a failover mechanism into our playback systems that allows a single room to ingest 2 sources that have the same content to fail over to one or the other in case there were errors in the broadcasting on one of the sources. You might be wondering what we use instead of YouTube, and that is, of course, very interesting. And that's where LivePeer comes in. Streameth is actually provider agnostic, which means that we don't do any of the broadcasting ourselves, right? We are just a front end that hooks into whatever video provider we want. In our case, we built the solution by default on top of LivePeer, which is an awesome protocol that some of you may know. I know these guys know them because they're the core developers, so yeah. LivePeer is a decentralized video streaming network built on the Ethereum blockchain. LivePeer can currently distribute live and on-demand content. So yeah, it's pretty cool. I'll go more in depth on why we chose LivePeer later, but you can imagine it's a protocol built on Ethereum, so decentralization, censorship resistant, and all the nice things about decentralization, right? So like I said, the application is provider agnostic, but there's already a out-of-the-box solution that integrates with LivePeer. So you can start up Streameth, set up your LivePeer account, and start streaming decentralized. Then we also put a lot of focus into the schedule. This is because Streameth is not only something you can use to live stream, but it's actually something that that event organizers want to use to, like I said, replicate the event experience, but virtually, right? So the schedule, as always, is a very important part of any event, especially events like Devcon, where you have a lot of sessions and a lot of rooms. You kind of want to automate the process of scheduling everything and showing the information in a nice, accessible way. So we built a schedule. By the way, I'm talking about the features, then we'll do a live demo and showcase the application, because I know it might be a bit difficult to imagine what I'm saying, right? So yeah, the schedule is a very central part of Streamies. We built multiple integrations with different schedule providers. Devcon is using Pretox as a schedule manager, which is Pretox is an open source tool for management that the Devcon team is using to organize all the sessions and all the rooms. So we built an integration with their API, and that's also available in Streamies. So if you're an event organizer, you can spin up a Pretox instance and get going with that and have a pretty nice schedule functionality there. Also, the application has an internal clock, which will basically sync you up with the latest sessions and always display the current information on which stock is happening and all of that. But I think that's better that you guys see it in a live demo that I'm going to show later. Then, of course, like we said, on-demand video playback, that is also crucial for the event organizers. Actually, most of the views for events happen during on-demand playback. So live video don't usually get too many views, but then when you store that video and you show it on demand, because of the content we're sharing here in these talks is very interesting, people go and watch it. So yeah, this is also currently all the on-demand video that we are hosting on different Streamies instances. It's also living on the LivePeer network. They recently developed their video on-demand features, so it's working very nicely. And I'll also show an example of a Streamies instance where we used video on demand. It was at ETH Berlin last month. It worked very nicely, so I'll show a demo of that as well. And finally, plugins. And I think this is the most interesting feature. So the software architecture that we built was thought to contain this plugin feature, right? So essentially, in the long term, of course, we want different protocols to build plugins into Streamies so that they can integrate their features into the application, right? So for instance, we are working with Radical to integrate Radical drips, and that will allow to, I don't know if you guys know Radical drips, but it's basically a product that allows to have tipping on web interfaces. So you could have a Streamies instance where you're live streaming an event, and then you have the Radical drips plugin, and so users of that, viewers of that event could donate directly to the speakers, which I think is pretty cool, right? So the plugin architecture is there. Now we need to develop the ecosystem and bring people in to develop these plugins for us. So yeah, it's pretty cool. Oh, and this is the slide where I show the live demo. So I'm gonna, yeah, yes. So this is the Streamies instance that we use for Devcon. And we can see there that the video is buffering because the Wi-Fi isn't the best in the world. But yeah, so like I said, we are live streaming through LivePeer. This is the main stage, as you guys can see. So even though network conditions are pretty shit, it's working fine, right? So props to the LivePeer team. In this case, we also added the YouTube link. So the good thing about Streamies is that because it's an open source application, each instance can be adjusted to the needs of the event, right? So for this, in this case, for Devcon, we also wanted to include a YouTube stream for, to have the maximum reach. So we're streaming both on LivePeer and YouTube, and we added this nice switcher in the bottom, so you can switch between both providers. I'm not going to play the YouTube because yeah, we don't like YouTube. So, like I said, then the schedule for this instance, we built the schedule into a nice navigation bar on the right panel of the page. You can kind of look through all the talks. I'm going to try and refresh. This is like very risky. Maybe it doesn't load, but I'm going to try and refresh this. So yeah, when I refresh, you guys can see that the schedule kind of synced to the latest hour. So this should be me. Oh no, this is talk 5. This is not my stage. So yeah, right now in stage 5, how to scale the blockchain is happening. So that's the internal clock feature that I was talking about. And yeah, it's pretty simple, but it works. Like we said, I'm going to show also the what's the ETH Berlin. Oh. Cool. And this is the ETH Berlin Streamies that we deployed. This is a custom schedule page that we built. So this is containing all of the sessions for ETH Berlin. You can filter by stages, and days. And so when you click on a session, okay, cool. It goes to the session page, and it loads up the VOD content, and also some speaker information, and kind of like the description of the event. And let's see if the VOD video loads. I'm going to click on the speaker thing for now. Okay. Well, maybe it's not loading. Wi-Fi issues. But go check it out. Watch.ethberlin.000. It's very good content. Oh, it's loading? It's loading. Okay, clap. Yes. Also hosted on Livepeer. Okay, we're going to close this. Cool. So yeah, like I said at the beginning, 3 basic features, but very powerful. And very effective as well, because the main goal was to decouple ETH events and community events of centralized platforms like YouTube, right? So I think even though it's nothing fancy, we're not Twitch, we don't do VR, we don't do 3D, nothing, it really serves a purpose, right? And now, because I'm talking about purpose, I want to go into a bit of the ethics on why we built this, why we think it's important, and why why we built this and why we think it's important. I think that's it. Yeah. So can we? Yes. So like I said, most of the Web3 events are being broadcasted using centralized providers, and this sucks a lot. And it's not just because I say that; it actually sucks. Like we all know, YouTube and Twitch don't really align with the core values of decentralization that we, that we're all here for and that we believe in. So Streamies is, should be a good first step to help these communities decouple from these services, right? So now we're going to look a bit of what are the problems about that you get with using YouTube, right? So the first one is pretty clear. YouTube and Twitch and others are censorship prone. So yeah, here I put 2 tweets. The first one was at ETH Barcelona. The live stream was taken down because they had some copyright issues, which is usually, event production is pretty hard. You have all kinds of audio, you have all kinds of music, and sometimes some music segments with copyright can slip into the production, and then your whole stream gets taken down. So that's not good. So ETH Barcelona had 1 day without streaming. And then there's another tweet about a YouTube account that got taken down because they were talking about Web3 content on YouTube. So yeah, there were some disputes, and YouTube kind of banned their account, right? So what is the solution? Streamies. So that's why I'm here, talking about Streamies. No, the solution is, having a front end that well, the solution is twofold, actually. So the first one is the front end, right? You want to deploy the front end on a decentralized storage layer like IPFS or Swarm. And that is actually one of the next steps we're going to take after Devcon, is to make sure the application is lightweight and we can use it and deploy it in one of these two layers. And the second solution to the problem is using decentralized video providers like LivePeer. Since LivePeer is a decentralized layer of nodes, the content cannot be really stopped, even if the government or the platform, any platform says so, right? So yeah, that would be the solution to censorship issues. The next problem that arises from using centralized providers is the intellectual property. This is kind of tied to the censorship-prone issue. So like we said, copyright claims can result in streams being taken down, channels being banned, and users being demonetized. We don't want that. And also, it's not only that they're taking down the streams, but it's the lack of transparency in the process to decide which streams get taken down and which content is being shown or not, right? So there's really an ethical discussion around what content are we being allowed to see, right? So using decentralized services, we don't really solve this content because there's no moderation, right? But I think we're heading in the right direction in regards to not allowing this one central entity to decide what we can see or what we can't see, right? So yeah, I think it's an interesting ethical problem. Next will be the high fee to content creators, and this is also fairly interesting, especially recently. Twitch, I think, increased their the share they're taking from content creators from, I think it was 15 to 30% or something like this, because these centralized providers are actually super expensive to run, right? So Twitch is, even though the content is free, it's mega expensive to run an operation like Twitch. So in the long term, they have two solutions. And one solution is to increase the share they're taking from content creators. The other solution is to display ads, right? So yeah, moving on to a decentralized solution like Streamies and also LivePeer will basically allow us to give back the monetization power to the content creator. Because then if a content creator is using LivePeer to distribute the content is actually theirs, right? So he is then able to decide how he monetizes the content. Also, building on top of the plugin system that I was talking about earlier, we're really setting up this ecosystem for developers to come in and build custom solutions on top of Streamies that they can use to monetize their content. So radical drips would be a good example, but this is Web3. The best thing we do is create monetization routes that. Oh, right. I lost what I was saying. Yeah, this is Web3 crypto. We're good at monetizing without having someone in the middle taking a share of our money. So you guys can figure out the rest. Just build a custom plugin that sends money to one address or the other, and we should be solving this issue. And finally, and that's for me, this is the most important one, the Web3 ecosystem and how Twitch, YouTube, and others are not really respecting the values that we stand for, right? Especially the open source and the communities. They build solutions sometimes, and they're trying to get into Web3, but they're not actually thinking about the community. They're not making this code public. They're not contributing back to the protocols they use, right? They're not part of our community. And yeah, I think Streamies is actually existing because we believe in these ideals, and it's coming out of a community effort between the EF, LivePeer, and me and other developers to embrace these ideals, right? And trying to help, like I said, communities decouple from these providers. Cool. And finally, oh, no, the most important slide. The members of the team. And I want a round of applause after I say all of the names. So first we have Hans, which is the guy that developed quite a big chunk of the code. He's sitting there in the audience. Big props, applause. Yes. Then we have Wesley EFR, he's sitting there. Oh, shit. Oh, Wesley, also applause, sitting there in the corner. I don't know if Akio is here. I don't think so. He's watching me on the stream, Akio. What's up? He's the designer. And then I'm there with the panda that I set for the merge. It's my PFP for the merge day. I didn't change it, so yeah, the panda. And that's me. And you don't have to clap. No. So yeah, it was awesome working with these guys. Really great. Cool. How much time? I'm done. Okay. Quick things. We used it at DevConnect. That was the first demo that we used. It was awesome. Lots of traction. We hacked a demo in like a week. So that's why I'm saying it's a great team, because we didn't really plan the development. It was really a decentralized development effort, because everyone was doing its own thing, right? So, but we got to DevConnect. It was awesome. We got great numbers of viewership and no bugs, I think. So great. Then we went to ETH Berlin, and we redid the design. We called it Streamies 2.0. We added dark mode, which is actually the best feature in the whole application. The schedule, super good. There really we had no bugs, and I know this for sure. And overall, we were super happy with it. And then, oh, okay, I didn't do my slide. Okay, no, I did. Okay, good. And then, yeah, Devcon, which is great. So yeah. And how does the future look like? We're going to focus on usability, we're going to focus on plugins, and we're going to focus on embracing the Web3 ecosystem, like we said. And yeah. And this is kind of like our vision. I don't know if you guys know WordPress, but the vision that we had since the beginning is to have Streamies be WordPress, so WordPress for video, right? So something that event organizers can clone and use quickly to stream their events. Cool. I think I'm done. Thank you all. Hey, Mom. Oh, wait. I want to say thank you to my girlfriend who helped me put this up. So, hola, Nerea. Hola. Yeah.
Hello. Hi, Pablo. Thank you for your talk. I am an event organizer. I have used several streaming providers, and I like Lightpeer, but one thing that worries me is how is the performance compared to other alternatives like Vimeo, YouTube, because this is decentralized, so this is kind of worry for events.
Yes. So this Lightpeer is pretty good. So I was a pretty early community member, and I've been using it. And in the early days, it had some issues. So since the beginning, I come from the Web 2 world, like production world, and you always have failovers. And when I started using Lightpeer, I was like, hey, we need to build a failover here. So that's why we have built in a failover mechanism into all of our players, right? So on the one hand, Lightpeer got really good already. On the other hand, we have a failover mechanism that allows to basically set 2 Lightpeer channels for the same room, so you have double the reliability. So yeah.
But what about the streaming related to attendees? Because you have attendees all around the world, and streaming providers have like a CDN, content delivery network.
No.
So how Lightpeer solves that?
Yeah, Lightpeer. I mean, this is a bit of a more complex question, because you have the Lightpeer, the protocol, and then you have Lightpeer Studio. But basically, Lightpeer Studio, and that's what we are using, has its own CDN, and latency is pretty good. So you shouldn't have an issue if you have people from around the world trying to watch your stream. Like I said, performance is really good. East Berlin, we had a bunch of people watching. Devcon, a bunch of people watching. Here, you know, it's Devcon. Yesterday we had 3K views on live here alone, and almost no downtime. So yeah, if you want, we can speak later, and I can explain a bit more. Yeah. Thank you.
Hi, everybody. My name is Ian Myers, and I'm a professor at the University of Maryland. I wrote the first papers on using zero-knowledge proofs and then ZK snarks for blockchains. This was the work on ZeroCoin and ZeroCash. This turned into Zcash, and it also happens to be the protocols that underpin basically every second-generation privacy coin that's coming online now. In other words, I've spent about the last 10 years working on zero-knowledge proofs for privacy in blockchains. And today, I'm going to give you a talk entitled, Privacy is Dead, Scalability is Boring, What are ZK Proofs Good For? Which is a bit of a contradiction in terms. So obviously, privacy is dead is clickbait. Apologies if I got you in here for the wrong reasons. privacy is really important. I spent the last 10 years of my life working on this stuff, but we haven't seen a large amount of demand for private consumer payments, right? Monero launched, Zcash launched, other things launched. They exist, they're great. They aren't really moving the needle. And so I've found myself wondering, as I work as a professor on like, what's the next thing we do? What happens if demand for this kind of stuff is 10 years plus out? One of my co-authors, Ron Tromer, sort of described it as follows. Selling privacy for people for blockchain payments is kind of like selling seatbelts for cars in the 1920s. Sure, we can all kind of figure out that in the future you're going to need it, but until you end up with the actual interstate highway system and people crashing cars at 60 miles an hour, it's kind of hard to sell people in the future. So what do we do, right? Second problem is, in terms of research, right, for everybody who likes to get excited about new technical stuff and new cryptography, there isn't much here anymore. The techniques to do this are known. They're done. We worked them out, and this is now a thing to work out in industrial applications, right? The approach for how you build private payments is a zero-knowledge proof plus an accumulator, typically ZK snark plus a Merkle tree. This was developed in Zero Cash in my PhD thesis. It ended up in Zcash. It's now in pretty much every single other thing that's coming online now. Aztec, Anoma, Penumbra, Railgun. They all have features on top of this. They're not clones. But that's the base thing for privacy for payments. And so, sure, you can build tweaks. You can change the accumulator. You can change the proof systems. You can claim it's something completely new. You can add extra features. That's quite valid. But this kind of feels to me like we're leaving behind the main things that make zero-knowledge proofs really cool. Because the thing to me that's fascinated me since I was 12 is the zero-knowledge bits that were hiding things. And if nobody cares about privacy, well, we should move to something else as an application. Obviously, privacy is not dead everywhere. It's definitely not dead everywhere in cryptocurrency. So if you're one of these second-gen privacy coins, don't kill me for killing your pitch deck. There are other things that are happening. Probably we need privacy for DeFi. It seems like traders do need that. You might be able to use ZK proofs to get out of MEV or front running. Jury's still out on that. You could have an interesting argument with Phil Diane if you don't believe me. But nonetheless, the core protocols for doing zero-knowledge proofs are still like the same as far as private payments go, even for these applications. So from a research perspective, there's nothing new here. So what do we do? Well, I hope this isn't too offensive to any of you but blockchains are slow. So that's a whole problem. And well, okay, zero-knowledge proofs are supposed to be everything a growing blockchain needs. There are a lot of people working on scalability for blockchains doing ZK rollups, ZK VMs, right? This is a lot of research. It's a lot of funding. It's probably several $1 billion worth of value from venture capital for this. And this is where all the excitement is right now. But if you haven't seen this, well, how do these things work? In a rollup, you have a server that is taking transactions that users generate. Users submit those transactions to the server. The server takes them and compresses them down using a zero-knowledge proof. The zero-knowledge proof says, hey, all of these transactions are correct. And then the server generates this proof and sort of throws it over the wall to the blockchain. And so the server is, in effect, saving the blockchain work. This proof is succinct, at least somewhat. And so it's easier for the blockchain to check that than it is to check all the proofs. And so then it doesn't matter if your blockchain is slow and does 10 transactions per second, if each one of those transactions is a zero-knowledge proof saying that 10,000 transactions are correct in payments. That's the theory. That's the pitch deck everyone's raising off of. OK, this is great. There's really nothing wrong with you. This is a lot of brilliant work has been done on this. I don't mean to belie people on it. There's just, as a cryptography professor, a thing that kind of bothers me. ZKVMs and ZK rollups aren't zero-knowledge. They compress transactions on blockchains. You don't need to hide what's going on to do that. You just need things that are faster and smaller to verify. There's no notion that this has to hide what's going on. And in fact, they likely aren't going to hide your data. And so this is going to be surprising to some of you. Of course, ZK rollups usually reveal the Merkle hash of the data they're dealing with. That's kind of obvious. There's a zero-knowledge proof about it, but they're revealing the Merkle hash. And that hash actually reveals a bunch of data in much the same way that, say, publishing the hash of your password is going to reveal your password. People can brute force these things. And it wouldn't matter if you, when you publish the hash of your password, said, here's a zero-knowledge proof that it meets whatever ridiculous password policy there is, 3 uppercase characters, a symbol, and hey, let's throw in some emojis for good effort. That's not going to help with the privacy problem here. And so this is going to become an issue. Maybe it's just in theory, maybe it's hard to brute force this stuff. On the other hand, Ethereum just moved to proof of stake, so there are a lot of angry miners with a bunch of hashing hardware who don't know what to do with it. So if this ends up being an MEV thing, you might have some problems. Either way, it's not zero knowledge. And so in my perspective, this is kind of boring from a ZK standpoint, because it just isn't using the thing that's cool and fascinating about zero knowledge proofs. Sure, you need faster proofs. That's quite nice. This will get you all kinds of cool technology, and I'm glad it exists. But it's skipping the interesting bits. Right? And so at the end of the day, ZKVMs are not a significant source of zero knowledge. They're sort of nutritionally defunct from this perspective. They don't give us what we want. And again, this is not to say this stuff isn't useful. It's driving serious innovation in zero knowledge proofs. The things I worked on in 2012, in 2017 when we wrote Zexy, which were like implausibly slow at the time, are now practical in part because of the R&D that's been funded by the companies doing this. And so that's incredibly useful. It's a bunch of tooling that I, as a researcher, can use. And so I sort of think about this like the 1980s and 1990s when people were building faster computer processors. These things were tools we could use to do anything we wanted. What was driving people doing them was, faster spreadsheets for offices. Kind of like what's driving people now is faster spreadsheets on a blockchain. So you can do this, that's great, there's nothing wrong with it. You can also nerd out on exactly what you're going to do for the zero knowledge proofs and just go, I don't care what anyone's building on an application. That's also fine. But some people should dream bigger, right? Just like we did with microprocessors, build the internet, build the metaverse, build something. I don't know what it is, but we should be thinking about it. And so we need to figure out what the combination of ZK proofs plus blockchains can do that isn't just faster spreadsheets on a blockchain. It's going to be part of it, but it's not going to be everything. So this brings me to the question, and this is where the sort of technical content of this talk stops. This is this sort of theory question. What is this stuff good for, right? What are we going to do with a zero knowledge proof? And if you went and took a cryptography class, probably even if you took my cryptography class because I'm lazy about writing slides, you would get a definition like this, which said a zero knowledge proof is a thing with correctness, soundness, and zero knowledge. And this is a very sort of textbook academic thing. It's very dry. It does not relate what these things really do. So I think we kind of should start thinking about them in different terms. So in deliberately non-standard terminology, what is a zero knowledge proof doing? Well, in my mind, it's three things. The first one is confidentiality. It hides data. And so that's how we got Zcash. That's how we got Tornado Cash. That's how you get Aztec. You get everything else. We were trying to hide data to get private payments because blockchains are Twitter for your bank account. And that sounds like a horrendous idea. OK, that's thing one. Thing two, for ZK snarks specifically, is compression. Right? They take a bunch of data, and it's easier to verify than doing the linear paths that the actual verification would do without the proof. That's nice. That's how you get scalability. Right? This is what's driving people's quest to save money on gas for blockchains. But the third point is that it provides something which we can think of as credibility. Right? So a zero knowledge proof, from the cryptography standpoint, is sound. It gives you some guarantee that some statement is correct. But it doesn't tell you anything about what you can do with it. Credibility is this point of if I give you a piece of data, I can use a zero knowledge proof to show to you that it really is the data you're supposed to be looking at. It really was computed on correctly. And this actually, actually works. Of course, that doesn't say anything about my slides working. OK, so the idea here comes from a piece of research done by some of my collaborators back before I knew them called proof carrying data in 2010. And this was really before blockchains were a major thing, at least in academia. And the idea was you have data, never mind where. Again, they didn't know about blockchains. And the data has proofs attached to it that the computations are correct that was done to produce the data. So you have some data. Proof here says data's whatever. Someone comes along, computes a function on the data, gives you the output, gives you proof that that's correct. And then later, somebody else can come along, compute another function on the result of that, give you proof that that's correct, and you can just sort of imagine some kind of state machine going forwards. It looks kind of like a smart contract, I guess, but it involves zero knowledge proofs. And of course, because it involves zero knowledge proofs, you can also hide anything you want in the process of doing this. So this is great. It's a nice piece of work. But first of all, how do you agree on what this data is, that everyone saw it? Second of all, what is this good for? This paper does not answer that question. It just proposes this academic mechanism. So we're back to the question of, what are zero knowledge proofs good for? And so in my mind, the thing that a zero knowledge proof combined with a blockchain, and that combination is crucial, gives you is credibility, right? That piece of data, if it's on a blockchain, can tell you that everyone agreed on this, right? This is what's out there, and then I can give you a proof that it was correct, that I didn't see anything else that I wasn't supposed to when I was computing on it, and that the operation I did was done correctly. And then we all get a shared consensus on this because it's on a blockchain. I can't equivocate on what I did. I can't double spin something if there's something in this data. This is privacy-preserving smart contracts for any of you who've looked at this stuff, but at a level of what's the property that a normal person might care about, right? So what do we do with this? Well, in general, what are zero-knowledge proofs good for? And in this talk, I'm going to give you some low-level things of like immediate problems, some very high-level things that are, what was on my mind at the time, and then back to some low-level things with identity. So the first thing that you really do need zero-knowledge proofs for is credible safety for or from, depending on how cynical you are, rollup operators, right? The Bitcoin people would call this censorship resistance. Because if you have a rollup, right? The rollup is taking these transactions, the server's sitting here, it sees everything that's in those transactions. Right? These are normal Ethereum or Bitcoin or whatever it is transactions. They are completely transparent to the server. Server can see what's going on. Okay, fine. Why does that matter? Blockchains are that way anyway. The problem is the server's getting these from a bunch of people, and it gets to choose which ones it takes and which ones it doesn't. And the problem is that that's going to be obvious to everybody, and so the server is going to be held responsible at some point by somebody for something it failed to exclude. In other words, ZK VMs and ZK rollups, at least if you naively do them in a single server model, aren't censorship resistant. The consequence of this is you really better not mint any NFTs or some meme a government doesn't like. You probably shouldn't take payments to activists that a government doesn't like. If you're a rollup operator sitting in Texas, I probably wouldn't take donations to an abortion fund right now. Might get you in a bit of trouble. Because if you do, your nice ZK block compactor trying to make things efficient isn't going to be a block compactor, it's going to be a trash compactor on fire. You're going to just have major problems with transactions you process. So this is not safe, this is not good, and this is a major problem for how people trying to get blockchains to scale. So what do you do about this? Well, you replace the individual user transactions with zero-knowledge proofs so that those transactions are now opaque. And as a result, the rollup operator can't see what's going on. And so they're a dumb pipe, and they have some limited ability to manipulate transaction ordering, but again, they don't really know what's going on. They have a degree of deniability. And so this gives you a minimal amount of safety. It doesn't solve everything. But this is the thing that you need to be building into your ZK rollups. And this is things that various people are building. I believe the original people who came up with this idea, I don't follow these things too closely, Aztec currently has this out there. Aleo, company I'm involved with, is also building this. I'm sure there are others, but nobody's really broadcasting these features as a thing that goes on very well. And part of that's because it has a really bad name, right? This gets called a ZK rollup, which is kind of a mouthful. And every time I hear it, all I can think of is this bad meme from like, not quite the 90s, but it's pretty old. So you should be doing this, and somebody should please come up with a better name for this that's catchy so that people can market it, because I'm sure I left off some people who are building this. But this poses an interesting problem for those of you who are working on zero-knowledge proofs, because these proofs need to be built on phones. And that doesn't necessarily work with every ZK proof system that's out there, right? I don't know the full breadth of these things. I don't play with most of them. Most of my stuff's still in Graph 16. But I do know that some of these things are slower than others and are suited to other cases. And so there's some risk factors that you might want to consider if you're looking at ZK tech and trying to figure out what we should use. A lot of these systems, the provers are architected to run in data centers on big iron. Right? This may be fundamental to the way the proof system works. It may just be who your devs were and what they knew how to do. But either way, it's not clear they're going to run efficiently on a mobile phone or a laptop. Secondly, for the proof systems, they may be amortized only over lots of transactions. Right? So they're not really efficient unless you put 1,000 transactions into this proof and check them, and then you get some amortized savings, which is fine for a server compressing transactions to do a rollup. But again, in these cases, you need phones to be generating proofs, or laptops to be generating proofs, so the server doesn't see what's going on. And that's only going to have one transaction in it. And lastly, the proofs in a lot of these things are very large, which is going to cause all kinds of problems for mobile data, for your gossip protocols, for transaction distributions. This is also a warning sign. And so the way to think about this, or at least I think about this, is you may remember that there's been this big problem with Intel and x86 for the past about 15 years, where Intel built these wonderful server chips, and then they found out the future of the world was mobile devices, and they've been trying to play catch up with getting their chips to work on mobile. And there's some business development things there's some fundamental technical things, there's some positioning that are causing them problems. And so we may end up in a similar situation with ZK proofs where you can't get these to work in the right settings you want, and then you're going to have to do a nested ZK thing. You have to add another ZK proof under your ZK proof in a different system. That's going to up your costs and up your complexity. So food for thought for those of you who are working on these things. Okay, that's the basic pressing issue today, but looking more broadly, what else can we use zero-knowledge proofs for, right? If we have this notion of credibility carrying data, right, what can we use it for? And I think you can more broadly do this for markets like competition, decentralization, migrating data around is going to be a big one, and obviously you can also use it for preventing money laundering. So starting with the last one of those, cryptocurrency has a theft problem, right? This is stuff gets stolen now by nation states. The nation states actually go get in trouble. Tornado Cash got taken down because of this. Actually, the Tornado Cash developer is in prison right now in the Netherlands because of this, which is kind of crazy for, thing that came out of a paper I started writing 10 years ago. But this is what's going on. And it would be good if we had some way to deal with this. So what if you wanted to prove to somebody when you make a payment that the money you had wasn't stolen? And you wanted to show them that the money wasn't stolen when you got it from somebody. And when that person got it from somebody, that money wasn't stolen then either, right? Ad infinitum, all the way back. This is impossible if you're just asking questions. You can't do this without cryptography, right? If you just do KYC or whatever, you'll stop at just who you are, who's giving you the money, and you won't really get a good notion of what's going on. But ZK proofs compose recursively, right? So I actually can build a zero-knowledge proof that not only is my money not on a list of stolen money, but it wasn't on a list of stolen money when it was paid to me, and that wasn't on a list of stolen money before that, all the way back in time. So we can have this sort of credible money where, despite the fact that I'm anonymous, you actually know that it's not stolen. All right, so that's one thing you could build. Details are somewhat complex, by the way, but it is possible. Right? More broadly, you can do all kinds of compliance. Right? You want to comply with anti-money laundering rules, currency transaction reports that you're not sending more than $10,000 through a system. You can do that. Right? In theory, we knew how to do this in 2016, so the paper I wrote at Financial Cryptography. But now there are actually companies building this because, again, we have more practical zero-knowledge proofs, in part because of the people working on rollups. You want to show you're not on the sanctions list. We can do that. So this is, again, you can get credibility for what's going on with money. More broadly, though, right, let's not just think about payments. What else could you do? What could you possibly want to prove to somebody? Well, we're all trying to build decentralized ecosystems. Right? There's a whole question of whether those are really going to be on a blockchain or they're going to be some oligopoly of servers where people try to move from one server to another, migrate their data from one thing to another. And in those settings, it would probably be pretty useful if when you took your data from server A to server B, you sort of said that, here, I can prove to you it's correct. Right? Similarly speaking, you might want to prove that an auction you're doing is not tampered with. Google recently got in trouble because allegedly, according to several states' attorney general, they were manipulating their ad auctions. Instead of they said they were running a second price sealed bid auction, where if you win, you pay what the second price is, and so you should bid your value. And instead, they were running something that was approximately a first price sealed bid auction, because if you won, they lied and said there was a bid right under where yours was and basically charged you what you were willing to pay. And this is a problem with Google, a semi-trusted guy in a legal setting where there are places to prosecute them. If you try to run an auction on, decentralized Wild West of blockchains, this is going to come up. So you probably want to be able to prove your auctions are correct. Similarly, you might want to run a matching market for some rideshare system like Uber. You can do this with a zero-knowledge proof, in theory. Right? Thinking even more broadly, you might want to be able to say, hey, if we're running a decentralized social media system, I have a news feed. I'd like to know that my news feed wasn't manipulated. That somebody isn't, for example, feeding me outrageous stuff just because it generates clicks. Or, making clickbait titles for, Ethereum Devcon talks. You might want zero-knowledge proofs to do that. And the thing here is, these are all sort of pie-in-the-sky dreams, but we're going to need to do things like this. Because if you're trying to decentralize existing services, organizations, and institutions, it's kind of essential, because people kind of trust these existing things for better or worse. And so if you move to something that's completely crazy and new, you're going to need to convince those people to trust your new thing, and you can't just publish everything. That's not how the world works. So this is sort of hard to think about as a concrete thing, so here's a concrete version of this. Standard tale about internet gaming, right? There's some awesome game, it's an online game, there's a server, there's a great community, everybody loves the thing. And then it gets a little too popular, thing goes down the toilet, the devs get greedy or bought by some company, Blizzard, and they somehow ruin the game. Never mind how. And so, in classic Futurama, Binder, we're going to make our own with better things. What you want to do is take all your data and go to a new server with the same game, but your existing game state. And for this to work, the game has to be open source. But even if it is, you're going to run into some problems here, right? When you take that level 50 sword or whatever it is from server A to server B, why is anyone going to believe that you actually earned that you didn't just make it up, right? For the server, how are we going to know that they weren't playing funny business and secretly running a pay-to-play game, right? How are you going to know that the economy of that server and the way the items are distributed is correct, right? You want to be able to prevent these guys from toileting this game. You want to be able to move to another server, but you need all of your data to be credible when you do this and move it around. And so the only way you're going to do this is by committing to the data on a blockchain and attaching zero-knowledge proofs to all of this stuff. Again, pie in the sky. You can't get this to scale now, but it's an interesting idea. And this approach is broadly feasible to not just gaming. Right? You don't need to just do this about a sword. You could do this about any number of things. Right? If you're running a crowdfunding platform that has awards, something like Patreon, if Patreon goes under, you can move to another server and take the awards you've gotten and prove you actually got them. Okay, well, what if we thought even bigger? Recently, there was a headline that the IRS had gotten in trouble for manipulating their audit process, and under the Trump administration, auditing senior FBI officials who mysteriously had also been investigating the Trump administration. So this was regarded as the tampering of the stuff. What would it take to make tax audit processes credible? And this is just sort of a hypothetical, right? How would you know that this is working? You'd have to commit to an audit policy in advance. You'd have to put up all of the tax returns committed in some blockchain and permissioned ledger, and then you'd have to show that your audit process was applied correctly. And the thing is, in the process of doing this, you cannot reveal any of that data. You can't tell people what will get your taxes audited. You can't tell people what other people's tax returns are. But if you want everybody to know and trust that when they get audited by the IRS or some other institution, that it was actually done according to a fixed procedure and the rule of law or whatever it is, you're going to have to do something. And so maybe, again, hypothetically, if you had a zero-knowledge proof in a blockchain, you could do this. So as I was writing this talk, I kept thinking of this idea that verifiability enables cooperation. So during the Cold War, the US and the USSR wanted to disarm somewhat. They wanted to have less nukes because they could save money on it, and it was better for the planet. But there was this problem of if the US gets rid of their nukes, they want to verify that the Russians are also getting rid of theirs. And that was kind of hard. So one of the limits for arms control treaties was that it was hard to verify what was going on. And what happened was that as spy satellites got better and as spy planes got better and more pervasive, the Russians and the US were capable of verifying that disarmament was happening, and so they could actually cooperate. And there actually are now treaties about being able to fly planes over other people's territory to verify this stuff. It's called the Open Skies Act, excuse me. So technical advances can enable better verification and more cooperation. But of course, spy satellites don't work for this kind of stuff on the internet. We can't just publish everyone's data out there for everyone to see. And so to do this in this case, we need zero-knowledge proofs. So what are zero-knowledge proofs good for? These three things. On a more concrete thing, you can also use them for identity, moderation, decentralization. So we need to prove all kinds of things about our identity online, that we're not North Korean money launderers, for example, that we're not a bot, Elon Musk, or that we're over 18 to view a video. And so that's time, but I have some work on this that would kind of be interesting. So with that, I guess I will take questions. So those are the two papers if you're interested in them.
Do you think that, oh, sorry, is this working?
Yep.
Do you think that ZK rollup providers will censor transactions by not including them if submitters
don't disclose the data?
So there's a whole game theory question about that. I don't know. I'm not guaranteeing that this will solve your problems. I'm guaranteeing you if you don't do it, you'll have problems. Right? There's no warranty on this, right? I'm in academia. I don't have to, be responsible for that.
Yeah. So when building like a real-world application using ZK stuff, like I think the Oracle issue would be kind of one issue, and how can we kind of the design the social stuff into just polygonal circuit stuff would be kind of real barrier. So what's your idea on that?
That's a major problem. You're asking about like tooling for ZK proofs? Like we need to get better at it. We need to get more developers on it. Thankfully, all the money in ZK rollups seems to be helping producing tooling for that. So I'm going to say that's an industry problem. And again, I'm in academia. I don't have to solve it. But it's a real problem. I don't know a good answer. It's a good question. Anybody else?
Just one more.
Hi, thank you. Christiana Viva. So you kept mentioning, I'm academia, I don't have to handle that, or I don't know about all the players in it. So like, if we actually want to build real useful products for the world, and you're in academia, but we need your knowledge, but you're not interested, so like, how do we bridge that gap, and what kind of collaboration can we do so we can build the good stuff that you've been studying all these years?
So that's a very good question. It's not that I'm not interested, it's that I haven't thought about it as much. You can come talk to me. I guess shamelessly, you can fund my research. I actually happen to like collaborating with people. I've had like 4 or 5 startups doing this stuff. So it's just a little harder on the spot on stage to give answers as a more general prescriptive thing. It's advice for particular problems is a different thing.
First of all, thank you for your talk. Best talk I've been to the whole day. Thank you so much.
Thank you.
I'm curious about something. I was curious about something you said at the beginning, kind of the premise of the whole situation, where you said that zero knowledge proofs aren't really zero knowledge because you know the hash.
ZKVMs aren't necessarily.
ZKVMs,
yes.
Right. I'm curious how much information really is in the hash, because you said, yes, you need to brute force. If you can brute force that hash, then the whole system break down because you can, no?
No, so think about this. If I have a Merkle tree with only 2 accounts in it, Alice, Bob, balance is 5, balance is 6. I do 1 payment, move it decrement 1, increment 1. I only have to try to guess a couple of different things about what that change was to figure it out. It's the same reason passwords aren't secure. It's not breaking hash functions in general.
But wouldn't you be composing the proofs of many more transactions than just 2?
Yeah, so this is a good question. It may be with enough data you don't run into that problem. You might run into others. This is more so like, look, if you hadn't thought about it, you should consider this. You can also fix it by like committing to the data and having randomness. I mean, that's what Zcash, that's what Zero Cash does. But naively, if you don't think about this and don't do it, you will run into problems like this.
Okay, thank you.
Let's see. It sounds like you guys can probably hear me. All right. Ooh, there it is. Now for something a little different. Good evening, everybody. I'm Piper Merriam. And this talk doesn't really need slides that much. I'm here to tell you a story. Those that know me best know this about me. I have a deep love of storytelling. You see, stories are everything. They're the glue that hold together this thing that we call reality. We tell ourselves stories about who we are, about what it all means. And we really want it to mean something, don't we? At this very moment, there are hundreds and hundreds of stories colliding and competing and passing clean through one another without either protagonist being the slightest bit aware of their insignificance. But I digress. I promised you a story, didn't I? The characters in this story are messy. They live in places where the water isn't safe to drink. Their dreams of children are met with miscarriages and disappointment. Their fathers drink themselves to death. Their partners toss them aside with indifference. Their daughters become sons. Their governments charge them with treason. Their brains betray them with depression, and panic attacks, and crippling social anxiety. The character that I play spends more time in pieces these days than he's comfortable with. His marriage failed this year. His windfall turned into tax liens and hundreds of thousands of dollars of debt. He has self-destructive coping mechanisms. He turned 40 this year. He goes to a lot of therapy and struggles to keep showing up to work and lead when the truth is that he feels lost most of the time. Struggling to keep things compartmentalized and walled off and separate. This is fine, he says, as the pieces of his life fall to pieces in the ground around him. I'm fine, he says, when all he can hear is the rattling of the bars as the feelings fight to be let free. It's fine, he says, as the community that loves him props him up day after day. But fine or not, there's a story to be told here. And the story of cryptocurrency is not mine. It doesn't belong to any of us, but it's one that I've had the honor to help write. It's a story written in math and human experience, straddling the predictable and reliable world of numbers, and the messy reality that I've been oversharing with you today. And in this story, at least the part that I'm telling, I am a superhero. I feel uncomfortable and self-conscious saying those words. How arrogant. But for real, the things I get to do and the stuff that I get to work on, the things that we get to work on, it's truly astounding when you step back and look at it. And then step back again, trillions of dollars sloshing around, 14-something million ether staked, blah, blah, blah. I think I have to say NFTs. I lied. I'm not really here to tell you a story. I am here to tell you about stories. When I said that stories are everything, I meant it. Stories propel us through our day-to-day. They're the chalk marks on the floor telling us where we came from in this labyrinth that we call life. And my job requires excellent storytelling. It's a craft I take with the utmost responsibility. The stories I tell have to be compelling and true and entertaining. There are a myriad of people who deserve an enormous amount of credit for coaxing Ethereum into existence. So I hesitate to draw such focused attention to a single individual, but we do love our heroes. We might not be here today without the story that Vitalik told us. So many people out there deal in these things called ideas, and idea merchants need not apply. Ideas are thin things, electricity surpassing some minimum threshold across a path of neurons in your mind. Ephemeral things, but stories have staying power. They are sticky things, infectious things. Ideas are nothing without a story to carry them, and stories are the incantations that we magicians use to summon ideas into existence out of thin air. A few years ago, I decided to tell a story. I called it the Core Developer Apprenticeship Program, and I told a story about what some people call a job or a career. I don't think those are exactly the right words. Identity, mission, purpose. Okay, it's a job, but it's a really cool job. I told them a story about getting paid to build what has the potential to be the most important tool humanity has ever imagined, and they believed me. They showed up in droves, hundreds and hundreds of them, hundreds and hundreds of messy people with messy lives. They showed up eager and ready to learn. What do you have to teach us, Piper? Absolutely nothing. This is not how it works. Go figure it out for yourself. No, there is not a roadmap. No, there is not any curriculum. No, we have not called it Serenity for a long time. No, I do not know how zero-knowledge proofs actually work. But they did it. Not all of them, but enough. Danny and I like to say that the doors are all unlocked and hilariously wide open, and I think a lot of people have trouble believing us. But all you have to do is look. These people walked through those doors one after another. Out of the rat race, away from OKRs and conversion funnels, away from larger salaries and stabler jobs, and away from the bullshit that I never, ever want to go back to. Stories are power, and power that I have learned how to wield. Unwieldy things that can slip through your fingers, things that can burn you when held too tightly or too close. I almost drowned a few years back. I told everybody a story about a new Ethereum client that would be lightweight, and line after line of code, months turned into years. The thing grew and metastasized. Wasn't this thing supposed to be lightweight? I watched as it pulls me deeper, water filling my lungs. I can't let go. My precious story that wasn't a lie, but would never become true. Of all of the things I was saved by a story about a monkey and a pedestal and dreams of the moon. So much time wasted and money to learn that I was telling the wrong story. Why do we have such a hard time letting go of the things that no longer serve us? A few years ago, I told another story that's called Stateless Ethereum. An epic journey fraught with peril, a story filled with swaths of blank pages yet to be written, a story with a chaotic beginning and a fairy tale ending and nothing but empty space between. A story that some of you seem to have believed was worth telling and that you continue to tell and that is still being written. Aya tells us stories about infinities and games. Danny told us a story about a bright beacon on the path towards a yet-to-be-realized dream. Alexei tells us stories about how we're doing it all wrong, and he's not entirely wrong. Parody told us stories of make-believe and fantasy that all turned out to be too good to be true. Nick tells us stories about the names of things, and Vitalik tells us story after story after story. And today you've listened to me say the word story 30 times or so without necessarily having a clear point to be made. What story are you going to tell? I did a talk like this a few DevCons back on the subject of depression. My hope was to help normalize some of the stigma around mental health issues that are prevalent in our industry and often invisible, and that I have personally struggled with. My goal this year was to do something similar for the more broad topic of the messy parts of our lives. There is immense social pressure to present a very well-manicured version of yourself. Fairy tales make for good bedtime stories, but when we tell them about our own lives, we deprive other people of the opportunity to really get to know us. I'm done with telling fairy tales. It's easy to feel like we are alone when everyone around us looks so well put together. My life is messy. I suspect some of you have your own messes. You at least don't have to hide them from me. Thank you.
Oh, test 1, 2, yes. Hi everyone, thank you very much for being here. It is the end of the day. I know you're looking forward to the happy hour, so I promise I'll be short. My name is Emilie Raffo. I'm the head of sales of Chain Security, and this is Tadeo, the core unit facilitator of MakerDAO Data Insights. He should find a shorter job title. So today we're going to be talking about statistics on MakerDAO vote delegation. And you might be wondering why me from Chain Security, so not from MakerDAO, why am I talking about this? So Chain Security, we're smart contract auditors, and we work with many large DeFi protocols, including MakerDAO, with whom we've had a very close partnership for quite some time. And as head of sales of Chain Security, I've had more and more to deal with DAOs and kind of go through a process that almost looks like an RFP, like a public tender to sell something to a state. And I was kind of wondering, what exactly is the difference? You know, when you talk to some people and it seems like a decision is made, and then, oh yeah, it's the DAO, but sometimes it doesn't feel that different. So I was kind of wondering, okay, how exactly is the community represented in those DAOs? And to look at that, Tadeo helped me a lot, because we looked at vote delegation in Maker. So that was introduced in the summer of 2021. And so what I wanted to do was to look, okay, since it's been introduced, what has changed? What were the effects of voting delegation? So just, you know, kind of some data to kind of put things in perspective. Holders of Maker tokens vote. 1 Maker token equals 1 vote. And there are approximately 1 million Maker tokens in circulation. And that has been the same in 2021 and 2022. So the whole period studied, let's say it's approximately 1 million Maker in circulation. All right, so you can vote as a Maker token holder, but the problem is that voting takes time and money. Hence, the introduction of delegation, basically allowing Maker token holders to entrust someone, a third party, with their voting power. So, meaning it's kind of like a politician in the end, you know, that you trust with your vote, you vote for them, and then they can take decisions for you. And they're going to be involved in this process, you know, of reading on the potential decisions, the potential changes that are going to be implemented. One thing that is kind of interesting is that, as opposed to a politician where you have a fixed term, 4 years or whatever, here you can undelegate at any point. So if at some point, so you as a delegator, you delegate your tokens, but you can undelegate at any point. So basically firing them, you know, if you want. And so there are 2 types of delegates. You have the shadow delegates, so it's permissionless, as if I was saying, all right, Tadeo, I know you know everything, you know, about Maker, I trust you to take decisions for me, and it's kind of just peer-to-peer between him and me. But there are also recognized delegates, which are monitored by the governance core units, and there we can see some information about them. And so this is an example of the 2 biggest delegates in MakerDAO. So here you can see, you know, how much they participate in votes, how much they communicate on the forums. You can see how much, you know, how many tokens are delegated to them, and so on. So there is kind of this transparency and this oversight from an authority that is the governance core unit. Okay, so now that we know what it is, let's look at, you know, kind of how it's impacted the community and the governance. Here we can see, so this is from beginning of the month, we can see that there were 115 delegates, and among these, 23 are recognized delegates. And what's very interesting, I find, is that almost 15% of all Maker tokens are delegated. So we can see that, you know, it has really had traction. It's not something that is just a small and on the side. But now what's interesting, in these 15%, what does it look like? You know, who delegates to who? And this is something that we can see, thanks to the amazing work of the data core unit. So here you can see on the left, this is the largest delegator. And you can see on the right who he delegated to. Why do I say he? Because probably it's Rune, the founder, right? And you can see here really who he delegated to. And what's very interesting is that he delegated to people that he knows and publicly supports, but he also delegated to people that he publicly disagrees with. He also delegated to university clubs, you know, blockchain university clubs. And so that's kind of one of the big points that I want to make in this presentation. Sometimes we think that the idea of delegation is that small token holders can kind of, you know, get together and become more powerful and so on. But actually one thing that we see most is that it's the opposite. It's huge, you know, it's whales who decentralize a bit of their power. And so we can see these are also like the other 5. These are also kind of big token holders. It's like Andreessen Horowitz and other kind of whales. And then we have not even 8K, not even 8,000 Maker tokens delegated from all the rest. So you can see that, you know, this is a much smaller, right, amount. And so all the rest delegates to all these delegates. So now that we know kind of the structure of delegation, we can look at Q2 2021, so which is the quarter right before delegation was introduced in the summer. So like in July, August 2021 it was introduced. And then we compare it here with Q2 2022, so 1 year later. And what is really interesting to me is that you have, in terms of the median poll participation, in terms of the number of maker tokens, you can see that there's an increase of 540%. So what does that mean? There are way more maker tokens which are put in, on average, in every vote. So that means it is way harder to commit a governance attack, So if you want to, I don't know, do something kind of shady with the protocol, to borrow tokens and kind of have this voting power to do something nefarious, well, it's much more difficult when there are 92,000 maker tokens than when there are 14 in a vote. So that's kind of the very interesting takeaway there. So takeaways. Whales delegate their MKR as a way to decentralize themselves. And we see, again, like I said before, a very significant increase in the number of maker tokens that are used in votes. And so now some questions that, I don't have time because it's a very short presentation. I think it's interesting to think about, okay, what is the optimal level of oversight, on these delegates? So the core unit that takes care of governance, how much should they monitor them and kind of have this relationship? Also, looking at the compensation of delegates, it's kind of interesting. If you have 10,000 maker delegated to you, so that's approximately almost $9 million, you have a yearly salary of $120,000 approximately. So that's a salary that you can live on, and so that's a cap. So is this an appropriate compensation? This is also, I think, a very interesting question. Another thing, so now we incentivize delegates, right? But should we maybe incentivize voters? Should we incentivize delegators? Maybe this would make sense. There is also something that we've seen, is that some whales delegate to themselves. And it's kind of funny to think, that you're going to get paid to delegate to yourself. But as we discussed, it's also some work that you do, even if it's for yourself. If you publish on the forum, if you do all this research, maybe this is also something that you should be compensated for, even if it's your own tokens. And finally, talking about whales decentralizing themselves, should we maybe lock those tokens in a delegation contract for a longer period of time, so that you cannot say, oh, I'm decentralizing myself, but the second you do not exactly what I want you to do, I take my tokens back. So maybe it could be interesting to create this type of options. So I just want to say a quick thanks to those who helped me. I focused here on Maker, but I also want to say thanks to the Compound team, to the Pull Together team, and to Reverie for helping me prepare this presentation. And of course, to Tadeo, who helped me and provided all the data. Thank you. And again, just a little reminder, I'm not from MakerDAO, I'm from Chain Security. We do smart contract audits for MakerDAO.
Hello. Do we have time for questions? Oh, yeah, anyone?
One question.
And in the meantime, the Sankey diagram is actually the work of Fernando from Go Alpha. But just want to give him a heads up. There's him. Anyone have a question? Over there? Okay.
Should we give you the mic?
Sorry, you said there was 24 official delegates and 92 unofficial delegates or something like that. How do the 92 become an official delegate? I guess that's the 120K compensation, right?
So in terms of the onboarding to become a recognized delegate, right now we're trying to keep it as easy as possible, and this is great work from Go Alpha and the governance teams. You have to have a call, you have to present a platform, present yourself, and basically have a public image. Again, it can be an anonymous person. That's totally okay on our side. But you basically need to have an open dialogue with the community. Something that was shown in one of the first screenshots coming from our voting portal. There, we actually, the compensations is managed by the performance. The performance is basically, is the delegate voting on all the polls and all the executives, and are they giving a reasoning for those votes?
Now I can do crowd work appropriately. All right. Hola, me llamo Andy, and that is all of the Spanish I know, unfortunately, which is surprising because I've used Duolingo. Anybody use Duolingo? But I used it a bunch, and I'm not at all fluent. Now, Duolingo boasts gamification. That's how they do what they do, right? And it certainly is fun, right? You get badges, you get experience, you level up. But it doesn't always do the best job at learning, at actual teaching. And so what I want to talk a little bit about is gamification and what that means in terms of composability in Web3 today. My background is I'm a former professor of games. I studied digital media effects for a variety of entertainment media and how the affordances of systems impacted player or user behavior. So yeah, I studied video games for 10 years. They gave me tenure, and then I left for crypto because, hey, we're all here, right? In my time in crypto, I worked for a number of protocols that you'll know, Status, Chainlink Labs. And last year, during the metaverse excitement and play-to-earn excitement and NFTs, what I noticed was that there was something missing. There was a lot of talk about gamification in terms of incentives and rewards and bonuses and experience points, but there wasn't a lot of talk about game mechanics and how those worked. There was a lot of hand-wringing about it, but not a ton. So I now founded a company called Infinity Keys. We are a project that tries to think about composability in Web3, especially on the EVM, and how we can make games with that. So quickly, right now, if you go to infinitykeys.io, you can see a number of different kinds of games that we have. They're mostly games where you have to solve a riddle, find a passcode, or go somewhere and find a passcode, or go collect an NFT. And this is kind of core to what I want to talk about in terms of composability. It's not finding a passcode and minting an NFT achievement. That's all that exciting. That's a piece of it. You can make fun games out of that. But what is interesting and exciting is when we take the NFT that you mint, a composable asset, and we require that in the next game. And then we give you a reward and an NFT for that, and then we require that in another game. And then we start interlacing those assets together and requiring them. And then the final sort of end state that we're trying to build at Infinity Keys, and that I want to encourage you all to build as well, is we allow anyone to lace those assets together. So developers and engineers, you know how to require composable assets, for gating and have them talk to each other. But average people don't know how to do that. Yet they still want to play games, and they still want to be able to design games in many cases. And so what I'm advocating for here is a new type of game, a game that relies on composable assets. I'm coining the term composability games. We'll see if it sticks. That allows anybody to do this sort of thing. And it's not just to make games and have people have good experiences. That is a part of it. That's a piece of it, and that's what we're doing right now. It's very fun, and you're supposed to have yay, I solved it, a good moment. That feels good. That's a nice experience to have with blockchain. But if you take a look at this, If you're familiar with complex systems or complex adaptive systems, how they work is you have a whole bunch of small components that interrelate as part of a system. And as they interrelate and as there's more of them, emergent phenomena start to happen. And I think that if we do this with NFTs and we start to connect them together, not just NFTs, but tokens, wallet signatures, all sorts of sort of composable elements that live on EVM, we'll start to see a new kind of, may I use the term metaverse. Metaverse isn't necessarily a 3D digital world. It does not have to be by any means. What I think is more interesting are deep digital worlds. Hey, everybody. Good to see the room. And when I talk about deep digital worlds, when you play a game, y'all play WoW? Anybody World of Warcrafters? I know there's a couple. Or Breath of the Wild? Anybody? Destiny? All right, I know I got some Destiny people in here. When you play one of these games, you go in, there's so much to do. It is an extremely rich and vibrant world because any town you walk into, there's 100 quests, and there's NPCs that tell you where to go. And then you go to the next town, and it's a different culture, and there's even more to do. A metaverse isn't just a plot of pixelated land that you can build things and put up a new sign, or even build games. It's a rich array of things to do. And you don't need 3D worlds to do that. What you need is a whole bunch of stuff to do. Composable assets let us do that if we connect them together using fun experiences called games. So this is what I'm building, we're building at Infinity Keys, and it's a piece of what you are all building as well. And so I really do think not only is it about composable assets, but it's about composable communities. I'm not going to talk about this too much because I do have limited time. Lightning talk, many things to say, not a lot of time to say it, but that's okay. Come on in, plenty of room. We're here. But kind of core to what I want to think about here that's different than just requiring one NFT to mint another NFT is we need to make good games and make good experiences. And that's something that we haven't been that concerned with because we've been making sure that the technology works, making sure that we can stake and those things are secure or can be secured if you use all the best practices, making sure that we do convert to proof of stake. Well done. Team, but now we can start thinking about user experience beyond just what's on the screen and what do they interact with, but what are the feelings that they have. Games are more than just a place to reward you with even more tokens. They're a place where you can help players have interesting emotional experiences. And that is, if you go to InfinityKeys.io and you solve some of our basic puzzles, they're easy, but you're like, all right, you feel good. You get that little kick. And that's enough in many cases. And those emotions are really, really powerful attractants as we bring more people into Web3 and into crypto economic systems. Right now, a lot of the emotional experiences that people have with crypto is number go up, which feels good, but is not sustainable, and number goes down, which is terrible and leaves a very long-lasting impression. The rest of us are here that figured out that curiosity. What else can we build? How do we improve systems with that? But most of the people that interact with crypto systems, that's what they deal with. Number go up, number go down. Games can change that. I really do think that. And not only can games change that, but by leaning into composable assets and permissionlessness of systems, we can open that and broaden that to further and further reaches. It doesn't have to be me creating games and a set of my NFTs. You can be a fan of a band and create trivia and reward NFTs for very cheap or free on layer 2s and rollups and all those sorts of things and make those a required asset for the next stage of your own hunt. I can make a hunt about Devcon where you have to go and collect POAPs from 5 different people. You got to collect one from Dave Hoffman and from Preston Van Loon, and you got to find Hudson. And now we've got a fun quest. And now we're using the composability of POAPs, which is a fantastic, really fun system that we've come to love. And now we can create layers on top of that. And then once you have that layer, we can create layers on top of that, et cetera, et cetera, et cetera. And by opening it up to community, we're creating stronger systems. I lost track of time, and so I'm getting cut off. So I will wrap up shortly, I promise. I think composability games will be something new. And this is a meta that we have missed thus far. Gaming, Web3 gaming has been about owning your assets, which means selling your assets, which is kind of boring. Maybe it's a value for some people, but it is far from the greatest value that we offer as a community of people building together. The value is the network. And so let's use the network to create value for people and their experiences. That's what we're doing at Infinity Keys. You can check us out. We have a number of live puzzles. We recently got a Lens grant, and so put up, I'm not going to read all this stuff, but we recently put up a Lens challenge where you have to go to different dApps on Lens, find passcodes, bring them back to mint a key, and then when you collect 3 keys, you can mint a treasure chest. It's all valueless free NFTs for fun. We're in alpha. But what we're starting to see is people coming into our community, starting to build their own puzzles and figure out how can we expand this world and use the assets that you've already created, that we created all last year ad nauseum. How can we put those together and more in the future to create a wider world of composability in gaming? There's treasure everywhere. This is a really important statement to me. It's not just the loot that you find. There's treasure in you, there's treasure in us and our ideas and the things that we can build together if we use systems that allow for composability and interconnection. That is my time. I'm happy to talk to anybody about games. I also love music or whatever. I'm around, I'm very tall, you can find me. Thank you very much for your time.
Okay. Hey, everyone. Feel free to come in over here. There's some seats on this side still. I'd say there's like 15 over there. So I'm Connor Spelsey, and I'm the founder of the DAO Research Collective. And at the DAO Research Collective, we fund, aggregate, and curate DAO research. We're a nonprofit. We also make that research searchable, and we make it freely and publicly available to everyone forever, as long as we continue to exist. So please jump on and check it out. A bit of my background. I'm really a crypto researcher. I focus on advocacy and DAOs. I've formerly started other nonprofits in the space, including the Blockchain Association and the Canadian Web3 Council. So a bit of advocacy, which also comes into play as we run the DAO Research Collective. The presentation today is about open sourcing information for the public goods. I think everyone here is probably sold on open sourcing information, so I will skip that part in favor of just talking about what we've done on the DAO side. It's only 7 minutes that we have here today, so if there are 2 things that you could take away from this, I'd love for you to think, firstly, if there's any way you want to be involved in what we do, please come reach out to me afterwards. And if you want to start your own research collective, be it in crypto or otherwise, I'd be very happy to chat about what we've done, which is what I'm going to focus on today. So how it all started? Well, really just all started because we realized crypto companies are spending way too much money on legal costs, and we were thinking, how can we make this more efficient? We started tweeting about it, had some phone calls, and then we formed a nonprofit. So as a former lawyer, I can let you in on a secret, which is that law firms charge crypto companies over and over again for the exact same legal advice. Now, some of you maybe have become aware of this, but a law firm will draft a memo on something like NFTs or securities, and then you as a client will approach them. They will adjust that memo 10 or 20%, and they'll sell it to you at the full price, and you'll be paying tens or hundreds of thousands of dollars. So obviously not really an efficient use of the community's money when we could be doing more collectively to take on that advice. So in chatting with more DAO stakeholders, we realized that this phenomenon doesn't really just apply in legal, of course, right? It also applies to so many other things in DAOs, treasury management, community, taxation. DAOs are very much, as I'm sure you're all aware, novel forms of organization, and there's very limited precedent to allow for DAO stakeholders to know how to operate efficiently. And so those stakeholders are now taking on a lot of responsibility and researching a ton of new things all by themselves. I know that a lot of DAOs have a lot of money, but they have very limited resources, and time is certainly very limited resources for that group. If they are doing research, that research is often siloed in that particular community. So the DAO community at large does not benefit from it. So what we are really focusing on is getting DAOs to pool that information at an early stage. So as a community, we can all rise up much more quickly. And we can do this in one of two ways, or a composition of the two ways, which is, if you're a DAO or if you've done research in the space, you can open source that research now, or you can pool capital and buy research collectively, which we can open source for the community to the benefit of all of us and to the big loss of the law firms. So an easy example here, right? You have a number of DAOs that want to come together to get information, for instance, on how to pay contributors. They can go to a law firm, Aave and Compound could go to a law firm separately, or they could come together, pool capital, and buy advice from that law firm. Now, there are some limitations here. Obviously, some information is very sensitive. It has to stay privileged and confidential, or some information has to be tailored specific to the DAO. But there is a ton of generic advice which we are constantly buying from these organizations, and the same applies not just to law firms, but also with respect to other research that we're buying really as a community. So in building the research collective, step one was really identifying the problem, right? We have a very limited amount of resources, and we want to make sure that we're spending those resources on getting for the DAO community what they need most. So in the summer of 2021, we hosted a virtual DAO summit with the Stanford Center for Blockchain Research and also Bankless. And really the focus of that summit was, what are the biggest issues in the space, and how can we contribute to improving the space as much as possible with our limited resources? We then followed up on those events with an IRL event at DevConnect, and then at the Stanford Blockchain Conference as well, to really get a list together of the things that are most important. This is really a very tiny sampling of it, but MetaGov in particular, an organization we work with, is currently building this incredible open problems in DAO science. I would guess you'd call it a paper, and I'd really highly recommend you all check it out. We're helping them out with that too. Step two, so you know the problems, you have to identify who is going to help you solve those problems, which is a much harder thing to solve for. So this is our list, a great list of fellows that we have. We were lucky enough to have a very strong network in crypto, but we realized we don't really have much of a network outside of crypto, particularly on the academic side, where we wanted to speak to a lot of experts in political science, in governance, in treasury management even, who come from different fields, but who would be really critical contributors to what we're doing in crypto. So we spent a lot of cycles reaching out to institutions. We became much closer with Stanford and others, and we now have a great group, many of whom participate actively in editing and also drafting research for us. Eventually, we also partnered with MetaGov and Scurf, two fabulous organizations which are crypto native, but much more deeply embedded in the academic spheres than we are. So curation and distribution, kind of the third step, we realized, okay, well, we can fund a lot of novel research, and that's great. Obviously, we have limited capacity for doing so, but there's also a lot of amazing research that's just out there already. So let's not duplicate it. We realized that something we had to do was build a platform that highlighted quality research that was already out there in the community, which people could check out and make it searchable, right? So that it didn't just disappear. What happens so often in crypto is that someone will publish something amazing, they'll put it on Twitter, it'll exist in our minds for a couple of weeks maybe, and then after that, we can't search it anymore. We don't know where it is. Someone writes the exact same article a month later, and the cycle continues with a lot of duplication and a lot of waste. To avoid that duplication, we set up this platform, which is searchable. We curate a list of resources that we think is really exceptional, and we've opened it up for the community. We've also written primers on kind of these core areas of functionality, like legal entity structure, advocacy, decentralization, etc. And it can give you a quick primer on the subject matter, and you can just double-click to dive deeper when you want to learn something more about a particular topic. So results. So results, how did it all work out? We're happy with how it's going so far. We can always improve, of course. Like, as a nonprofit, our thought is that our objective is really to help the community accelerate as quickly as possible. And so in order to do that, we obviously need to be interfacing with the community a lot to get a sense of what are the biggest problems for the community. And so we had an anonymous survey done fairly recently, and the results were a bit surprising. The second most common reason people use the DAO Research Collective was for research, was to avoid duplication of their own research when they were starting and looking into a new area that they hadn't previously focused on. But the most common reason they'd use it would actually be to find subject matter experts in particular fields. So we appreciate there's a huge talent issue in DAOs, where we are doing things like setting up very complex governance systems, often without any governance experts at the DAO, right? It could just be a collection of people, of operators, of developers who've done some research on governance, but they won't give you, for instance, as good of advice as Andy Hall, who's a professor at Stanford in governance and political science, who will just have a bit of a better sense of it. So we see that as a huge need and something we're going to need to focus on going forward, while also continuing to build out the platform. And that's it. So if you do have any questions about what we do, or if you'd like to contribute your research, or if you'd like to set up your own research collective, crypto or otherwise, I'm super happy to chat about it. So have a great conference, and thanks for coming, everyone.
Hey, Justin, if you want to come hang out over here. Right, ready when you are. Hello, everyone. How are you doing? GM. All right. So every DevCon, or maybe about every quarter, I send this tweet, which is, why are we here? What is the purpose of Web3? And I just like to see how the results change over time. It's kind of fun to see what the community's values are and what they think we're doing with this technology. And I kind of bucket the responses into the following categories. So the title of my talk is Ethereum is Punk. And I think the first category of punk that Ethereum is cypherpunk. So basically a cypherpunk is anyone who is advocating for strong privacy and cryptography, and especially sovereignty in their digital systems. And this serves as a route to social and political change, decentralizing power into the hands of the individual. Ethereum is cypherpunk. And if you want to know about the roots of the cypherpunk movement, you can read the Cypherpunk Manifesto, which is a canonical piece of text from Eric Hughes. It's really very prescient, considering it was written in the 90s. The second category of punk that I think is really interesting and has only really developed over the last couple years is this idea that Ethereum is solar punk. So solar punk, I think, is our alternative to doomerism. In a world with rising coordination failures like climate change, rising autocracy, misinformation, breakdown of the international order, we now have a transparent, immutable, programmable, and global structure for coordinating. We just need that key that unlocks the ability to build new institutions, humanity coordinating at web scale. And that is how Ethereum becomes solarpunk. So if we want to make Ethereum good for the world, first we have to do no harm. And I'm really proud of the merge and the fact that the network is nearly carbon neutral. I think we have a little bit of work to do to get rid of the rid of the scams on the network. But from there, we can use this programmable substrate to build better coordination hyperstructures that can do things like track carbon credits and start to solve climate change, but also can track impact on any other vector. So Ethereum is a coordination substrate that it gives us the ability to coordinate at web scale, and a lot of these problems can be framed as coordination failures. I also recommend that you read the Solarpunk Manifesto. This one's not nearly as influential as the Cypherpunk Manifesto, but there's a few different Solarpunk manifestos. Basically, Solarpunk is a movement in speculative fiction that imagines what the world would look like if we solved our contemporary problems around sustainability and coordination failure. So Solarpunk is an art movement that envisions how the humanity might look if we've succeeded in solving our major contemporary problems with coordination, with an emphasis on sustainability and things like climate change. Cypherpunk is the value system of sovereignty and privacy. And there's a blending of the two that has really been developing a lot over the last couple years. So Ethereum is punk, Ethereum is Solarpunk, Ethereum is Cypherpunk, and since these things are not mutually exclusive, Ethereum is also Lunarpunk. So Lunarpunk is regarded as the sibling aesthetic of the Solarpunk aesthetic, has more universal properties such as like witchcraft, futuristic design, nature, renewable energy. And you can kind of think of like it being Solarpunk with an emphasis on sovereignty and privacy, or Cypherpunk but with an emphasis on solving coordination failures, a middle ground between the two. Ethereum is Lunarpunk. And I would really encourage you, if you're looking for a canonical piece on Lunarpunk, to check out this video, Lunarpunk and the Dark Side of the Cycle, that went viral about a month ago. I think that Lunarpunk is good because it's solving coordination failures and it's blending our Cypherpunk values and our Lunarpunk values. There's another interesting alt of punk that I think that many in the room haven't heard of. I only know about it because I get tagged in every Twitter conversation about this stuff. And it's called Terrapunk. So basically the idea behind Terrapunk is taking Solarpunk and looking at the art and realizing that there's not a lot of humans in it. And basically, if you look at Solarpunk and you assume that we're going to solve our contemporary problems with coordination with it, then you're going to then are we going to do that in an accelerationist way where humanity continues to scale along with our economies, or are we going to do it in a way that assumes that 90% of humans aren't there? And so I don't necessarily agree with this interpretation of Solarpunk, but I do think that Terrapunk as a way of expressing Solarpunk, but with a more like high growth, high human way of doing Solarpunk is kind of interesting. I think that what I get from all of these different variants of punk and what I get back from the tweets that I sent out is that Ethereum is a mirror, and what we build on Ethereum is an expression of the programming capabilities of Ethereum, but also the mirror of our values looking back at us through these systems. So Ethereum is all of these things. Ethereum is a coordination technology, and it's all coordination. All of our human systems and meeting our shared needs involve the coordination between people in these systems. Ethereum is a Schelling point for the hopeful, a transparent, immutable, programmable global substrate for finance and coordination. And since we can program our values into our money, Ethereum is going to be a Schelling point for people who are creating new coordination systems. Using Web3, we can build new coordination mechanisms that leverage collective intelligence to solve some of humanity's most pressing coordination problems. Through my work at Gitcoin, which leverages quadratic funding, we have become an aqueduct for funding within the space, and we do $3 million worth of funding to the communities in the Web3 ecosystem using the magic coordination technology that is Ethereum, and also the quadratic funding mechanism that distributes value to communities. So far, Gitcoin has delivered $69 million worth of funding to our digital public goods. This graph is an expression of the community's preferences for what they're funding. So every edge in the network is a transaction, and every node is a grant or a user. And this is a mesh network of the preferences of the Ethereum community and which public goods they care about. So we're building coordination technologies to fund the public goods that we care about. Our vision at Gitcoin is to hopefully take ourselves to the quadratic lands, a place where we've rewritten the laws of economic gravity to support public goods and prevent coordination failures, and to do it in a privacy-preserving way. Ethereum is a mirror that reflects back to us our values, and this is our vision of where we want to go. You can kind of think of how much we're able to realize our values as a heuristic function in a fitness landscape, and we're executing the search space asynchronously and all together of finding the global maxima of how much we can realize our collective value realization using collective intelligence to allocate our commons resources. We were building hyperstructures, institutions in the ether that are able to meet our shared needs and are deployed on smart contract technology. And the sum of all of the hyperstructures out there they form a meta hyperstructure, which is a set of hyperstructures that all interoperate with each other in a modular way and help us to realize our shared values. So what I'm saying is Ethereum is cypherpunk, Ethereum is solarpunk, Ethereum is lunarpunk, Ethereum is also terrapunk. We are the ones who we've been waiting for, regardless of whether of these visions you believe in. So let's coordinate and let's build the world that we want. Thank you. All right, so I'm gonna take a little chance and we're gonna get a little weird. I invited my friend Justin Holmes up to the stage to sing a little song about coordination. Hey, Justin. Let's get a round of applause for Justin. What's that? Just hold the mic right here, please. Cool. All right.
Here. What mic are you gonna speak into?
Here, let's do 2 mics. Okay. All right. Can everyone hear us okay? Can you hear Justin's guitar okay? Cool. So I've known intellectually for quite a while that Ethereum is all about coordination. And I felt it in my bones that we have this programmable substrate for the ability to create, with our ability to create our shared needs. And I invited Justin to do this song with me because I want you to feel it, not just to think it. Ethereum is all about coordination. We are the ones that we've been waiting for. And I'm so thrilled to be here with you today, building this new world.
It's called coordination when we give each other lifts. Our improving situation is our most important gift. So this is going to sound a little weird, but lately I've been falling asleep to the sounds of air traffic control. I have the privilege of being a native English speaker, and most air traffic control is English. And I don't know if you've ever listened to air traffic control. It's a strange thing, but it's really quite an impressive feat of coordination around an extremely deadly possibility. And it dawned on me the other day that there are 2 obvious questions that arise from this. One, assuming we, on a medium time scale, deprecate the monopolistic violent coordination inherent in state imperialism, how are we going to do air traffic control? Literally air traffic control. Is anyone working on air traffic control on Ethereum? And the other, perhaps more obvious, is what are the lessons from those existing highly coordinated activities? Obviously, ATC is just one example that can inform us. We don't perhaps normally think of those as inspiration, but maybe we're kind of at a point where we're strong enough that it would be helpful. Maybe. Oh, it's called coordination when we give each other lift. Our improving situation is our most important gift.
All right, let's bring it down a little bit. I want to talk about someone who's been really inspirational for me and has been foundational in their contributions to the Ethereum community. They started ETH Research, and they created a blog post called Ethereum is a Game-Changing Technology way before I even discovered green pilling or coordination technology. And their name is Virgil Griffith. Virgil has been an inspiration to many of us in the protocol research side. He's been an inspiration to the Ethereum community, and he's now in jail for coordinating with the wrong people. And regardless of what you think of what he did and why he's in jail, I think that we can all agree that Virgil is an inspiration to all of us. And so Virgil, if you're listening to this, we miss you, brother. Thank you for seeding this vision of Ethereum as a game-changing technology, and I hope that we realize that vision together.
Well, it's called coordination when we give each other lift. Our improving situation is our most important gift. I spend most of my days working on threshold crypto and occasionally zero knowledge proofs. And I have for like 4 years now. And during that time, the solarpunk movement, and particularly an emphasis on coordination as a part of the gravity well of economic impact and computational impact of Ethereum has arisen. And it occurs to me that this is a good time to remind us that the cryptographic primitives that come from the ground, come from the mathematics, the inherent physics of the universe, are our birthright as information age beings. And they represent both a toolkit for coordination and also a reasoning for coordination. Oh, it's called coordination when we give each other lift. Our improving situation is our most enduring gift.
I guess what we're saying, the TLDR, is that Ethereum is what we make of it, so let's coordinate it to make it something good. Thank you. And another round of applause for our amazing mic stand right here. All right, so Justin, you're playing a show tonight, is that right?
It's true. At 7 o'clock on the Chiva Lounge on the first floor. You know, the Chiva Lounge is like where all the colorful flags are. 7 o'clock is coming right up, so I hope to see you all there for some blockchain bluegrass and video game traditionals.
Peace and love. Thank you. Thanks, that came out really well.